Okay, let's discuss variables and data types. And yes, variables and data types are typically the first topic you'll cover when learning a new language. Look in any programming book or programming tutorial. Starting at the bottom means starting at variables and data types. Really the most foundational topic in learning a language. We're going to start our coding journey in Python, learning about the concepts of variables and data types, and then how they are represented in Python. Let's go. Variables. What is a variable? A variable is a storage container, like a cell in a computer's memory, to hold data. Now, I say cell there because you can kind of conceptualize or make an analogy where variables are really storage cells in memory. And really what memory is in a computer is it's temporary storage, kind of like your own short-term memory maybe, where you can think about something, remember it, and then maybe a few days ago you can't remember it, but you can remember something same day, where it's like it's short-term memory. A variable is something stored in short-term memory, data in your computer's memory. But going back to this analogy, looking at these cells, let's say you have the number 3, the number 6, and the number, I don't know, 10. These would represent 3 different variables, being 3 different cells. And how variables work is that you would attach a name to each of these for identification. So this cell that contains 3, maybe you can call it X. The cell that contains 6, maybe you can call it num, because variable names can be you can use regular words, even though num is not a regular word. You can use words as variable names. But the concept is that a variable is a storage container in memory. So a simplified view of memory would be something like this: cell containing data, and then the names would be for identification, labeling, so that you could retrieve the data, because you can retrieve the data by referring to X or num, and then that will get you the data inside of that cell. Conceptual look at variables. And variables are labeled with names for identification called variable names. Like you just saw in that little visual that I did, the name it's kind of a pointer for identification to the data that is stored in that cell. And here's kind of a rehash. A variable can be likened to a cell in a spreadsheet with a name. And why variables? What are they used for? They allow for the storage and manipulation of data, as well as tracking changes throughout the program. A lot of coding is taking data in an initial state and doing things to it, doing operations on it, and then seeing what the outcome is at the end. Something simple like mathematical. You take an initial number and you put it through a formula where it goes through all kinds of translations, and then it outputs. And to be able to get it through all the transformations and still be able to refer to the same data, you store it in a variable so that we can identify it by name, so that we can pull it up by name when it is done with all those operations. So it's like a kind of a marker you put on it so that you can track its changes throughout the metamorphoses that it goes through. Now let's talk about looking at this in a graphical sense. And this is another view of the little drawing that I did. Here's a simplified view in memory of variables. Now, realistically, in memory, it's not exactly like this, but this is a good way to visualize, to conceptualize how variables might look in memory. You have cells and then you have individual pieces of data in those cells. And then you have variable names, X, Y, and Z, pointing to those. And remember, the variable names are for identification, so that when I refer to the variable X, I'm referring to the data within it that is 25, and so on and so forth, whatever that means. Let's talk about the concept of data types. Data types are categories of data, classifications, types of data. Types of data realistically and specifically are number data, text data, image data, audio data, video data. These are different kinds of data. And in a programming language, data types are the classifications specifically applied to those kinds of data. Data types are for identification and defining what operations can be performed on data. For instance, if you think about numeric data and you think about image data, what are operations that could be performed on numeric data? Things like add, subtract, multiply, divide. Think about the things that could be applied to images. Really some advanced stuff that I can't think of right now, but you can, let's say, a long story short, you cannot do the same operations with images that you can do with numbers. You can't add, subtract, multiply, divide typically an image, So numbers have a defined set of operations, and images have a defined set of operations, which I can't think of, which I guess I don't need to. But the classification is the beginning point of being able to define those operations. That's the point here. Next point is that variables are often referred to by the type of data that they contain. So going back to the concept of variables, and this is why data types and variables are interrelated, because variables are the storage containers for data, and data has types of data. So let's say you take a number and store it into a variable. That variable is a number variable. Well, what if you take text and store it in a variable? That is a text variable. That is the point here. Variables are referred to by the type of data that they contain. And programmers will talk about integer, string variables because of the type of data that they contain. Python is a little bit different than other traditional languages in that a Python variable can change its data type by having data of a different type assigned to it. This is called dynamic typing. In more traditional languages, variables have fixed data types, meaning you create a variable to store numeric data. It can only store numeric data for its entire lifetime. But in Python, variables are more general purpose in that you create a variable and you can store text data in it on one line, and later on you can delete that text data and store a number inside of it. So the kind of variable is determined by the data you put into it instead, where you could store any type of data in a single variable. So that is dynamic typing. Dynamic meaning its type is determined by what you have in it right now, and later on you can put a different type into it. Well, let's look at some of the basic data types specifically in Python, because we're here to learn Python, right? You almost forgot that, didn't you? All right. An integer, your basic number type from algebra. I'm sure you remember that either back in the day or maybe now. It's a whole number. It can be positive, negative, or zero. And here I'm going to show you how to create an integer variable in Python. And we talk about data types and variables being related. Here's a direct thing where taking our type of data and putting it into a variable. Here is simply how you would create it in Python code, and it is really this simple. On a single line of Python code, if you type x equals 34, what happens is this 34 is going to be placed into a memory location with the label x. So yes, the assignment happens from right to left, as shown with the arrow. And a graphical view of this would be here, where we have a cell in memory. You put a 34 inside of it, and then you have a label x that is pointing to that. And yes, we've placed a 34 into the variable with the name x, the storage container with the name x. Next data type is a float. Floats are decimal numbers. Integers are whole numbers, floats are decimal numbers. A decimal number meaning you have a whole number portion, a dot, and then a fractional portion. Here's how you create a float in Python. We use our same variable name x equals 34.4. And what this means, of course, is that the 34.4 is being placed into the variable x. Remember the right to left association. Next, string. The string is the foundational text data type in Python. So think of string as being text. A string is a string of text consisting of one or more text symbols. So one or more text symbols. So a string could be a single character of text. It could be an entire page of text. And I don't believe there is a limit on the amount of text that can be in a string. And the data that you put into a string is enclosed in quotes. And these quotes can be either single or double quotes. The quotes are how you specify that this data is going to be string data. It kind of says string. It's like, identify this as the string because of the quotes. I don't know if I said that right, but here is how it looks. Our same variable x equals, and then you have double quotes around the words hello world. Now this over here means that this hello world is going to be string text data, and this text data is going to be placed into a variable called x. Remember the association. And as stated here, it can be single or double quotes. Single and double quotes are interchangeable in Python for the most part. So I could have this with double as it is here, or I could have enclosed them as single and it would mean the same thing. Next one is Boolean. Booleans consist of two possible values, either true or false. Boolean data is only one of these two. And the word Boolean, if you haven't heard it before, it refers to Boolean logic, Boolean algebra, which is a branch of mathematics based on logic tests typically using the concepts of and, or, and not, logic tests that result in true or false. False, not false. Named after a mathematician named George Boole from the 19th century. And Boolean algebra is used in a variety of fields like computer science, engineering, circuit design, philosophy, logic, so many areas that Boolean logic is used for. And in programming, a lot of what you do in coding is going to be what are called tests for truth. Logic tests that result in a true or false, well, Boolean variables can hold the outcomes of these tests for truth. Where you do some test and it results in a true or false, you can store it in a Boolean variable and then access that variable later to find out what the result of the test was. Here's how you create a Boolean variable in Python. X equals false. The values can only be true or false, no quotes, and it has to be a capital first letter. Capital T true or capital F false. The last data type that I'll go over is actually a different kind of data type. I guess they're all different, but this is a basic data structure called a list. A list is a basic data structure. What is a data structure? A data structure is a collection or grouping of individual data items. Think of here's an analogy. Think of a physical cardboard box, where a physical cardboard box, when you place items into it, it is a collection of individual items, but it is in a group. And that's kind of what a data structure is in programming. And there's several different kinds of data structures in programming. A list in Python is the most foundational one in Python. But really foundationally, it is a collection of individual pieces put into a group. And here's how you would represent a list in Python. We're going to use our same variable x, and here the syntax is square brackets, and then you have individual numbers, integers, whole numbers, separated by commas. Now each of these is an individual piece of data, but they are grouped together to form a collection. And really, lists and data structures are useful for processing multiple pieces of data as a single unit and or running them through the same process in an automated manner. Very useful for efficiency in that vein. And you'll see a lot of data structures in your programming life. They're a foundational piece of all programming. Absolutely. Now, let's look at some rules for naming variables. Now, yeah, you have a lot of leeway in naming your variables, and going back to what a variable name is, it's a label or a name for the storage location that stores your data. And a tip on naming variables generally is that your variable name should be descriptive as to what the variable is being used for, because it makes your programs easier to read. Like, think of the idea of if you have a variable that's going to store the summation of several numbers, you can call the variable sum. And when you're reading that code, it's going to make it easier to understand what the variable is doing, what the code is doing, really. But here are some rules for naming variables. A variable name cannot be a reserved keyword. What is a reserved keyword? It's a word that's already in use by the Python language. And these words that are already in use typically will refer to language constructs that you use to compose, to do various operations. And here are some examples: for, while, if, def, and class. These are all words that are already used in Python syntax to do other operations, so you can't use them as variable names because they will confuse the interpreter. I do not list the full set of reserved keywords here because you can look it up online. If you just go to Google and type in reserved keywords Python, it'll bring up a list of about 20 or 30 words that you cannot use as variable names. So they are reserved for use by the language. Variable names can only contain letters, numbers, or underscores. So you can't use a lot of the funny symbols, or they call them special characters, in variable names. And the last bit is that variable names can only begin with a letter or an underscore. Only begin with a letter or underscore. They can only contain letters, numbers, and underscores. So by the inclusion of they can only begin with letters or underscores, you see that this excludes numbers. So it cannot, a variable name cannot begin with a number. So there you have it, folks. So those are your variable naming rules. Hello again, folks, and now we're going to take a look at the next module in this series, and this is Python input and output. And these functions are going to allow you to really communicate, the human, to communicate with a running program, where you'll be able to have the program talk to you via output from the program, and have you be able to enter data into a running program via a function called the input function. I think someone's got my throat here. Anyway, let's get in here. Let's dive in. We're going to look at the print function, which does the output in Python, and the input function, which does the input. The print function allows you to print output to your screen, the console, the terminal, whatever you call it on your system. And as this said, allow you to output text from your code to the console terminal. And I'll demonstrate it pretty soon. Here's how the print function works. It is the word print, parentheses, and then a string in quotes. Remember, the string data type, string data is specified by quotes around it. And what's going to happen when you run this line of code is that hello world is going to be printed on the screen. Just hello world by itself. Now with a print function, you can also print variable values with or without surrounding text, where here I'm creating a variable, setting it equal to 51. Remember variables in the last module? Hope you do. If you don't, go back and watch it. 51 is being placed into the variable x, and then I call the print function on x here, or using x. And what this means is when you refer to a variable in code, you're really referring to its value. So the print, this is going to print 51, not x, 51. I want to make that one clear. And a little more about printing. Using a comma in between the string data, like your hello world, and the variable, which would be something like x, using a comma in between those is a method to print them both together. So I could print text and data inside of a variable or from within a variable together, like this, where I have my literal string data, then I have a comma, and then I have a variable. What this is going to do is print the number is, and then whatever value is inside of x. And if this code was the code before it, it's going to print the number is 51. And I'm going to demo these in PyCharm right now. This is a good, I believe, first opportunity to take a look at some actual running code in Python. So check this one out, folks. I'm going to leave the slideshow real quick and let's take a look here. I'm in PyCharm, and you got the run button here at the top right. Almost said left. That's funny. And then you have the output area down here, down below. This is the console that I'm speaking of. When I say outputting into the console or terminal, in PyCharm, your IDE, this is going to be the output area, the console or terminal. And so, without further ado, and yeah, here's the code, as you can see. This is the area where you're going to edit the code. And on the top right, I hit the run. Oh, I ran the wrong thing. Oh, no second takes, folks. Here it is, hello world. So that is the output, and it's going to print whatever you put inside the quotes. Hello world, my brother, whatever it is. So there's your basic, this is kind of the most basic program that you could do, where you're just printing something on the screen. Going to the next example that I had, where I create a variable and I make it equal to, I made it equal to 51, but let's just do 41. You can print the value of that variable by putting in the name of the variable. So you use the name of the variable in print, and it'll print out the value. See down there, folks? 41. Big fat 41. Good, good, good. And then my next point was that if I wanted to print literal string data like text along with a variable value, I will separate them with a comma like this. I'll do my string and then close the quotes and do a comma, and then I'll have my variable on the other side of that comma. And what this is going to do, it's going to print them together on the same line. Oh, no it ain't. Live TV, folks. Made a mistake. I didn't define x. So I define x, and there we go. We have the value of x is comma x. And here you see x in the code is replaced with its value. Its value. All right, let's dive back into the slides. Next slide. Got that one. So I was telling you about printing string data with the variable using a comma. There's another and a better way. Another method to print variable and string data together is through the usage of what are called f-strings. An f-string is a way to format a string to allow for the inclusion of variable and literal strings together. And here is what it looks like. Sound like a newscaster, right? Here, y equals 49. It's creating a variable, and then have the print function, and then here is the activation of the f-string. You activate the f-string by placing a lowercase f in front of the first quote, and then you do your regular string. And here is also another difference, where instead of doing a comma in between the string data and the variable, you will instead create a set of curly braces and place your variable inside the curly braces. In this way, I don't have to break my quotes. I can have everything inside of the same set of quotes and include the variable inside of my literal string. And yeah, the f string is activated by the lowercase f and the curly braces around the variable. So this one is going to print, on my next birthday I will be 49, because 49 is the value of y. And this just says what I just did. F string is activated by placing a lowercase f before the quotes. And you can read the rest. I said the rest already, so it is what it is. And now that it is what it is, we're going to run this code in our IDE. Yes, yes, yes. I've got it in one of these. Yeah, here. I already got the code queued up. You see it just like it was in the slide, so I'm going to go ahead and run it. Oh, I did it again. I ran the wrong piece of code. That's why you get that. Running the right piece of code. On my next birthday, I will be 49. And you see, with the curly braces and the Y, it gets translated to 49. And that is how the F string works. Next slide. I'm saying next slide like I have somebody else controlling me, controlling it. It is only a one-person show here, folks, as you can readily tell. Now we're going to look at the input function. The input function enables you to input data into the program while it's running via a prompt. So yeah, input creates a prompt. It sits there and waits for the user to enter something, like type something from the keyboard, and then once they press enter, it's going to go into the running code. And here's how it looks. You create a variable and make it equal to input, and you're doing this because once someone inputs something, it is going to go into that variable. So it's like a combination of stuff going on here. The input function and then the parentheses. And inside the parentheses, this is going to be a prompt. Whoa. This is whatever you want your prompt to be. And a prompt is like it's like a question or a request to do something. So, and it's going to be a string. What's going to happen is when this first line of code is run, please state your name is going to show on the terminal or the console. It's just going to sit there and wait. Wait for you to enter some text. When text is entered, it's going to go into this variable, and then from here on, the name variable is going to hold whatever was entered. Like if I put in the name Dean, Dean is going to be inside of the name variable. And then on the next line, I print hello there. And then I have name, which is going to be whatever the name was entered. I'm using the comma format of printing a string and a variable together that you saw on a very recent previous slide. If you don't remember, rewind. Yeah, the input function creates a prompt, waits at the console for typed input. Once the enter key is pressed, the typed input goes into the variable. Let's take a gander at this one in actual code. Here it is, all queued up. My assistant did a good job today. And so when I run this one, Sandbox 5, let's run it. So I run it, and just like I said, the input function causes the please state your name to just sit there and wait. And you see you got the blinking cursor. What you do is you go down here and click your mouse in here to bring the focus to the terminal, and then you enter a name. I'm going to enter, I'll enter my own name. I will be honest here. And once I press enter, the program will continue to run and do whatever it's going to do. All that this program does is it has one more line where it says hello there and then the actual name that was entered. So I'm going to press enter. I'm going to smash the like button. And of course it says hello there, Dean. So, and Dean is inside of the name variable. Of course, variable gets translated to its containing value. All right, there's input. And give you a little more about input here. When you enter data into input, like you just saw me enter the name Dean, the data always comes in as a string. Like, I have the capability of entering numbers and pressing enter as well as text, but no matter what I enter, whether it's number or words or letters, it's going to come in as a string data type. But there may be cases where I will want to get numeric input and process that numeric input as a actual number, like an integer or a float. If I want to do that, I have to do a conversion function. And yes, the data can be converted from a string to another data type via conversion functions that are built into Python. So let's say I want to do like an addition program, like where I take in a couple of numbers and then I add them together. To be able to do that, I'm going to need to convert each number to an integer before I do the addition. And so here, I'm going to show you the conversion function, int. First line, we say, please enter a number. And the next line is the key line where I use the conversion function of int. Int is going to convert number to an integer, and it's going to put it back into the same variable. So on line number 1, it's a string. Number is a string. After line number 2, number is an integer. And then once it is an integer, I then do this stuff. And what this stuff is number times itself is, and I do a mathematical calculation on the number. This is multiplication, folks. I know you haven't seen this yet, but what it means is number times number. It's going to give me the multiplication of a number times itself. I would not be able to do this if this was a string. It would not have the proper outcome. Yeah, so the conversion matters. But this is really illustrating the fact that when you get input via the input function, it always comes in as a string. And I think I said that already. And I think that's the last portion. It is. So, I don't know my own slides, right? I'm going to now show you this in running mode in PyCharm. Let's take a look. Which one is it? Here it is. Here it is, the groove slightly transformed. Just a bit of a break from the norm. Summertime, right? It is summer, as you can see from my system clock. All right, please enter a number, and then I do the conversion, and then the number times itself is number times number. So of course, this is the variable value times itself. And so, let us run this file. I'll enter something large and in charge, 33. 1089, so that's 33 times 33, because it's number times number up here. All right, so there you have it. That is the end of this module. You've got to look at print and input, the major ways to do input and output on your system. And you will hear me in the next module. So stay tuned, and I will talk to you soon. See ya. checking out Python operators. And what operators are, they are the manipulators of data. They allow you to do stuff with data. We talked about variables and data types and looked at input and output. Of course, input and output, you're doing things with data, but the operators actually allow you to perform operations on the data, to do stuff, like I just said. So let's dive in here. There are 4 major types of operators in Python, and you're going to find these types of operators in most programming languages, if not all. Arithmetic, or arithmetic as it were, depending on which side of the pond you're on maybe. These are mathematical operations. Your add, subtract, multiply, divide, and a few other ones. Assignment. The assignment operators, well, you can assign values to variables and things, and there are also combination, assignment, and other operators. So we'll get into those. Comparison. These aid in the creation of Boolean expressions, and what Boolean expressions are, they're expressions that result in a true or false. And comparison is it's you could break it down simply and say, like, if you're looking at 2 quantities, is X larger than Y? Yes or no? That really translates to a true or false outcome. Like, the value of X is 5, the value of Y is 10. Is 5 larger than 10? No, it's not, so that's a false. Comparisons like that comprise the comparison operators. Logical. Logical allows you to create compound Boolean expressions. See, comparison, those operators allow you to create really singular Boolean expressions. The logical allows you to create compound Boolean expressions where you can really chain comparisons together. Like if X is greater than 10 and Y is less than 2, then you do something. And notice I included the if there because the comparison and logical operators typically are going to be involved in if, elif, and else statements, which are the control flow statements that we'll be getting into later on. Now we're going to cover each of these 4 in detail. Looking at arithmetic operators. The basic arithmetic operators are plus, minus, asterisk, and slash. And the last 2 here are of note. Of course, the first 2 are pretty simple. Add, subtract, or plus and minus, pretty simple. The asterisk is for multiplication. This is how multiplication is represented typically in programming. And the slash is the forward slash. You have the backslash, and you can tell the slash is by where is the top pointing to. If the top is leaning to the right, it is a forward slash. If the top is leaning to the left, it is a backslash. So the forward slash is for division. And you have a little code piece down here where we're assigning some values to variables. X equals 4, Y equals 5. And then here we have an actual expression involving an arithmetic operator, multiplication, y times x. The variable y, the value in it, times the value in y is being assigned to z. So z is going to hold 20 after this assignment, as this says. And then we have 25 divided by 5 using the division operator. So this is an example, or these are examples of the multiplication and division operators, arithmetic operators in action. Next, we're going to look at another arithmetic operator called the modulo operator. And this is an operator unique to programming, I believe. There is another arithmetic operator typically only seen in programming called the modulo operator. And the modulo operator uses the percent symbol. And it provides the remainder result of a division. You think about, interesting concept, you think about regular division, like, say 20 divided by 5. And what is that? Is that 4? Yeah, I think so. 20 divided by 5, you get a result. The modulo, denoted by the percent symbol, it gives you the remainder of a division. So if this were a modulo problem, 20 and 5, the remainder would actually be 0 because it divides evenly. 20 divided by 5, the division result is 4, but there is no remainder, so the remainder would be 0. Modulo is specified, the modulo operation is specified by the percent symbol, and it is going to be represented like this. If you're going to do modulo of two numbers, it's going to be first number, then in programming called the modulo operator, it's going to equal 0 because there is no remainder in this division. So the mental operation is you really do first number divided by second number, and if there is a remainder, that is the answer. So the modulo is the remainder result of a division. So there's another arithmetic operator. I keep saying it both ways, arithmetic, oh well, whatever. More examples. And again, here's how you write modulo or type modulo in coding. It's first number, percent symbol, second number, result. And so 10, and it is said modulo, so it's 10 modulo 6 equals 4. That's how it is said. 10 modulo 6 equals 4 because 10 divided by 6, the division is 1 with a remainder of 4. Another example, 43 modulo 5 is 3 because 43 divided by 5 is 8. Of course, it doesn't divide evenly, so there is a remainder of 3. So modulo is the remainder of a division. You may be asking, why the heck would you use modulo? What applicability does it have in regular programming? Modulo is typically used to determine even divisibility and to discern even numbers from odd numbers. So yeah, it comes up a lot where you have a quantity and you want to know if it's divisible by some number. Like I want to get I have a set of values, I want to get all values that are evenly divisible by 3 or 2 or whatever. And you could run them through a modulo operation to ensure that all the values, or to get all the values divisible by a certain number. Discerning even and odd numbers, pretty common operation, especially in the beginner arena, where you have a set of numbers. To programmatically determine if they're even or odd, you can do modulo, because really any number when divided by 2 that does not give a remainder is an even number. If you think about it, any even number divided by 2 divides evenly, so there is no remainder. Any odd number divided by 2, there will always be a remainder. So if there's a remainder when divided by 2, it is not even. And that's how you can determine. So you can use modulo in those scenarios. There are some other scenarios, but they're a little more advanced, and they will come up later in your programming life. But that is the modulo arithmetic operator. Another one. Getting into more specifically the division operators. So I told you the division operator is a forward slash. Well, there is another division operator with 2 forward slashes, and I'll tell you about it now. You just saw the one that has 1 slash, and there, yeah, one that has 2 slashes. The single slash operator actually does float division, which will do decimal division with a decimal result. The double slash one, which is the new one that I'm talking to you about, is for integer division. It's only going to give you a whole number. So there's your distinction. The 1 slash will result in a decimal result. The 2 slashes will result in an integer result. And the integer division is always going to round down. So if your typical result or your decimal or float result is going to be like 5.7, the integer will turn that into a 5. It's not going to round up, it will round down. So single slash, float, double slash, integer. Let's take a look here. There's a little code example. You have 45 divided by 7 with a single, 45 divided by 7 with a double, and here are your results. The first expression is going to give you the float, the decimal result, and the second expression is going to give you the whole number result. And again, it rounds down. Of course, this would round down no matter what, but if you had a number above 6.5, it will still round to 6 for those for the 2 slash result. And there we go. Another arithmetic operator. You can also perform exponentiation via the 2 asterisk operator. This allows you to do, as it is said, exponentiation, like raising numbers to powers, you know, like 3 squared, 4 cubed. Here we have x squared. That's how it translates into regular math. The 2 asterisks are raising to a power, x squared. So in this code snippet, we start with a 3. We raise it to the second power, or square. Then it results in a 9. So this is going to print a 9. And your raising power can be any integer. Maybe able to be a float too, I don't recall. But it'll raise it to that power. Alrighty, folks. Moving on. Now we'll get into the next class of operators called the assignment operators. The arithmetic was covered beautifully. Now we'll look at the assignment operators. The basic assignment operator is the equal sign. Just the equal sign, you know, x equals 3. There is your basic assignment, but there's more. And this will generally assign values to variables and some other things which we'll learn about later. But it's just a basic assignment. This equals this. Very straightforward. Now, the assignment, the way the assignment flows in programming is a little different than some other arenas. It is important to understand that the destination of the assignment is always on the left side of the equal sign, meaning the entity on the left is where the result is going to be stored, or where the assignment is going. And let's look at these examples where you have a bunch of equal signs, and for each of these expressions, the flow is going right to left. 22 is going to be stored in Y, 6 will be stored in Z, and the outcome of this expression is not important. The fact my point here is that it is going to be stored in X. So remember that right to left flow, or the destination of the assignment is always on the left. Let's go a step further with this. Python also has combination arithmetic and assignment operators where you're combining two worlds, really the last two that we've gone over, where you have plus equals, minus equals, times equals, I think it is said, division equals, and you even have modulo equals. And so what do these do? These operators will perform the math operation and then place the result in the variable on the left side of the equal sign. So really, as the name states, these are combination operators in that they will do the math operation and then store the result, assign the result to the item on the left side of the equal sign. Here's an example. You have here x equals 5, and then you have the plus equals, x plus equals 6. Now, the operation of the combination is going to be, it is going to do the addition, then the assignment. Therein lies the combination. It's going to do x plus 6, which in this case, x begins as a 5, 5 plus 6 equals 11. That is one operation. The next part of the operation is the assignment. The 11 is going to be assigned to x. There's the combination. The addition, then the assignment. Two operations. So each of these contain two operations. They will have the math operation, then the assignment operation. And the assignment operation, which is specified by the equals, is important for the storage. See, I talked about variables being storage locations. The result of the math operation is stored in the variable. So it's math operation and storage. And this code will result in the 11, in an 11 being printed. Yes, yes. Moving forward. Now on to the comparison operators. What do? They help create Boolean expressions. What is a Boolean expression? Boolean expressions, they're expressions that result in a true or false value. They can also be called tests for truth. So yeah, when you compare things, it results in a true or false value, and then you can use those true or false values to drive decisions in programming. And here are the comparison operators. You have the double equals, less than, not equal, greater than or equal to, greater than, and less than or equal to. And let me give you an example here, a comparison situation. A lot of times you're going to be comparing variables, like how does one variable compare to another? And that results in a true or false value. Let's say we have a variable x. Of course, I'm going to be using x and y a lot because they're simple names. And let's use less than or equal to. Here is a simple Boolean expression, and the way you say this is x less than or equal to y, and this is going to result in a true or false value. And so let's evaluate this for truth or falseness. And you really can't evaluate for truth or falseness unless you give the variable's values. So let's give them values. Let's say x equals 10 and y equals 4. Now that these have values, you can actually plug them in and evaluate this for truth or falseness. So if x is 10, we'll do is 10 less than or equal to 4. Is it less than or equal to 4? No, it's not. So that will result in a false. And I'll just denote it with an F. So this is an example of a Boolean expression, and you use these Boolean expressions in code to make decisions, really. Like, a lot of times it's going to be in the context of a statement called if or elif or else, or actually not else, but it'll say like if x is less than or equal to y, then maybe you do something, or maybe you don't do something. These create decision pathways in your code that you'll see here pretty soon in a few modules. But all of these are ways to compare values and variables to each other. Some things of note here: equals. Notice you have two equal signs here, and this is for comparison of equivalence, like does x equal y? The reason you're using two equal signs here is because the single equal sign is already being used. The single equal sign is being used for assignment. Remember, a couple of topics ago, actually the last topic, we have assignment where x equals y. It's assigning a value. Equal or comparison equals will compare. It's not assigning, it is saying does x equal y. So it's a different situation. If you're doing the double equals, it's a question rather than an assignment. And it's going to result in a true or false. But the double equals is for comparison, not assignment. Important to know for the young programmer, and important to remember. The not equals is exclamation equals, which means it's a comparison of not equals. So if the two quantities do not equal each other, then it'll result in a true. And those are your comparison operators. Now let's look at some examples of Boolean expressions. We assign two values. X is 5, y is 7. Then here we have a Boolean expression. Check it out. I put the Boolean expression in parentheses to really just separate it, but we have x double equals y. Here's that double equals. Remember I just said double equals is for comparison, so it's really it's asking the question. Whoops. Here we go. It's asking the question, does x equal y? And the answer is going to be true or false. And the answer is going to be placed in Z via assignment. So let's look at x is 5 and y is 7. These are two different values. They do not equal each other. So that's going to result in a false. So the false is going to be placed in Z. And then Z is going to print, or line 7 is going to print false. So that's one Boolean expression. Another example of a Boolean expression is on line 8, where we have 10 greater than 5. Again, this is asking the question, is 10 greater than 5? And it's true or false. 10, of course, is greater than 5, so that's true. Line 9, we have another Boolean expression. Hello not equal to goodbye. And again, it's a question. Is hello not equal to goodbye? That's true. It is not equal to goodbye because they're not the same. And this is, of course, a string comparison, and a string comparison compares for exact equivalence. So these two words are not equal. The characters are not the same. So that would be a true. And I'm printing all of these to get the output actually on the console. But as the graphic says, it'll be false, true, false. As you see, false, true, false. Yep. Now I'll take this opportunity to actually do a code example on this one. I have it pulled in PyCharm lately, so let's take a look here. Just code up another example really quickly. I know I said before to use descriptive variable names, but I'm using really nondescript variable names because I'm not actually creating an application, right? There's no real program here. So I'm using single letter variable names because, well, for simplicity. I can't be descriptive about nothing, right? Just show you the outcomes of a Boolean expression on the console. Here I'm comparing. That's funny. Here I'm comparing x and y, the values. 9, 19, and 11. Obviously, they're not the same. We are not the same, homie. So here we go. Of course, it's going to be a false. If I make them equivalent, now we got a true. Check it out. And let's do something like this. And let's actually make it greater than. 22 greater than 9 should be a true. And it's a true. Yeah. So that's how Boolean expressions work when you print them. And there we go. So now, let's move on, folks. Moving on to logical operators. The logical operators allow for the combination of Boolean expressions to produce more complex logic. So you just saw Boolean expressions in action a little bit. What logical operators allow you to do is to really combine them together to, as it says, produce more complex logic, really more complicated tests. The logical operators in Python are and, or, and not. And they are and, or, and not in most programming languages. It's just that in Python they are represented specifically as, character-wise, and, or, and not. So let's talk about and or. What do? And or are going to join two or more Boolean expressions. The difference is that the and is going to result in a true outcome if all of the combined tests are true. The or is going to result in true if at least one test is true. Just one, so it's very inclusive. And as I was saying, these combine, the logical operators combine two or more Boolean expressions together. Boolean expression is a true or false. When you chain them together with logical operators, they still result in true or false. But the outcome is determined by the logical operators you use in between the Boolean expressions. If you use and in between, the results are going to be true if all the tests are true, like if the individual ones are true. Or is only one's got to be true. And let's look at some examples here. Here we go. You ready to go this? You ready to go, folks? Yeah. Okay. I can hear the crowd roar. Line 4, assigning 4 to x. Then on line 6, this is a Boolean expression using a logical operator. And as I was saying, it's going to combine 2 or more Boolean expressions together to produce more complex logic. Well, here we have one Boolean expression, then we have another Boolean expression. That's 2. They are joined together with and the logical operator. So there it is in action. Let's see what the outcome is. As I said before, the and is going to produce a true if all of the tests are true, all of the individual tests are true. So let's look at them. X greater than or equal to 0. Is that true? X is 4. Is 4 greater than or equal to 0? Yeah, that is a true. Then let's look at the other test. X less than 10. Is 4 less than 10? That is a true. And so then let's look at the and. The and says it results in a true if all of the tests are true. Are all the tests true? They are. So this whole thing will result in a true. And it's going to be placed in y. So y will hold a true. Awesome how that works. Let's look at another example on line 10. Line 10, we have z equals 5. And then on line 12, we have another Boolean expression down here. This time using or. But when you look at the Boolean expression involving logical operators, you look at the individual tests. So let's take a look here. Z greater than 10. Is z greater than 10? 5 greater than 10? No, it is not. Let's look at z greater than 1. Is z greater than 1? Is 5 greater than 1? It is. So we have a false and a true. Then we look to the middle to our or. Or says that only one test has to be true for the whole thing to be true. So it'll be a true because you have one true in here. You have one true, one false. So overall, it is true. And this looks like an I, actually. And as this states, first one will be true, and the second one will be true. Good. All right. I feel like we should take a minute to look at one of these in PyCharm. If I can pull it up here. And we'll just use these values again. Yeah, let's just make it simple. We'll use the values that are already here. I'm going to use parentheses to separate, to ensure that the operations inside the parentheses happen before the operations outside. And when you put I didn't say this explicitly before, when you put a Boolean expression involving logical operators or not inside of a print statement, it's going to print a true or false value. But you've probably already seen that through context. Okay, like I was saying before, when you evaluate an expression like this, you look at left side, or no, you look at one expression, then the other expression, and then you look at the operation in the middle, at least for this simple situation. X greater than y. Is x greater than y? 22 is greater than 19, so that's a yes. That's a true. X equals y. It does not equal y, so that's a false. So we have a true and a false. But we have an or. Or says that if there are any trues, then the whole thing is true. So we run this, we will get, once again, a true. Excellent, excellent. So there is a Boolean expression involving logical operators in action. Pretty simple idea there, though. Yeah. All right, let's move a little bit and take a look at the not. So we looked at and or. The not is a little bit different, so I covered it by itself. The not is going to result in the opposite of the expression that follows it. Typically, you're going to place it in front of something, and it is called, termed negation, where it's like it's going to negate the thing or the expression that comes after it. If you look here with this little code example, we assign 7 to x, so x equals 7. Line 6. Then we have a not in front of a Boolean expression. X greater than 1. The way to evaluate Boolean expressions is to really break them down like thing by thing. So let's look at the right side of the expression first, just x greater than 1. Is x greater than 1? Is 7 greater than 1? That's true. 7 is greater than 1. Now we'll apply the not to it. Looking at not is negation. What not is actually going to do is not is going to take the result and make it the opposite of its outcome. So the true will turn to a false. That's what not does. Not will make the outcome the opposite of what comes after it. And as stated in the bullet below, the code's going to print false because x is greater than 1. It is true, but the not switches it to false. So get that term in your head, negation. It takes what is there and flips it to the other side. It's like whatever position the light switch is on, it flips it to the other position. If it's on, it's off. If it's off, it's on. That is what not does. And here, folks, here are some logic tables that kind of help you understand the and, or, and not operations conceptually, as it is said. And let's term zeros as false and ones as true, and then you can read these tables effectively. Let's look at A and B as Boolean expressions, and then the subject of the table would be in between the two expressions. So if we have Boolean expression A and Boolean expression B, if the outcome of expression A is false and the outcome of expression B is false, then it results in a false when you apply it to and. Because you recall, and all tests have to be true for it to be true. So it's only going to result in a true if it has true inputs, or two true inputs. So that's how this table works. Looking over at the or, it's more inclusive because only one has to be true for the outcome to be true. And then when you look at the not, it's simple negation. It's whatever the input is, the opposite is output. One way in, flip it on the output. And folks, this concludes the talk on operators. Pretty long, but pretty necessary. Operators are a huge part of programming, and you'll use them in every program you write probably from here on out. So, with that, I'm out. See you in the next module. Now let's discuss Python control flow. Control flow is where things really get interesting, where it'll allow for separate pathways of execution through decision statements, automation through looping, and the control of loops through loop control. Control flow is rested in 3 separate areas, and there are 3 categories of control flow statements. The first category is conditional and decision statements. If, elif, and else. These allow you to create separate pathways of execution based on the outcome of Boolean expressions. We discussed Boolean expressions in a previous module, and these are expressions that result in a true or false outcome. Well, these conditional decision statements allow you to conditionally execute based on the outcome of those Boolean expressions. Next, we have looping statements, and loops really allow for automation in your code. You can really, based on a condition, you can execute something a certain number of times or while a condition is true. But the real takeaway is automation. It's kind of, you can set something up, set a set of tasks up, and have them execute over and over again. There's a lot of power to be gained there. Next are loop control statements of break and continue. These allow you to alter the execution of loops. So loops are set to run a certain way. The break and continue, you can alter the execution based on certain conditions. Notice I keep saying conditions over and over again. So much in programming is based on condition. Really, all 3 of these are conditional statements, looping statements, and loop control. They all end up being based on conditions, and you'll see as we move forward. Next, we will discuss specifically the conditional and decision statements of if, elif, and else. Conditional and decision statements. As I promised, if, elif, and else. Let's dive in here. So let's define the idea of conditional/decision statements. And I use both of these words, these terms, because you will see both of them used sometimes separately to describe this same thing. Sometimes they're called conditional, sometimes they're called decision, but they really mean the same thing. It is really conditionally executing code based on the outcome of a Boolean expression. And here defined, conditional statements, they create separate pathways of execution based on the outcome of Boolean expressions. And they do consist of the if, elif, and else statements. So speaking structurally and syntactically, these statements consist of a header, that's going to be the beginning statement, and then a body which will contain the code to execute. The body must be indented below the header, and the body contains the action or actions to be performed if the expression is true, the Boolean expression. Now we're going to take a look syntactically at how the header and body look in these if, elif, and else statements. Follow me now. Okay, here is a look at an example of an if statement, and not really focusing on syntax so much as structure. Here we're going to look at the structure where we have if x equal to. This right here, this is a Boolean expression. And you saw these in a previous module where you have a variable x, you have two equal signs, and then you have a literal number 2. And remember, the two equal signs means comparison. So we're comparing the x to 2. And then this is the header, and then here is the body of the statement. And if the conditional or if the Boolean expression is true, then the body is executed. But speaking more structurally than syntactically, we have here the header. The header is the first line of your if, elif, or else statements. And we'll look at elif and else pretty soon. This is an if statement. The header contains your beginning statement, whether it be if or elif, then your Boolean expression, and then they always contain a colon at the end of the header. And this colon really specifies that the header is ending and the body is beginning. Of course, down here is the body. And right on cue, there's the body. The body is indented below the header. And you see the header up here. The body is going to be, you see, indented. You see it's moved in to the right. The body has to be indented below the header. This is a Python syntax rule in that if you do not indent below the header of an if statement or an elif or an else, these are syntax errors. And again, syntax meaning the rules of the language. That's the header and the body. And now we can dive into specifically what if, elif, and else mean by defining them. Let's go. So when you have an if statement, it's going to perform an action based on the outcome of a Boolean expression. And you saw in the previous slide where you have if, then you have a Boolean expression. It's just saying, yeah, if this is true, then execute the stuff that's below in the body. Elif is a little bit different than the if, and an elif will appear below an if structurally. It'll be, here's like a little mock-up where you'll have an if, then you have a expression, then a body, and then an elif would appear below it, and then it'll have an expression, and then it'll have a body. You have if and then elif. This kind of block is always going to begin with the if, and an elif or many elifs could be below it. That's how it's set up. And so let's look now at the definition. It says, if the expression above the elif is false and the expression next to elif is true, perform this action instead. It kind of runs contrary to the thing or things that are above it. See, an elif, it may have a single if above it, or it may have other elifs above it and also an if. And really, it is saying if all of the things or the thing above it is false and the statement next to it is true, perform this action instead. And when I say this action, I mean the stuff in the body of this elif. So if we're looking at this particular elif right here, it's if the above is false and the statement next to elif is true, perform those actions instead. So it runs contrary. So if you break it down very simply, it's if you have just two statements, so where you have an if and you have an elif below it, it's saying if the if is false, its condition is false, and the condition next to elif is true, execute the elif instead. And finally, we have the else. The else is going to appear at the bottom of one of these blocks, and it's going to say if all of the expressions above are false, perform this action instead. The elif is kind of a catch-all or default statement where if everything in the previous sections are false, then you're going to perform the actions according to the else. See, the else will never have a condition next to it because it really means anything else. So if and elif will have a Boolean expression next to them, else will not have a Boolean expression next to it. Else will it'll just be else and then a colon. And then it'll have a body below it, which will have statements to execute, but else will never have an expression next to it. And you'll see it syntactically when we look at the code. Let's look at some quick rules, then we'll dive into looking at some code on these statements. Some rules regarding these statements. The if is the only required piece of the block. And when I say this block, these statements typically appear where it is like if, elif, and else, or it could be an if and several elifs and an else, or it could be an if and an else, or it could be an else, or it could be an if by itself. Hopefully that wasn't too confusing. But the if is the only required piece, meaning that you can construct an if by itself, where you simply have an if and then a Boolean expression and then a body. You can do that and it's fine. It's the only required piece. You can optionally include elif or else or both. Speaking of elifs, you can have an unlimited number of elifs. So you could have one if and a bunch of elifs, and then you could have an else. And you would use a lot of elifs. I'm thinking my color coding is messed up here, but oh well. You would want a number of elifs if you have several conditions to test. And if you want to do a separate action based on each condition, you'll have a bunch of elifs. And you'll see some code pretty soon where I utilize this idea. And also, elif is short for else if. In other languages, else if is actually spelled out, but elif is short for else if. Didn't say that earlier. And it's kind of a funny looking word. If you like, what is elif? It is short for else if. It is a shortening, condensing of those two words. Got a cauldron going over there. You cannot have an elif or else without an if. An if always begins this block. So it's if and then whatever else you got, but you will never begin a block with an elif or an else. They are dependent on the if. And the else is always at the end if it is used, because an else is optional, but if you use it, it's going to be at the end of one of these blocks because it means anything else. So it's a catch-all at the end. And now, my friends, we'll dive into looking at some code utilizing these and to illustrate the rules. Alrighty, looking at this one, we are utilizing the input function that we covered in a previous module to demonstrate the if a basic if, elif, and else setup. So on line 4, we have please enter a number, creating a prompt. And then on line 5, we do the integer conversion because we're going to take x and we're going to manipulate it as a number. So we're going to want to convert it to an integer so that we can do things to it as a number instead of a string. Because you remember when you get input, it comes in as a string. And then here is the meat of the situation, so to speak, where we have our if, elif, and else. So we look at the if structurally, and I keep saying that structurally and syntactically here. You have an if, and then we have a Boolean expression. X less than 7. We are comparing x to 7. Is x less than 7? The if says, if this is true, we will execute the body. The body is simply a print statement that says x is less than 7. So if this is true, this is going to be executed. That's how if works. So that's how if works. Let's look at how the rest of the statements work. If the if, interesting way to say it, right? If the if happens to be false, like if x is not less than 7, we go to the next statement. We go down the chain, so to speak. We go to the elif. And that's how these work, where I was saying before, defining the elif, if the statement above is false and this is true, do this instead. So looking at the elif, we've fallen down to the elif. If the if is false, we go to the elif and say, it's like saying otherwise. If x is greater than 7, print x is greater than 7. And then if the elif is not true, we come down to the else. And as I was saying before with the else, you will not, there's no condition next to it. There's nothing there. It's just else and then a colon. And then what you execute if you get here, basically. So there's a fall through mechanism with if, elif, and else. It's, is this true? No. And is this true? No. And then you go down to the else. So if the elif is not true, then we go down to the else and do x equals 7. And else here being a catch-all. And if you think about the possible conditions here, you have x being less than 7, x being greater than 7, and if a number is not, or if a variable is not less than 7 or greater than 7, it equals 7. So else catches the only other possible condition, which is x equaling 7. Now I got to take this into PyCharm and run the sucker and see. Very good to see this in real execution. So here it is in code, and let's run it and supply some values here. Make sure this thing works, because you can look at it in theory, and you always want to run your code, obviously, right? So we have please enter a number. I want to equal the number. I'm going to enter the number 7. And right away, x equals 7. So we see what happened here is that I entered a 7, and how the execution works is it goes down the line. It's x is 7, so is x less than 7? No, it's not. Then it gets here. Is x greater than 7? No, it's not. So it enters this one, and that's why we get x equals 7. Let's enter one more thing here. Let's enter a number, let's say -4, because you can do that. I enter a -4, x is less than 7. So when x equals -4, of course it is less than 7. And how the flow worked is that it got here, and here x was -4. -4 is less than 7, so it prints out x is less than 7. So this is how conditional statements work. It's comparing, doing the comparison with the Boolean expression, and based on the truth or falseness, it's going to conditionally execute. Like, is it true? Then it executes. If it's false, then it goes down to the next statement until it gets to the else. That is how these work. Now I'll go over another example in slides. Yes, we don't stop here. Here's one that's concerning numeric grades and sort of converting them to letter grades. Again, utilizing the input function. All right, we have number grade equals input, and you're being prompted to enter a number grade. Then we once again do the integer conversion, because we're going to do comparisons based on the numeric value, converting the string that is input into an integer. Then we have a block here of if, elif, and else statements. Notice the multiple elifs. I said a few minutes ago that you can have an unlimited number of elifs, and I said that you would use multiple elifs if you had separate conditions to test, and you wanted to do something different for each condition. That is exactly what we have here. So once we get our input and it's converted to a number, we go down to the if, elif, and else statements. Yeah, so getting in here, we have if the number grade is greater than or equal to 90, you receive an A. You print, you received an A. And that would be right, because yeah, if you enter a 95 and then you get here greater than or equal to 90, you received an A. Then we have elifs for the next three, where it's greater than or equal to 80, B, greater than or equal to 70, a C, greater than or equal to 60, a D, and then the else will be you failed. Let's think about the condition for the else. What's covered up here is really 60 or greater. So the else would be, really it's going to be less than 60. It's going to be that you failed. That's what it's going to be. And really with the elifs, you create ranges of the possibilities, because looking at this, this is greater than or equal to 80, but because of the sequential nature of execution, another way to look at this condition would be, it would actually be 80 to 89 would be the actual range that's caught here, because the first, or the if handles greater than or equal to 90. So this ends at 90. And then this says greater than or equal to 80, but you are only going to get here if the if is not true. So if the if is not true, it means that your number grade is going to be less than 90. So getting down here less than 90, it would be 89 and less. And this is going to be pursued if it's between 89 and 80, or 80 and 89, depending on which direction you want to say it. So it kind of creates a logical range here, and really each of these do. So what I'm really giving you is a different way to interpret it other than what is shown here. because really these do create ranges where this one will be 70 to 79, and then 60 to 69, and then less than 60. Just another way to look at it. Well, I want to give you a little bit extra, sprinkle a little bit on you. That sounds weird, right? Okay. All right. I think that's an explanation here, and that wraps up conditional and decision statements. And that's it for me. See you in the next module. Okay, now we're going to discuss looping. Looping, my friends. And what is looping in programming in Python? Let's explain it. Looping, or loops, in code allow for automation. Loops allow for the repeating of tasks until a certain outcome is reached. Really, it is a way to set up a task or a set of tasks and run them over and over again until some stopping point, usually based on a condition. Like a lot of things in programming, it is based on many times a Boolean expression becoming true or false. There's that term again. And in Python, there are two main types of loops, the for loop and the while loop. And we're going to cover some ideas on each and define each here in the next few slides. You like that? I do too. Now let's look at the for loop. And within the category of for loops, there are two main kinds of for loops: the for each loop and the for range loop. And really, for each and for range, these are names that I've given these loops, but you will see others using these names as well because they're good identification names for them. They're not officially called for each and for range, but once you see them and once you use them, you'll probably call them these as well. But these are not official names, but it's kind of good to attach these kind of nicknames to them for identification. I don't know if they have official names actually. Anyway, let's look at each of these now. Two kinds of for loops. The for each loop is designed to access each item in a data structure like a list. This is the kind of loop you want to use if you want to go through a data structure and process each item, usually sequentially. And remember, a data structure is basically, you can think of it as a list containing individual items. The for each loop allows you to go through and access each one of those items one by one and usually do something to them. It could be as simple as printing each one out, or it could be running each of them through some mathematical formula or some function. Whatever you want to do, you can access them one by one. But the for each loop is designed to go through something like a list and process each item one by one. The for range loop is designed simply to run a certain number of times. And that is an oversimplification, but early on when learning this is a good identification, a good way of identification for this kind of loop. It's just, we're going to set it up to run a certain number of times, and it's going to do this task over and over again until the number of times runs out. And later on in the course, you'll find out more about the for range, but keep it simple for now and just think about it as running a certain number of times. So yeah, these are, with these two for loops, two different ways of automation, basically. And that's the term you should get in your mind as far as looping. Looping equals automation. Task over and over again, or a set of tasks over and over again. Now let's look at each one. Examples. Here is an example of the for each loop. Now, as I said, the for each loop is designed to go through a data structure like a list. And it can also go through strings and dictionaries that you haven't heard about yet and other data structures, but you've only learned about the list so far, so we will lock it into the context of a list. Here we have a list named Wu-Tang, and it is a list of strings. See your list enclosure, and then you have strings separated by commas. Of course, these are individual strings in a group forming a list. And for those who don't know, these are the names of 3 of the members of the Wu-Tang Clan, the hip-hop group from the 1990s up to today. So look it up if you don't know. All right, this is what we're here to talk about, the for each loop. Here is the syntax. The word for, and then you have member in Wu-Tang. Wu-Tang is the name of the list that you're going through. And so whatever list you're going through will be in this slot, basically. So if your list is named Wu-Tang, it's going to be here. If your list is named test list, it's going to be here. Whatever the name of your list is going to be put here in this slot. The word for is always there because this is a for loop, of course. Member, this is of note. Member, it is a variable. Really, it is a temporary variable. And its purpose is to hold each one of the elements, each one of the individual items as you go through the list one by one. And I say it's a temporary variable because it is created on the spot when you put this into the for loop header. And its name can be any valid variable name of the programmer's choosing. The programmer decides what the name is. I decided to call it member because the Wu-Tang Clan, being a rap group, has members. So for member in Wu-Tang. It kind of makes sense. I could have called it anything. I could have called it X. I could have called it Y. I could have called it Dean. But would it make sense to say for Dean in Wu-Tang? It just makes it a little easier to read. But it could be anything. So what it's going to be is it's going to hold each member as you loop through. And going back to the definition of the for each loop, it's going to process one item at a time as you go through the loop. So on the first turn, it's going to process this first item, Jizza, then it's going to process Reza, then ODB, one for each turn. That's what it's going to do. Move some of this stuff out of here. And looking at this portion, the in is a required piece of the syntax. So for and in are required pieces of the syntax, and the pieces of the syntax that are up to the programmer are going to be this variable right now called member, and this variable right now called Wu-Tang. And of course, Wu-Tang is going to be the list, and member is going to be the variable. So it's like the format is for variable in list. That's kind of how you can think of it. And this first line comprises the header of the loop. Almost said list. This is the header, and if you remember the if and elif headers, or actually really if, elif, and else, those headers, they ended with a colon. This one is no different, of course, and this is going to be a running theme in Python where the headers of code blocks will end with a colon. So this ends with a colon, and as I said before, the colon begins the body, so the body is down below here, and the body is indented as I talked about before. I guess we didn't talk because you're not talking. I'm the only one talking, right? But anyway, the body is indented, and the things in the body are going to be executed for each turn of the loop. And you think of a loop as like a literal loop, like it goes around and around, and then it goes around again. That's kind of the flow of the loop, where each go around, each looping, it's going to process one of these items. On the first looping, it is going to process jizza. So member will be inside of jizza. Actually, that's the other way around. Jizza will be inside of member. Member will contain it, and then it'll print jizza on the first go around. Then it loops around again. Jizza is overwritten, and it'll process rizza. And I'm not going to rat all these out, but it'll print rizza on the next go around. Then it's going to be overwritten, and then it'll print ODB on the next round. So it's one at a time through the list. But that's the concept of the loop. It's going to do the set of tasks that's in the body. It's going to do it once for every turn of the loop. And as stated, it will print jizza, rizza, and ODB on separate lines. There we go. And of course, you knew I was going to do this. I am going to pop this into PyCharm to show you what it looks like in sort of real time. Because I could say live, but you are not here live with me. This is pre-recorded, of course. Of course, you do have the capability of being live with me. I do offer live one-on-one and group appointments, so yeah, you can text me if you need real-time instruction. Okay, folks, this is the exact same text or code that is in the slide. As I say all the time, let's run this sucker. See how it goes. And I gotta run the right one. Okay, as I said, rizza, jizza, ODB on separate lines. And see, for each turn, it's going to print one of them. So, and it processes the list in order, sequentially. There we go with that. And there is your for each loop. For item in list or for variable in list. There it is. Now let's look at the next kind of for loop. The for range loop. And to redefine this one really quickly, it is a loop that is going to run, is going to be set to run a certain number of times. That's this simplistic or the simplified form of defining this loop. Here's your syntax. For I in range. And then you have a number. Here you have a 10 inside. And the format is similar to the last for loop in that at the end you have a colon, and you start with 4, and then you have the n. These are kind of the required pieces. And then another required piece with this one is the range keyword. And in the parentheses of range, you're going to put the number of times this is really the number of times that you're going to loop. In this in this loop, I is a variable, kind of like member was a variable before, but here I's purpose is completely different than member's purpose in the other loop. I's purpose in this loop is to actually hold a number. I is going to hold a number. And yeah, I is a variable, if I didn't say that already. It's a variable that is going to hold a number, and the number within I is going to be the current turn number of the loop. And I know that is maybe an odd term. It's a turn number, meaning like think about if you're running laps around a track. For those of you who run or who hate running, you know what I'm talking about. You run on a track, and for every lap that you do, maybe there's a lap counter that, this is lap 1, this is lap 2, this is lap 3. I's purpose here is to hold the number of laps you've done so far, the number of turns you've done in the loop. So in computer science, counting starts with 0. So on the first turn, I is going to hold 0. And then on the next turn of the loop, I is going to hold 1, then 2, then 3, and then so on. And really, until it gets to 1 before the end of the number of turns that is set right there. So I is kind of like it's a lap counter that to kind of let you know how far you are to the end of your range. So that's what I does in this kind of loop. And not useful in this particular code, but in other code, I is very useful for things. I'll just leave it at that, because there's a whole another discussion about what I is going to be used for, and we will save that. But I will hold a number, and it'll be the current turn that you are on right now. But kind of got a little deep there, but what we're doing here is to simplify. In the parentheses, you're going to put the number of times you want to loop. And then what is going to happen in your body is it's going to loop an equal number of times to the number that you put in the parentheses. So because I put a 10 here, it is going to run 10 times, and it is going to do what is in the body 10 times. So it's going to print, let's do this 10 times. As the slide states, yeah, it's going to do this 10 times on 10 separate lines. And the reason it's on 10 separate lines is because whenever you do a print in Python, it always goes to the next line after the print function. So it's set to do that. Let's try this one out in code. Wipe out what we got here. Keep it simple. Let's do this, baby. As you see, 10 times. So that's some of the power of loops, where you can create a couple of lines and then you can generate 10 lines off of that. If that is amazing for you. How about this? If we throw a 100 into here, let's see what happens. Bam. We got 100 printings. So as you can see, you know, the printings can pile up. You can just do, you know, really to break it down simply, you can, whatever you put in here, it's going to run whatever's in the body that number of times. And this is an oversimplification of what's going on here, but better to learn simply first, and I'll add in the complexity later. And that's really what I'm going to do later on. But simple identification, run a certain number of times, get that ingrained, and then from here we will go on to the deeper pieces of this topic in subsequent modules. Yes, yes, yes. Because I mentioned because I really needed to, because that's my job, right? I mentioned I'm going to give you a little bit of a peek here at what is doing. I'm going to turn this into an F string, and I'm going to print the value of as we loop each turn, just so you can see what's going on. I was saying before that is going to hold it's like a lap counter. It's going to hold the current turn number that we're on, and it's kind of like it keeps pace. I don't know if that's the right term either, but when I run this code, you're going to see that is going to increment each time, meaning it's going to add 1 to itself each time that this let's do this prints out. Here's what I mean. And you see 99 is the last one, and you go up here, and as I said, counting in computer science starts with 0, so it's like 0, 1, 2, blah, blah, blah. So yeah, you see, this is the value of each time we go down, and it counts up all the way up to 99. And I said this is going to run an equal number of times to what you put in here. Well, it does, because you can see in the count that it starts at 0 and goes to 99. Of course, 0 to 99 is 100, because that's 100 if you if you sort of do the math. Pretty obvious. But yeah, 100 times. And we will talk more about the function of in later modules. Another quick example to hammer home this point about the range. Let's change this one to 3 just so you can see another little example. Put in a 3, does it 3 times. There you go. And that is the for range loop. Quickly in a nutshell. Sort of quickly. Alrighty, let's talk about the other kind of loop, which is the while loop. Let's go. Y'all fired up out there? I know I am. The while loop. Yeah, the while loop is it's different than the for loop, which is why it exists, I guess. The while loop is going to run as long as the Boolean expression next to while is true. So really, while is based on a Boolean expression. That's kind of the thing here, where you saw with the for loops, there is no Boolean expression to be found. If you look at the range loop, if you look at the for each loop, there's no Boolean expression there. It's not based on that. It's based on other stuff. But the while loop is based on a Boolean expression. Looking at the syntax here, we have the word while, and then we have a Boolean expression here. And it says, will run as long as the Boolean expression next to while is true. While I is less than 10. Let's break it down. What is I? I is defined earlier here. I equals 0. And it says while I is less than 10. I is 0 initially. So because it's 0 initially, we're going to do something until it equals 10. That's what's going on here. And so what we're going to do while it is less than 10 is specified in the body of the loop. And of course, the body of the loop is the indented portion. And in the indented portion, what do we see here? We have a print, let's do this. I know that looks familiar. Then we have I plus equals 1. And what is I plus equals 1? Anybody? Well, I can't hear you anyway, so I'm not going to pause. But what I plus equals 1 means is that we're going to add 1 to I. You remember your combination operators from an earlier module? The plus equals is going to do an add, then a sign. It's going to add 1, and then it's going to add 1 to the current value of I, then assign that result back to I. Add, then assign. So on the first turn of this loop, I is going to be 0. When you add 1 to 0, you get 1, and then you put it back into I. So after the first turn of the loop, I is going to be 1. And then, as I said before, you loop back around again. And when you loop back around here, you loop back around, I is going to be 1. And then you're going to add 1 to it again. It's going to be 2. Then 3. So you see what's happening? I is going to be increasing each time, and I will eventually get to 10. The way the loop works overall is that the first thing that happens is the condition is checked. Is I less than 10? Then it goes in and does the print statement, then it does the increasing of I, and then it goes back to check the condition. Is I less than 10 still? Then it goes back in. This is how the while loop works. It checks the condition, checks the Boolean expression at the top. If it is still true, then it goes into the body and does what it does. Once it becomes untrue, the loop is over. So that's the whole thing here. While the condition is true, it is going to keep going and going and going. Once this condition is false, it is going to stop. So let's think about when this condition is going to be false. When it's going to be false is when when I is no longer less than 10. So really the first time it's going to be false is when I equals 10. So we know from earlier that I is going to be, 1's going to be added to I each time. So as it loops, 1's going to be added. It goes 1, 2, 3, 4, blah, blah, blah. It's eventually going to get to 10. Once it gets to 10, you leave the loop and you go down to whatever code is after the loop. That is how this works. So let us now take a look at this one in code in live code. Haven't developed a term for this yet. Bunch of exclamations. And what does it do? It prints, let's do this 10 times, because in setting this condition, it's going to go 10 times because it has to run 10 times in order to get I from 0 to 10. See, it says run while I is less than 10. It's going to take 10 times because each time you run it, I is going to be increased by 1. So if you increase by 1 on each turn of the loop, it's going to take 10 times to get there. Thus, it runs 10 times. And looking at this code, line 6 is essential, because if I don't have line 6, I will not be increasing I, and that means I will never get to 10. And if it never gets to 10, this condition stays true. And let me illustrate here. If I delete line 6 and I run this code, it is going to create what is called an infinite loop, meaning it's just going to run forever until I intervene and stop it. It's because the condition stays true. Because I stays at 0, notice now there's no code to increase I by 1. So I remains 0, so it just keeps running. Because there is no change in I. When there's no change in I, it's never going to get to 10, and it's going to run forever. Theoretically. Because I can stop it right there. All right. There's a basic example of while. Let's look at another example of while, shall we? We shall. Got a little bit of code here. This illustrates a different usage of while, where it is still going to be based on a Boolean expression and checking a condition each time, but here the condition is based on the value of a string. I create a string password called Rosebud, or the value within it is Rosebud. And really what I'm doing here is this is kind of a password prompt program, sort of. The wording is a little bit different, but the idea is similar, where we have logins for everything. We log into our computers, we log into websites, to apps, whatnot. This is a really simplified look at how a login processing loop works, where you're prompted to enter a password, and then it checks the password that you entered against the actual password, and if they're not the same, it's going to ask you again and again and again. That's what this code is going to do. On line 3, I create the password called Rosebud for you Citizen Kane fans out there, or people who have seen the movie. I actually haven't myself. Line 5, I use the input function to create a prompt. We've seen the input function in a few examples now. It should be old hat for you. Please enter your password, guess. Yes. And here is the while loop. While guess is not equal to password. Remember, password is Rosebud. So it's going to be while what you entered as your password is not equal to the actual password, we're going to do something. And what we're going to do is we're going to prompt with input once again. Because if there is no match, remember not equal, or the exclamation equals means not equal. If there is no match, then we need to ask again. And this time we're going to say that entry was incorrect. Please enter your password guess. And then the guess is going to go into the variable guess, and it's going to check again. Remember I said it's you check the condition, then you do the body. Check the condition, then do the body. Over and over and over again. At some point when you check the condition, it is no longer going to be true, and then you will leave, going down to the code below. And you'll go down to the code below once guess equals password, because the condition right now is we're going to loop as long as guess is not equal to the password. Once they are equal, we're going to leave. And I think I'll put this into PyCharm now. Why not? I'm running long enough, folks. Long enough. Long and strong enough. I think I can type this up pretty quickly. I probably should have just had it ready, right? That's how the pros do it. I'm still getting used to this whole recorded content game, so bear with me. I'll just say please enter your password. Well, the guess is not equal to password. You just prompt again. And I will say incorrect here. I'll do a sad face here. I didn't speak about this last line yet, and I'll do that soon. Once I spell this, congratulations. Congratulations. Remember that song? All right. Stay focused, homie. All right. Almost, whatever. Okay, looking at line 10, I didn't talk about this yet. Once the while loop is over, it means that the correct password has been given. So once the correct password has been given, you go ahead and say congratulations. There you go. So that's why that's there. We are going to run, or I'm going to run. You're going to watch. All right. So please enter your password there at the bottom. Oh, what if I enter the right password right away? Congratulations. See, what happens is that you enter the right password. If you enter the right password, this condition is not true. Because if you enter the right password, guess equals password. So you leave it immediately, and then you go down here where it says congratulations, and that's why it says it there. Let's look at a different scenario. The password. Say enter the wrong thing. So line 8 will execute now. I enter something else once again. And you see here, no matter what I enter, as long as it's incorrect, it's going to loop, loop, loop. See, this is looping. It's going to stay in that loop until I enter the right password. And once I enter the right password, magic, it exits. Not really magic, This is entirely logic, but it may appear as magic to some. Once I enter the right password, the condition on line 7 becomes false, and then I exit. Congratulations. Congratulations to you for now completing the loop module. That's loops, and I will see you, or you'll see me, or at least my code, in the next module. See ya. Okay, folks, now we will check out the topic of loop control statements. The statements of break and continue. And the loop control statements, they allow you to alter the execution of loops. We just looked at loops, looked at the for loops and the while loop. We looked at the normal operation of these. So now you should know how they run. The loop control statements allow you to change slightly the normal operation of loops. And we will define each one here. Break and continue. The break allows you to leave a loop early, typically based on some condition. And there's that word condition again. And really, these two statements are based on conditions. It's like the loop is running normally, and then if a certain thing happens, you change the way the loop works. The break is going to completely leave a loop based on a condition. The general format is if this happens, break. Break meaning leave. And you know, of course, a loop runs based on some condition like while I is less than 10. But the break would say, if this certain thing happens, we're going to leave and have no regard for the original condition. So a break will simply leave the loop, will not come back. It just cuts out, cuts and runs, as it were. The continue. Continue is an interesting one. Continue is going to skip an iteration in a loop based on a condition. There is that word condition again. And so what continue does is it skips a turn in a loop. And I use the term iteration there. I don't think I've revealed this term yet, but an iteration in a loop is a turn in a loop. It is like one revolution in a loop. And that is a term you're going to see and hear in programming a lot, so you can get used to it and write it down now. An iteration is a single turn in a loop. But what continue does is it skips one turn in a loop based on a condition. The general way to think about it is you've got a loop that's going while I is less than 10 or whatever, and the continue would be if this happens, you would place a continue, and the continue is going to go back to the top of the loop from where it is and continue with the next turn. So it skips the current turn and goes to the next one. And in the case of a variable I incrementing, I would increment to the next thing on the next turn. But to simplify things, you can really make the association between the word continue and the word skip. Continue, skip. Continue means to skip. Break, of course, means to just leave, cut, and run. Continue is a skip. Now we're going to look at a couple of examples of each of these right now. Here is break. Here's a simple look at a break. You see the word break in here, and when you use break, it is simply the word break in lowercase by itself. Now let's see what break is actually doing here. For I in range 10, using the for range loop. So this is going to loop 10 times. And we know that I is going to change its value each turn of the loop, starting at 0. It's going to go 0 to 10 in normal operation. Nested within this loop, we have an if statement. It says if I equals 4, break. And below that, it has a print I. And the print I is going to print the value of I. Now this print statement has nothing to do with the if above it, because you see print is not it is not indented. So it's not indented below the if, so it is not a part of the body of the if. So this print will happen no matter what. It belongs to the for loop. And yeah, it'll happen no matter what. So the if is pursued if I equals 4, but the print will happen no matter what. So let's look at the operation. As this loops, it's going to print I. On looking at the first turn of the loop, I is going to be 0, so it's going to print a 0 on the first turn, then it'll print a 1, then it'll print a 2, then it'll print a 3, and on the next turn, I is going to be a 4, but it actually won't print 4, because it'll be a 4, it gets here, and here's where the if becomes a factor, because it's if I equals 4. Of course, on the turn where I does equal 4, this is going to be caught. This condition is going to be caught. And what happens when the condition is caught is that you break. What does break do? Break just leaves and goes down to whatever code is below the for loop. So the overall effect of this code is that it's going to print 0 through 3. And that's it. It's never going to print 4 because this code will leave when I is 4, so the print here doesn't happen because it leaves before the printing of 4. So it goes 0, 1, 2, 3, leaves before the 4. And of course it never gets to the end because it's set up to leave when I is 4. So that is the basic operation of break. And I'm going to cut in a pie charm and look at this one. Oh. Let's go down a little bit. Take a look at how this one runs. As stated, we got the 0, 1, 2, 3, and it is because at 4 it breaks and this print will not be executed. It'll break and go down here, but there's no code down here, so it just exits, finishes. But yeah, loops until I is 4, so it gives you that 0, 1, 2, 3. And that's the basic operation of break. Now we will look at a more substantial example here. Here is another example. A little snippet. Here on the first line, I create a list called test list, and it's got some integers in it. Then I create a loop, and this is a for each loop. For those who remember the last module, for each. And the for each loop is going to loop through a list one at a time, meaning it's going to go through each item one at a time in the list. And each item is going to be placed into the num variable. And really, so it's a way to process a list one by one, each item. And then it's got some stuff going on in the body here, of course, as a loop should. So we have an if statement that says, if num equals 5, you're going to print 5 has been found, done searching. And then there's our break. And the break would leave. So what you see here is if the value of num is 5, another way to say it is if we encounter a 5 in our list, we're going to print this message and then we're going to leave the loop entirely. Just leave. Looking at the else says 5 not found yet. So the else will execute if num is not 5. And if num is not 5, it just prints this out and goes right back to the top of the loop and keeps looping, looping, looping. So essentially, this is code to search the list for the value of 5. Once it finds the value of 5, it will stop looping, specified by the break. If this is a 5, print a message and leave. Otherwise, we just say we have not found 5 yet. So this is a 5 searching, I was going to say function, but it is not a function. A 5 searching piece of code. You'll learn about functions later on. But yeah, it uses a for each loop to loop through a list looking for a value of 5. Once it finds that 5, it breaks. Let's run this code. Here it is, all nicely done for you. So running this, oh, wrong piece of code. So you see here the printing, we have 5 not found yet, printing 3 times, and then 5 has been found. Let's go through the list to see why this is happening. You look at the first 3 elements of the list, 1, 1, and 4. That accounts for these first 3 printings. And then we encounter a 5, which accounts for this one. And notice there's nothing else, because once you encounter that 5, you exit the loop via the break. It's over. And that's how break can work in a more substantial setting. And so you can search for something, and then once you find it, you just leave instead of continuing to go through a list. Let's run this thing on another list, because you can do that. Let's say we have a list with no 5s in it. If you take away the 5s, see what the operation is here. And you see we have, what, 6 occurrences of 5 not found yet, because this list contains 6 things, and you don't find a 5 at all. So some illustration of the concept of conditionals along with break, in that if you don't find a 5, you are not going to execute this body. So there's break, folks, and now let's look at continue. The continue is going to skip a turn in a loop based on a condition. And this is really the same code that you saw with our original break scenario, but it runs differently. And the usage of continue is the word continue right here. And yeah, it is simply the word, just like break is. So looking at this loop, it's for I in range 10 will loop 10 times. If I is 4, continue. And then we have our print statement that is not, it's not inside the if, it's inside the for loop, so it's not affected by the if. The operation here is that we know that I is going to increase, every time, 0, 1, 2, 3, until 10 in normal operation. This if statement says if I is 4, continue. Really, in the continue means skip. So when I is 4, what's going to happen is it's going to skip the printing and go back to the top where I is going to become 5. And then I is 5, this condition will not be true because I won't be 5, and then it'll go down to the print and print 5. The operation here is that it is going to print 0 through 3, and then it'll skip 4, and then go 5 through 9, because the continue will skip. So the difference between this and break is that the break will leave when it is 4, when I is 4. The continue will simply skip the printing when I is 4 and continue with the next numbers. So the loop actually continues, thus the word continue. I'll now run this one in PyCharm. I simply replace the word break with continue, and let's see the difference. Oh, I keep doing that all the time. Sandbox 5, let's go. Looking at the print here, 0, 1, 2, 3, you don't see the 4 because the 4 is skipped here. See? If it's 4, continue, which means it goes back to the top, it will not print on that one iteration, on that one turn. It will not print, but it prints for the rest of them. And let's just reiterate, looking at the difference. If you put a break in here, running with a break, it leaves on 4. If you put a continue, it will continue on 4. Really, it'll skip then continue. So that's a way to think about the continue statement. It is a skipping of a turn, then continuing with the next turn. As you see here, you continue with the I equals 5 turn. Make sense? Let's look at another example. Here we have what I would call a more substantial example. On the first line, we have a list, once again, of integers, some positive numbers, some negative numbers. Then we have a variable total made equal to 0. Then we have a for each loop where it is for item in LST. This is a for each loop, so it's going to be going through each item one by one in the list. And as it goes through each item, the current item will be placed in a variable called item. In the body, we have an if and an else. And the if says, if item is less than 0, continue. The else says total plus equals item. Let us break down the if first. The if says, if item less than 0, continue. So this is a comparison of values. If the value inside of item is less than 0, continue. What does less than 0 mean? Less than 0 means negative. So, because those are the only values that are less than 0. So if item is negative, continue. And what continue is going to do? Continue is going to go back to the loop, and really it's going to skip the current turn and go to the next. The effect here is that it's going to jump to the next item in the list. Let's think about the operation of this on the -3. If it gets to the -3, is -3 less than 0? It is. Then it says continue, which really means it skips from the -3, then goes to the 4. So it goes to the next item in the list. Then let's look at what happens if it doesn't skip, if it doesn't continue. That is what the else will handle. The else says total plus equals item. What is this doing? This is getting this is an addition. Remember the combination operator, the combination assignment. Wait, I'm not saying it right. The combination arithmetic and assignment operator that is shown right here, plus equals. It's going to add item plus total and then store the result in total. In a nutshell, what it's going to do is it's going to get a summation of items from the list. Let's go through a couple of turns with this. Let's say we start here and go through the loop with a 1. When item equals 1, it won't be less than 0. So we go down to the else. And then it's total plus equals item. It's going to be these two added together and then the result placed in total. To begin, total is going to be 0. So it's going to be 0 plus 1. 0 plus 1, of course, is 1. So on the first turn, total equals 1, because it's going to be these two added together and then the result placed in total. And I'm abbreviating total as T. So then I go back to the top of the loop. On this next turn, item is going to be equal to 2 because we've gotten past 1. And then you go in here, item is 2. Is 2 less than 0? No, it's not. So you don't pursue that. You go to the else. So then we have total plus equals item. Item is 2. Total is 1. So it's going to be 2 plus 1, which is 3. And that result is going to be placed in total. So total becomes 3 now instead of 1. Whoops. And then we move on to the next turn. Going to the next turn, item moves where now it's -3. Item is item. Item is -3. And then is -3 less than 0? Yes, it is. So we do the continue, which means we go back to the top of the loop and we move to the next item, essentially skipping -3. So now item becomes 4. And then is 4 less than 0? No. So then we go to the else. And then it's going to be total plus equals item. Item is 4, total is 3. So it's going to be 4, it's going to be 3 plus 4, which of course is a 7. And then 7 is going to be placed in total. Now total is 7. And then you go back to the top of the loop. And then we have item being -4. So I'm not going to go all the way through, but now you see the operation where it's going to skip negative numbers via continue, and it is going to add positive numbers. At this point, our total is 7, and it's going to accumulate as it goes forward. It's going to skip the 4 and go to 3 and 4. So 7 more is going to be added, and it's going to eventually be 14. But the code here, it's going to skip the negative numbers and only add the positive. And that's what continue is being used for. Continue is being used to skip the negative numbers and add only the positive. So we're going to get a sum of the positive numbers in this code. And as the slide states, it's going to loop through the list, getting a sum of only positive values, and accumulate the sum in the total variable. And let us now run this one in PyCharm. There it is. I did it again, folks. Can always count on me. I ran the wrong code. Oh, so here I'm not printing anything out, so that's why you see no output down there. So I've got to print out what I want to display. I'm going to print the value of total because total is going to hold the summation. You see there 14. And how is 14 arrived at? It is 1 plus 2 plus 4 plus 3 plus 4. The negative numbers are eliminated via the continue because it says if the item is less than 0, continue, meaning skip. If it's not, if the item is not less than 0, we are going to add. So there is the reason for the season, folks, whatever that means. Alrighty, this concludes the talk on loop control. You'll see me in the next module. I'm out. Alrighty, I wanted to take some time to discuss some syntax rules that don't really fit into any other of the modules, so I needed to cover them sort of in their own module. These are really just rules of the road in Python, just some rules you're going to have to follow as you format your code. And I don't think I've defined it anywhere else. And you're going to hear me use the words over and over again, the word over and over again, just one word. Syntax. Syntax. These are the rules that govern how you construct code in a certain language. Of course, this language being Python. We're going to look at some syntactic elements, meaning some rules regarding how you construct code in Python. And all the Python code that you write, you're going to need to follow these rules, so let us dive in. Great introduction, right? All right. Comments. The use of comments in coding is a way to add notes or explanations to your code file. Comments are ignored by the interpreter and allow you to write freely alongside your code to explain, document, and plan using plain language. So, yeah, comments are a way to insert notes, to-do lists, documentation. They are immensely useful, where if you're on a project team, if you write a piece of code, you can explain your code using comments in plain language, and then you have the code right after it in the same file, so people can they can more quickly acclimate to your code, because reading code without an explanation, it is simply a slower process than reading code with an explanation. So comments are useful. Comments are useful also for if you're developing something by yourself. I've experienced it many times where I'll do some work on a project, and I'll work on a project and leave it dormant for a while, and then come back to it, and it'll take me hours to understand what I was doing prior, because I didn't comment my code properly. When you comment your code properly, you can really more quickly dive into what you're doing, either you or somebody else. Now, in Python, there are two ways to comment your code, either single line comment or multiple line. For single line commenting, it begins with the hash or number symbol and goes to the end of the current line. Anything after the hash symbol is ignored by the Python interpreter. And here is an example of a single line comment. All you have to do is begin it with a single hash symbol, and the rest of the line is ignored. So if you put code in here, actual runnable code, it's not going to be interpreted. It's not going to be evaluated by the interpreter. Multi-line comments begin with triple quotes, either single or double triple quotes. Isn't that confusing? Well, single triple quotes are like this, and then double triple quotes are like this. So, but either one's going to work. I think you're going to see more often, you're going to see the single triple quotes, but they will both work for multi-line comments. So yes, multi-line comments are comments that span multiple lines, as the name suggests. From the first set of triple quotes to the ending set of triple quotes, the text is ignored by the code interpreter. And let us take a look. So right here, yeah, you begin with the single quotes, and then you have your little block here of just whatever you want to say, and then you end it with a set of triple quotes. So multi-line comments they can span a lot of lines. It could be a full page. If you need to really document something or really break something down, you can write a poem in there, like whatever you want to do. It is up to the programmer. Let us real quick take a look at how these look in actual PyCharm. Here's an example of a single line. And you can put whatever characters you want, and it's not going to be evaluated. And then you can have some regular code here. And then you can have another single line comment. You can write whatever you want. Notes to self, little jokes, whatever. Yeah, it is up to you. The multiple line comment is like this, where you do three. In PyCharm, when you do three single quotes or three double quotes, I think. Let's do the double quote. It'll autocomplete and give you three more on the other side, so that you can do your commenting. So you can do blah 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 blah. If I can spell nonsense right, and that's nonsense. And then you can go on to, do other code. I do hell word, not hello world. I missed some letters there. And you'll see when I run the code, this is going to, you see all of my nonsense and gibberish is not evaluated. But let's uncomment the gibberish and nonsense, and you see red flags go off, right? Red flags. And it actually prints it out, and it gives you an error because it doesn't know what the heck this is. Okay, so there's your single line and there's your multiple line. Let's dive back into the documentation, shall we? Okay. A common use of commenting, tongue twister maybe, a common use of commenting is basic code troubleshooting. Comments give you the ability to deactivate lines or sections of code and selectively run parts of the code to determine where a problem might be. This is called commenting out code. And this is a very prominent use of commenting. You can selectively deactivate lines of code really to find a problem. Because any of the troubleshooters and problem solvers out there, maybe if you've been in IT support, you know that when you're trying to figure out a problem, you isolate pieces of it to determine what the problem is. Like if you're working on computer hardware, you will isolate or remove certain pieces from the equation to determine if the piece that you removed is the problem piece. You can do the same thing with code here, where you can have several lines of code and you can selectively deactivate certain lines of code to see, when I deactivate this code, was the thing that I deactivated the problem or not? So here we have a little example where we have a variable equaling 0, and then we loop 10 times, and then here is our commented out code. And this is not showing you a potential problem. This is just more illustration of the concept. So there's no problem here. It's just I'm showing you the deactivation of a line of code. So in the body of the loop, we have the total plus equals 1, or not 1, it's I. Total plus equals I. This is the deactivated part. So this part will not execute. The only thing that's going to execute is this print. So as we loop, the only thing that's going to execute is the printing of I, and it's gonna go 0 to 9 printing wise, and that's it. This total plus equals I, nothing's going to happen with it. And it will not execute. Only the printing will occur. The plus or the hash symbol deactivates all the text after it on the same line. Let's pop this into PyCharm. Let's play with this one a little bit, my friends. Play with it. Hell word. Okay. So when you look at this code, whether line 5 runs or not, you don't really know because there's no printing of total. Like, you don't know what total is. So I'm going to add a print statement here. So you can actually see the value of total, because if line 5 runs, then total is not 0. If it doesn't run, it will be 0. So let's run. What was that? Yeah. Anyway, I guess I hit it twice. But anyway, what you see here is you just see the printing of I, which line 6 is in charge of. What happens when we take away this hash symbol, and we go ahead and run it? Oh no, yeah, the 0 at the end, that is the printing of total. Let me do this to make it more clearer. The value of total. I'm going to leave this commented out for now. Let's run it. So you see 0 through 9, and then you see the value of total. That's funny. Yeah, yeah, folks. You can tell that I do one take things. I don't videos. I don't like go back and edit and all that stuff. I like the free flow to kind of more realistic. You know what I'm saying? Anyway, let's go here. So you see the value of total is 0. It's because it started at 0, and line 5 did not run. Now let's uncomment total. So now here we're going to see the power of the reactivation of this line. 45, because what is actually happening in this line is that I is being added to total, getting a sum, and it gives you a sum of, I think, of the numbers 0 through 9, because they're all going to be added to total as we loop. So this is the code running, and this is the code with line 5 commented out. Line 5 commented out, this value is going to change from 45 to 0 because total, it is not going to be added to at all. So it'll retain its original value. There we go. There is commenting out. We move on. Indentation. Python, and you've already seen this, indentation is required in certain situations. The majority of the situations involve the bodies of control blocks like if, elif, and else, and loops. These are the control blocks you've seen so far. Indentation is typically for the bodies of these control blocks to show membership to the control block. I'll say control block again. Okay. Yeah, indentation is required in Python in those certain scenarios. In other programming languages, it is not. So Python kind of unique in that way. So look in here, as we look here, I equals 0. And then while I is less than 10, there's your condition. And then notice the red arrows showing the indentation. And all of these lines are in the body of the while. And being in the body of the while, they will execute however many times the while loop runs. And this is set to run 10 times, so these lines will occur, they will execute 10 times. And you have a line afterwards that is not indented, and the lack of indentation means that this is not in the loop. So these other things occur 10 times. These other lines, this last line will only occur once because it's not in the loop. When indentation ceases, it means the body of that block is done. The last print statement will only print once as it is not in the loop. So you got the stuff in the loop, and the indentation, it shows the membership to the loop, and when you stop indenting, it means that the subsequent line or lines are not in the loop. And let's put this into PyCharm. Let's see how the arrows will, I forgot the dub. Oh, no, I didn't forget the dub. Get rid of these arrows. And those single quotes are messed up. Of course, you see the indentation happening there. And then on line 8, the indentation stops. Line 8, the indentation stops. So you see that. And you see the printing occurs 10 times, these two lines. But the last line only occurs once. This code will not occur in the loop. So that's the indentation, required piece of Python. And there you go. For already indented code blocks, items within those indented blocks are indented further, where you look at this for I in range 20, and then we have an if statement where, of course, you've got to indent. Of course, you got to indent for the if because it's in the for loop. So the if is in the for loop, so it's indented. And then, of course, an if statement has to have a body. So for the if statement body, you have to indent further. So you got one tab here for the if, and then you got two tabs for the body of the if because you indent once to be inside the for loop, and then you indent once again to be inside the if. So this print statement, it's a member of the if, and then the if is a member of the for loop. So it's this nesting that's occurring. Yeah. So yeah, notice the extra indent below the if to show membership to the if block. Yeah. So when you have a code or you have a control block inside of a control block, like an if inside of a for, like you see here, you have to indent further for its body. See, 2 indents versus 1 indent. Yeah. All right, let's cover a few more topics here to close it out. Casing. Python and programming in general is case sensitive. Most languages are case sensitive. An uppercase letter and a lowercase letter, there is a distinction there. So that is important. The use of lowercase letters is more prevalent, as most of Python's language constructs employ lowercase letters like for, while, if, else. Basically, the majority of the reserved keywords in Python, maybe all of them, are in lowercase, and lowercasing is mostly a standard in Python. Of course, when you create variable names, you have the ability to use all capital letters or capital letters here and there, but by convention, most will use lowercase letters for the entirety of their Python code. But the casing is really, as far as variable names, you can case however you want, although it may look strange. For the reserved keywords and language constructs, by and large, they are lowercased. Let's talk about spacing. Spacing is sometimes ignored, sometimes not. Then there's just you'll kind of get a feel for it as you go through Python. Vertical spacing, up and down, it's largely ignored. Like you can space out vertically, kind of to your heart's content for the most part. It'll look weird, but you can play with that a lot. Horizontal spacing. side to side, it's ignored in certain cases and not in other cases. Horizontal spacing is ignored in between elements and after proper indentation has occurred. If you're not indenting, the code has to begin at the left edge of the editor. And these items take a little bit of demo. Yeah, so I will do that. Clear. So it's like vertical spacing. And I don't really need to say nothing there important. Vertical spacing, yeah, you can totally do this, and your code's going to run fine. You know, no issue there. That vertical spacing. Horizontal spacing is okay. I say in between elements. So like doing stuff like this, although silly. And I'll print X down here. Although silly, it totally works. Like you can write your code like that if you want. In the cases where you have to indent, let's kind of bring this stuff back. Wait a minute, let's see. So in the cases where you have to indent, once you've indented, meaning once your indenting is taken care of here, you can play with the horizontal spacing, where like once my Y is indented properly, I can do some weird stuff with it. Just the line has to start at the proper place. But once it starts at the proper place, you know, I can be kind of crazy. So the indenting must occur first, and then you can play around with the horizontal spacing. You can horizontally space like in the middle of an element. Like you have a print statement here. I mean, I don't think I can do this. Let's see here. Oh, I can. Interesting. So there's something I wasn't really sure about. But yeah, so you can do that. But yeah, those are horizontal and vertical spacing. Vertical, it's kind of wide open. Horizontal, once you've done the proper indenting, then you can do more horizontal spacing, but the proper indenting has to be in place before you start playing with the horizontal spacing. And it's kind of an obscure topic, but I've gotten this question here and there, so I wanted to address it in this content. So there you go. And those are some syntactic elements to chew on for you. These will aid you in your future development. So with that, I'm out. See you in the next one. We will now take a look at the string data type. Now that we've covered a lot of the foundations, the fundamentals of Python, we're now going to look at certain data types in detail. Looking at strings here, we'll look at lists in another module, but yeah, we're going to focus on some data types and look at those, as I said, in detail. Keep using the same word, but it is what it is. All right, so let's define strings. Strings are a data type consisting of one or more units of text data. Yeah, strings are the text data type in Python. all text, pretty much, I can't think of an exception, all text is represented as a string in Python, whether it be a single character or a bunch of characters. And characters, or the text can span, pages. Like it could be one character, it could be 10 characters, it could be 10 pages. Strings can be immense. And strings are pretty heavily used because text is important in life, it is what it is. We're reading text right now. A string can contain any text character and can be of any size. String data is always enclosed in quotes, either single or double. And for the most part, single and double quotes are interchangeable in Python. And there are a few exceptions. The most notable exception being when you have outer quotes of one type and then you have inner quotes of the same type. You have to differentiate, but not really going to get into that. But by and large, single and double are interchangeable in Python. Looking at strings can be likened to data structures, although they are not technically. And going back to the definition I gave of data structures, a collection of individual items. A string can be kind of thought of as a data structure, although it really isn't. See, it can be thought of as a collection of individual characters, meaning like the word hello. You see this word in string form, and you look at it at the entire entity, but it can also be considered a collection of individual characters, like a collection of individual letters. Like you have the H, the E, L, L, O, and I'm putting commas in between to kind of make it like a list. You can think of it like a collection of individual letters because with strings in Python, you can actually isolate letter by letter through a thing called indexing that we'll get into pretty soon. So you can do things to it as if it were a data structure. So you can kind of get your mind thinking in that direction, that it's kind of like a list of characters, even though it is overall a complete entity. It can also be broken down into its constituent parts. That sounded good, didn't it? All right, let's look at some string operations, as the heading says. String data can be represented inside single or double quotes, as I stated before. And here's a new thing. Multi-line string data can be enclosed in triple quotes. So you can use single, double, or triple quotes. And the triple quotes have a special meaning. These triple quotes, you're going to use the triple quotes to represent a string that spans multiple lines. Of course, this is useful for longer text, like if you have a paragraph, page, or more of text. You're going to want to use a triple quotes, and it makes the formatting of your code, it's the way to do it, because you take one of these, other ones try to span multiple lines. It's you got to do some finagling to try to get it to go multiple lines. So if you have text that is going to be more than one line, start it with triple quotes, and just really anything inside the triple quotes is interpreted as the string, and you're good to go. So it is the way to do it. And what we have here is 3 variables, and these 3 variables are set to different string literal values. And I wanted to highlight the term string literal. You're going to hear this in programming. You're going to see it in programming. The term string literal, it means the string data. That's what a string literal is. It is text inside of quotes that is defined as a string literal. A string variable would be a variable holding a string literal. So var1, var2, var3, these would be string variables. The string literal would be the stuff in quotes. Alrighty, moving along here. Look at this last piece of string operations. The print function can be used to display string data in variables containing strings. On this line we have a variable equal to a string literal, and then we print that variable. It is printing the contents of the variable here, so what we'll print out will be hello world. Moving down, covered previously, two common ways to print variables along with string data are the comma method and the f string. Yeah, we covered this when we talked about the print function and the input function. Basically, there are two ways to print string literal data along with a variable. The first print shows the comma method. This is the comma method where you have your string literal here, and then you have a variable over here. I'll abbreviate them as L and V, literal and variable, and C separated by a comma. And notice with the comma method, you have your quotes here, and you have to break the quotes, meaning you have to end your quote before the comma, then you have your variable here. On the next line, we have the f string method, where you have the lowercase f, then your quotes, and notice with the f string, everything other than the lowercase f is inside the quotes. Where you have your literal here, then you have your variable. The variable is enclosed in curly braces. Curly braces. So with the f string, you insert your variable inside of curly braces, and notice the quotes. I just made this point. They go all the way to the end versus being broken up here. I think the f string is really the way to go in modern print formatting. Of course, it is up to the programmer to choose. There's always more than one way to do something, which is a great thing about programming. You can decide on your own style how you like to do it, and sometimes things are suited to a purpose. Like sometimes one method is going to be more preferable to another method given the constraints of what you have to do. So we can make decisions, and that's a cool thing about programming. It's not just one way. All right, I'm going to pick up indexing in another video, but that's it for now. String indexing in another video. Hey there, well, we will now look at the concept of indexing. That was a weird intro, right? Kind of got tongue-tied. Anyway, indexing, string indexing, actually. So, yeah, interesting concept here in that we're going to talk about indexing in the context of strings, but indexing is not only isolated to strings. You can do it with other data types as well, like lists. We'll get into indexing with lists when we look at lists, but indexing is a thing that is across programming, not just Python. So it is a larger concept than what's being presented here, but here is your intro to it if this is the first time you're hearing about indexing. Accessing individual characters from a string can be done via a technique called indexing. Indexing is the ability to access an individual character of a string using a syntax that specifies the location of the character you're seeking. Indexing, restated, it's a way to access an individual character out of a string. Usually strings are going to be multiple characters. If you want to tab a single character, grab it out of there, Indexing is the way to do it. In a string, each character has a location number called an index. Indexes begin at 0 on the left side and count up by 1 going to the right. You can think of an index as an address of a character within a string. And looking at this graphic and examining the string Pythonic, we see that the characters sectioned with the corresponding indexes below. The indexes indicate location and ordering of items. So if you break the string Pythonic into sections, we see that each character has a location number starting at 0 on the left. And all strings are like this. It's just automatic. When you create a string, it has indexes according to starting with 0 on the left and counting up by 1 going to the right. And here, for instance, the index of P is 0, the index of Y is 1, and so on. So the index of I is 6, and it's ordered left to right, increasing by 1. And these indexes which are integers, they allow you to access and address characters in a string. Let's look at it syntactically. Now that we see the graphic. See the graphic? Now it's gone. Okay. The action of indexing syntactically, meaning according to the rules of Python, involves using the variable name of the string followed by a set of square brackets. Inside the square brackets, you're going to place the index number of the desired character. And we have our resident variable a string now equaling Pythonic, which is the string we had in the graphic. And here on this line, we are doing indexing as the comment suggests or says. We have the name of the variable, square brackets, and then a number inside the square brackets. The number is the location number of the character that we're accessing. That character is going to be placed into the variable, and then the variable is going to print, and it's going to print an H. It prints H because, let's do location numbers, 0, 1, 2, 3. You see the 3 matches up with H, 3, H. Can't get any simpler than that, folks. Let me know if you have any questions. And if you do, I can't hear them, so I don't know. Send me a text, send me an email. You got my address, I'm sure. My number. It's everywhere on the internet. All right. Indexing can also be done with integer variables. So the indexing that you just saw was done with what you could say is a literal integer, like an actual value. Indexing can also be done with variables, meaning, putting an integer inside of a variable. So on this line, we have I equals 5, so now I will contain 5. Then we have our A string once again. And here is variable indexing, where we put a variable inside the square brackets. Of course, when you use a variable, it really represents the value that is inside of it. So this is the same as doing like A string 5. So A string 5 is going to be in, which is 0, 1, 2, 3, 4, 5. And that's in. That's why that is displayed. And as I do always, I'm going to demo these two. Just to make sure you all get what's going on. Always got to clean up the quotes because they do not transfer. The formatting does not transfer. And on line 4, what you see here, this is a comment, and a comment is a way to put notes into your code. And I'm sure we'll cover these at some point, but a comment, like I said, is a way to put notes in your code. It's a way to explain things or to put little to-dos or notes. You can also deactivate code with them, but long story short, when you put a hashtag here, everything after it is ignored by the Python interpreter, so you can type whatever you want. It's a way to put notes in here, like I did. All right, so getting into the code, I've already explained the code, so let's just see how it runs. And you get yourself an H there. Another little demo here. Let's do a 0, and you can call this index 0. I should get the capital P on this one. And there we go. We do get the capital P. So that's basic indexing. And we can spice it up a little bit and do variable indexing. Create an integer variable. Let's make it equal to 5. You put a I in there. And it's going to give you the 5th one, which is an N. And let's change the variable value on line 4. Let's change it to a 1. That's going to give me a different letter. It gets me the Y because Y is index 1. All right, back to the show or the document. And now I'm going to look at a concept called slicing. A very interesting concept. Slicing is the ability to retrieve a subset of a string from a string. You retrieve a subset of a string from a string. Really, it's a way to get a substring out of a string. It allows you to extract a portion of a string from a larger string. So if you got the string hello, I always use hello. Let's say you want to only get the last bit, LLO, and put it into its own string. That would be slicing. You take a piece of a string, put it in another string. Got the morning throat here. Here we go. Slicing is based on a range of characters indicated by a beginning index and an ending index. So when you're doing slicing, it is governed by a beginning and end of a range, and indexes are the thing to use here because we just saw that indexes are location numbers. So you can create your substring with a beginning location and an ending location. That's the idea of slicing. Slicing is performed using the variable name of the string along with a set of square brackets as if you were indexing. And here is the format. We have our buddy A string once again. Then we have square brackets. And we have start, colon, end. In this formatting, start will represent a beginning integer, and end will represent an ending integer. And an example would be something like 1 and 5, where 1 would be the beginning of the range, 5 would be the end of the range, and it would grab the characters in this range from index 1 to index 5. Inside the square brackets, you place a colon in the middle, and on each side of the colon, you specify indexes. And I think the the plural is actually indices, or indices, but I'll let this one fly for now. The index on the left side indicates the starting position. The index on the right side indicates the ending position of your substring. And this kind of reiterates, start will be the beginning, end will be the ending of the slice. Slicing will produce a separate string, and the original string is unmodified. So what slicing does is it copies out a portion of your string, and the original string is not modified in this scenario. Slicing will produce a portion of the string from the start position to the end position, and something to note is that the ending position is not inclusive. This means that the actual end of the new string will be one less than the specified end. So just to make things more confusing, throw a little wrinkle in here. The way that slicing in Python works is that the ending that you specify is not inclusive. It includes the value before the end of the number that you specify. So got to look at an example. So looking at Pythonic once again, here is your first look at an actual slice. It is 1 to 4, but really, and this would be indexes 1 to 4. How it's actually going to work is, in reality, it's really going to go 1 to 3 because the ending is not inclusive. It's always going to be one less than the number specified at the end. The beginning index is inclusive, so the 1 is actually going to be the 1, but the 4 is really going to be a 3. It is just something you have to get used to. And what it's going to print here is YTH, because if we do the numbering here, 0, 1, 2, 3, 4, you see the from 1 to 3 is YTH. 1 to 3. Remember that it does not include 4, even though you have to specify 4 to get 3. It is what it is. Let's look at another example out here. We have another string equal to quarterfinal. Beautiful word there. It's what is it, the third to last round of the playoffs? Quarterfinal, semifinal, final. Yeah, something like that. Okay. Don't know why I decided to throw that in there. Here's another slice. From 5 to 9. So if you do the numbering out, I know this is tedious, but y'all are just learning, so bear with me. Guess it should be tedious for me, not you. But anyway, some will appreciate this. So we have our indexes here, 5 to 9. It really means 5 to 8. So we're going to start at 5 and go to 8, not including 9. So ERFI, that's going to be your slice, ERFI. And it actually goes from index 5 to 8 because the ending is not inclusive. And let's run these, shall we? Always got a demo. Always got to try out your code. Especially when you're teaching it, right? Right. Of course, we got to clean up them quotes. So here we're getting a slice of 1 to 4. From 1 to 4, which really is going to be 1 to 3, so it's going to be YTH. And just to play off the demo a little bit, if we go 1 character more, going to 5, Then it's YTHO. Yeah, there we go. Look at the next example, quarterfinal. So we have the variable creation on line 3. And then, of course, I've got to print out the variable in order to see it. So I'm going to do that. And never mind about that warning. It ain't going to be a problem here. But we have ERFI, which is going to be ERFI in the middle. 5 to 9, really, it's going to be 5 to 8. So the index at I is 8. The index at E is 5, 5 to 8. So yeah, 5 to 9, it really means 5 to 8. Yes, yes. And that's it for this part. And the next part, going to look at strings in loops. Now we look at the concept of strings in loops. We looked at strings in several scenarios already. Indexing, basic usage, printing out the concepts. Now we're looking at strings in loops. And this will be good to see with loops because we haven't done very much with loops yet. I introed you to the concept of loops. You've done, I think to this point, you've done some exercises in loops, depending on how I order the course. I haven't really completed that yet, but looking at strings and loops, strings can be processed using loops. Any kind of loop can process a string, whether it be the two for loop types, even though there's more than 2 for loop types, but I've only given you 2 for loop types, and then you have the while loop. Any of those can process strings. When you process a string in a loop, strings are processed 1 character at a time. Looking at this one, we have x equals rosebud, and then using a for each loop here, for a character in x, x being the variable, x being rosebud, it's really saying for letter in the string. And as we know in the for each loop, the variable becomes, or it's going to hold each element successively of the data structure. Here the data structure is a string, so it's going to successively hold the letters R, O, S, E, and then the rest. So on the first turn, char is going to hold R, it's going to print it. Going to hold O, not 0, and then print it, and then S, and so on. It's going to print 1 at a time because that's how loops work. Loop is going to print 1 character at a time. And so you see here, down the line, we have rosebud printed vertically. Now, why does it print vertically? I believe I covered this idea in another module, but it prints vertically because every time you print, it goes to the next line. And we're printing 1 character at a time. So when you print a character, goes to the next line, print the character, goes to the next line, the word is going to print vertically, as you see in the document. Moving along here, strings can produce similar outcomes in for range loops as well, using a different syntax. To assist in doing this, I use a function called len. It's going to give you the number of characters in the string, and this is going to tell range how many times to loop. Now we have another example, and this is going to do the same thing as the loop before, but it's going to be done using the for range loop instead. First line, I create the variable as I did before, then I do a for I in range. And remember, this is kind of the basic setup for the range loop. Then in the parentheses, instead of an exact number, I have len x, which is the length of x. And this is a new function for you all. And len is a function that is going to give you the number of letters in the word. Now, why do you get the number of letters? The number of letters is going to tell you how many times to loop. Because if you recall in range, it's how many times do you loop? You put that in the parentheses. The exact number here is being replaced by the length of the string, giving us the number of times to loop. The number of times to loop is going to be equal to the number of characters in the string, because you want to loop an equal number of times as there are characters in the string so that you get through all of the characters. So it is going to do the same thing in a different way. Looking at the printing line, you have x brackets I. This is using indexing, using variable indexing. And we're using I. I is going to be, as I said before, I holds the turn number that we're currently going through in the loop. So I is going to hold that number, and then we're going to use that to index in to the string. So like initially I is going to be 0, it's going to get you R. Then it's going to be 1, it's going to get you the O. Then it's going to be 2, get you the S. Consequentially, it's going to give you each character sequentially. So there's a little bit of symbiosis there, where it's just that I is going to correspond to the consecutive indexes, and it's going to give you the consecutive characters. It all works out in the end, just like everything, right? Absolutely. Then we have another example where we have we're using the while loop to do the same thing. So as I said, this can be, you can process strings with any kind of loop. Well, here is the version with the while loop. So we create the string again, I equals 0, and then the condition here, you know, with the while loop, we set a condition. So it is I less than the length of s, and here is our Boolean expression. We set I to 0, so initially I is 0, and then while I is less than, having a little bit of lag here, less than the length of x. Said in the last example that the length of x is going to be equal to the number of characters in x, and then I is going to go from 0 to the number of characters in the string. Essentially, that gives you the number of times to loop. In the body, we have print statement, the same one as before, or function, if you will. Then we have the I plus equals 1, and this is going to increment I towards the limit, which is the length of x, the number of characters in the string. So now let's run all of this code, because that is what I do to demo these things. So, and I encourage you to do the same. And even if you fully understand this, you know it inside out, you got it, running this code, it's instructive somehow. I can't even explain it, but putting it in yourself and actually running it, there's some experience points to be gained there. Even when I do it, believe it or not. So we see Rosebud printed vertically as it should be. And this is using the for each loop. And then I will put it in using the for range loop. Same outcome should be. Same outcome, yep. And then rapid fire, I'll pop it in using the while loop. The indentation is off here. Looks good now. Yeah, Python is a stickler for indentation. It is required, and I've spoken on that before. And we get the same output. And just to show you that this is not an automated robotic kind of thing, I'm going to add some characters. And if you add characters, you don't have to change the loop code. It'll print out the extra characters. There we go with that demo. All right, next concept. String concatenation. Almost sounds like a dance, but it is not. Concatenation is the joining of two or more strings, typically using the plus operator. When the plus operator is applied to strings, it has the effect of combining two or more strings into one string. So this is interesting. This is the reusage or redefinition of the plus operator, applying it to strings. So you have string plus string equals the combined string. Like, think of the plus operator with addition. 2 plus 3 equals 5 with numbers. But when you use it with strings, it is a combining term to concatenation. And here it is. String 1, string 2, hello and world. String 3 here, string 1 plus string 2 makes string 3. String 3 is going to be hello and world together. So the plus sign will combine the two strings. And concatenation can combine more than two, but 2 is the beginning. And here's a different look here. An added example of concatenation is that you can use the plus equals operator to produce concatenation. It produces an accumulation effect where it takes what you have, adds something to it, and then places it back into the same variable. So it's like a tacking on or an appending effect, where you start with one string, and then you do a plus equals something else, adds on to the end. Plus equals again, adds on to the end. It produces an accumulation effect. And we see here where you have a string hello, and then you plus equals exclamation point, another one, and then another one, and you end up with 3, because it is a building process. It's one, then another, then another. So if you want to continually add on to the same string, you can use that plus equals. It's kind of a shorthand, because you can do this another way, a longer way, but this is good. And really, this exact thing you're going to want to do it in a loop, not here, not the way it is, but this is more for demo purposes. And definitely going to drag this one into PyCharm and take a look at it. Clean up the quotes. Combine strings through concatenation. You see the hello world combined into one now. Let's look at the other example. If I'm going too fast for you, obviously you can pause the video, watch it again. That is the power of technology, my friends. And I won't ask you if you have any questions, because I won't hear them anyway. You can text me or email me, like I said. Feel free to ask questions though, but do not expect a response. If you do, you're going to need some different tutorial videos. All right, looking at lines 2 through 5, add the exclamation points, and then it's going to print the 3 that have been added. There we go. Hello, hello, hello. So 3 exclamation points on the end. All right, folks, there's our demos. Next time we'll look at string functions to wrap up strings, and that'll be that. The discussion now is on string functions. This is the last portion of the strings unit, the strings module. And yes, string functions. Python includes several functions with the string data type to make common operations easier. And I haven't discussed what a function is. We're going to look at functions in detail, like I say with everything else. We're going to look at functions in detail later on, and you're going to actually be able to make your own functions. But what a function is, it's a pre-made utility by the makers of Python. Individuals can make their own functions as well, but a function is it's like a tool. It's a pre-made tool that allows you to perform a task that you would have otherwise had to write with your own code. So Python provides several functions with strings so that you don't have to reinvent the wheel to make your usage of strings easier. And here is a little format of how you can use the string functions. The functions are utilized by typing the variable name of the string. So let's assume a string is the name of the string variable, a dot, and then the name of the function, followed by a set of parentheses. Now the parentheses will always accompany the function name when you use a function. And the parentheses will either be empty or there's going to be stuff in them. And whether you put stuff in there or not, meaning in here, depends on the function. But this is the general format of a function usage in Python. And now let's look at some functions, shall we? The first function we're going to look at is index. What index does is it's going to provide you with the index of a certain character in a string. Here we have our string a string equals yellow. That's the string literal. Then we print, and then here is the function usage here. It's a string dot index, and then we have an O in quotes. Index is going to give you the index of a character in the string. You provide a character in the parentheses, it'll give you the index of that character, the numeric index. Remember, indexes are integers, and it'll provide the location number, which is the index, and it is 4 in this case. 0, 1, 2, 3, 4. And we see 4 is the O. That's what index does. Index will return the numeric integer index of a character from a string. And it's kind of a way to search for a character in a string. Let's say you have a really long string and you want to find the first index of the letter A in the string. You plug it into index and it'll give you the location of that first A. Very useful function. The next function we'll look at is count. Count is going to give you the number of times a string occurs within a string. Here we create a string called Yellow Wolf. Anybody heard of Yellow Wolf? Excellent, excellent. Then we print. And here is the function usage. A string dot count. And in the parentheses we put an L as the provided string. This is going to give us the number of times that L occurs in the string. So we do L and it gives us 2 because there are 2 L's in the string. The number of times a string occurs within a string. Then we have upper, lower, and capitalize. These are all about changing case. They will modify the casing of the string. Upper and lower, I'm getting tongue-tied here, will uppercase or lowercase all characters in the string, all of them. So if you do upper or lower, it's going to upper or lower all of the characters. Capitalize is going to capitalize only the first character of the string. And I've gotten far enough that I'm going to demo the first set of these functions, and then I'll move on to the next ones. Move this on over. Here we go here. Nice view, isn't it? So we're going to look at index count, and then upper, lower, and capitalize once again. And let's look at index. And that there is a comment, in case you didn't see one of the previous videos, a comment. It's a way to create a note in your code. I'm going to give you another example of using index because you already see an example here. Why don't I give you a different example so you get a different look, right? Not always the same. Even though I'm using the same variable. Okay. This is the usage of function usage of index. I need to supply index with a letter to get the index of. So let's get the index of the letter D. Print that out. 10. See, the D is all the way at the end, so that's going to be, index 10. I guess you could count over 0, 1, 2, 3, 4. The space also counts as an index. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is 10. That makes sense. There is the usage of index. Let's look at count. And we'll just do it on the same string. Count. And I'm going to get the count of a letter that occurs more than once. Like L. You have 3 L's in here. So let's put L in here and see what we get. I think it's going to be a 3. There we go. Magic. That's where the magic happens. And now let's look at these capitalization functions. Upper, lower, and capitalize. Let's call upper on this one. Cool. Let's take a look. Upper is going to change all the letters to uppercase. Now I'm yelling at you. Hello, world. I'm here. Let's look at capitalize on it. All right. And yeah, I didn't say much about capitalize, but it is going to capitalize only the first character of the string. Only the first character, and everything else stays as it is. Let's scroll down a little bit. Let's look at these next three. Is upper, is lower, is numeric, is alpha. These are what I call checker functions because they check for a certain condition. These functions will give you a Boolean value. They'll give you a true or false, depending on the result of the check. And you're typically going to use those in if and elif statements. It's going to be something like, if the string is upper, then you're going to do something. That's how you typically use them. And so how do they work? The is upper and is lower, they're going to give you a true if the string is entirely uppercase or entirely lowercase. The whole thing, not just one or two letters, whatever. The entire thing has got to fit that condition. Is numeric, it actually is similar, where the entire string has to be a number for is numeric to be true. If any part of the string is not a number, it'll give you a false. Similar for is alpha. Is alpha, everything in the string has to be a letter or it is false. Let's try out one of these, or maybe a few of these. I'll decide right now. I'll try is numeric. Is numeric, again, these return true or false, and we're going to do it on a string. And it's like, is a string entirely numeric? Of course it isn't. So it's going to give me a false. Now what if I change it to all numbers? Gives me a true. Yeah. So there you go with that. And if I add letters along with it, see, that gives me a false because, like I said, it's got to all be numbers for it to be is numeric. All numbers. Let's try another example. Let's say is upper. You see these are all lowercase. Is upper going to be a false. How about is lower? They are all lowercase, so that is a true. So that's how you use these. These are going to be checkers where it's, is the entire string, does the entire string fit this condition? If so, true. If not, false. Now we will look at replace. Replace is going to replace a portion of a string with another string. And it creates a new string once you do the replacement. So when you call replace, it's going to produce a new string from the replacement. So we have a string here, hello, how are you? Then we have another, or we have a usage of replace, string name dot replace, you and we. And so here is what you supply the replace function with, and how it works is that the first thing you put here is the old string that you're replacing. What you put next is the new string you're replacing with. So it goes in this direction, right to left, old over right to new. So in this situation, we are replacing you with we. So instead of how are you, it becomes how are we. And there we go. That's how the replace works. Yeah, let's I'm going to copy this into the old charmer here. See how it goes. Yeah, Formatting is all good. And notice it gives me those little hints here where it has the old and new. These are things from PyCharm that's it gives you hints. That's what that is. Alright, let's run it. There we go. Hello, how are we? We. All the way home. And there you have it, folks. String functions. And you'll see me in the next module. That's all I have for the strings. We covered strings quite a bit, went over quite a bit of stuff, and now you're schooled up on strings. There's definitely more to see, and you'll see more as time goes on, but I, or you, will see me. Now let us take a look at the concept of lists. And lists are containers that allow you to group individual units of data together. Lists are the foundational data structure in Python. And they're powerful as they allow you to group related data items together for organization and make automated processing of many items easier. I always liken lists and data structures to something like a physical cardboard box where you could have items individually in your house. When you take the items and place them in a cardboard box, they are together in a unit and they could be carried together as a single thing. Lists are kind of similar in that you take individual data items, put them into this list container, and you can carry them around really in a variable as a single entity. And then you can do processing on them in kind of a batch format. And there is power in grouping, definitely. And lists, they can contain any data type, including other lists. You can also group different data types within the same list. Now let's look at these list examples syntactically. With this first one, you have list underscore example, and the syntactic creation of a list is like this, where you have a set of square brackets on the outside, almost like a box, right? So there's that analogy again. And you have the brackets on the outside, and then you have data items separated by commas. Now going back to the definition, it says contain any data type, including other lists, and you can group different data types in the same list. This first list is an example of grouping different data types in the same list, because you see string, integer, float. And this is kind of an example of what you could use to begin a basic sports stats database, where you have an individual's name and you have several stats of different data types together. You could develop a grouping of these, and you could do stats for a whole team and do some analysis and manipulation on these stats. But there's gives you a little piece of what's possible with the list. But going back to the definition, you can put different data types in the same list together. Does not all have to be the same. In the next example, we have a list of only integers. Of course, there is also power in just having the same data type together in the same list. Could be all related data. Maybe they're all readings from a machine, and it puts them in, the machine plops in I guess that's not the greatest word, plops in the data reading, once every minute, and it's always the same data type. But whatever it is, Yeah, grouping related data together, there's power in that. And we have a list of integers here. And then a list example 3, we have just different data types, and we even have a list inside. And see, that goes to another part of the definition, or it's not really a definition, it's a point. It can contain other lists. Here we have another list inside of list example 3, and you can totally do that. And you can create a lot of depth in your list, where a list inside of a list is called a two-dimensional list, and it allows for a lot of depth, and that's as far as I'll go with that. But you can have lists inside of other lists, and then we have an integer as the last element there. And that last word that I said brings up an important vocabulary term: element. An element is a single or individual piece of data in a list. That is called an element. Remember that word because it is used across programming languages for the same idea. In programming languages, a single piece or an individual piece of a data structure is called an element. And here with lists, a single piece is called an element. Remember it, remember it, remember it. You will hear it again, probably in a minute or so. Let's look at the creation of lists through initialization. Lists can be created with or without items in them. Here we have a list creation where I'm creating a list with items in it. My list equals 5, 4, 3, 2, 1. It's got items in there at the beginning. So I'm creating a list, putting items in it right away. I'm bringing up this point because you don't have to. You can create a list like on this next line that is empty. When you create a list that's empty, it's kind of like a placeholder that says, I'm making this list now, but I'm going to put stuff into it later. It's a placeholder that says, put a list into this variable, and I'll put stuff into it later. That's the idea. Kind of like you build a cardboard box and have it empty, set it off to the side for when you're ready to start moving and placing stuff into it. All right, let's get into some more usage of, or get into some usage of lists, looking at indexing and slicing. Now, I covered this topic when we looked at strings in the last module. Lists can also be indexed and sliced like strings, and the idea is the same. Indexing allows you to get an individual item from a list by using an integer number as a location number. Slicing allows you to get a subset or a sub-range out of a list. And yes, both indexing and slicing are based on the usage of integer indexes. So we have a list. You say there's a list. There's a list right here of scale strings. Do, re, mi, fa, sol, blah, 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 so on and so forth. We got these scales. And then I index using 5 into scale, and that prints la, because 0, 1, 2, 3, 4, 5. Index 5, index 5, index 5. Yes, see how that matches up? It's beautiful. And the next example, we have scale slice equals scale to 6, 2:6. This is slicing syntax, where this is going to give us a subset of this list. It's going to give me a smaller list that is a sub-range of the list. And it's denoted, or it is specified by indexes indicating a range, 2 to 6. And remember that with slicing, the ending is not inclusive. It is the index of the previous element that is included. So if you specify a 6 as your ending index, a 5 is really going to be your last index. So scale 2 to 6 is really going to be 2 to 5. Just another thing they do to make programming more confusing. It is what it is, folks. So we start at 2 over here. There's the beginning of our slice. And then 5 is going to be the end, because 6 is the stated end, but it's not official because the ending is not inclusive. So it goes 2 to 5. So it's going to be mi, fa, sol, la. There you go. And next point is that unlike strings, lists can be modified via indexing. Like, you have a list, you can decide that in this list I want to take me and change it to something else. You can modify it via indexing. Using indexing syntax, you can change me to whatever you want. I'll change me to whatever I want. That's the personal development, right? Okay, you have this list, and then looking at this, this syntax here, we index into index 0, and we say it equals yo. What happens there is that this new string is assigned to that location. So the element at index 0 becomes yo instead of whatever it was. This just overwrites what's there, and it becomes yo. So looking at scale, index 0 is do, so that gets crossed out and becomes yo. Looking at the next one, scale index 2 becomes we, so it gets crossed out and it becomes we. So the act of modifying via index is that whatever is there is overwritten, and what you specify becomes the change. Now let's demo some of these, or maybe all of them in PyCharm. Got my list of scales here, my list of strings. Let's do that basic indexing. Yep, just like strings, you can index to get an individual element of a list. So we have la, index 5. Let's look at slicing. And I'll just use this right here, 2 to 6. Remember, it's really going to get 2 to 5 because the ending is not inclusive. And see, what it does is it creates a sub list when you do this. It's a separate list, not connected to the original. It takes out these elements and puts them in a brand new list. So I can assign this to a variable if I want, just like it's shown right here. So there's the slicing. And then let's do the reassignment, where I can take it, I can index into any of these and change them using indexing. So let's say if I do scale, say scale 0 equals, now let's put my name in caps. I'm going to change do to Dean. Then I'm going to print it out. And see, instead of do, it is now Dean. So there's your list modification. So yeah, lists can be modified via index. So you got an example here, and you got an example over here. Plenty to chew on, folks. Now let's dive back into the document, shall we? And cover this last point of the video called negative indexing. Indexing can also be done with negative That's funny. What does that sound like? Indexing can also be done with negative numbers, and this is called negative indexing. Negative indexing begins with a -1 at the rightmost element and proceeds to the left. So if we have say we have a list of characters, or I guess you could say a list of strings, because that's what they really are, where each string is an individual letter, and it's in the form of Pythonic, kind of like you saw with the previous module. We have a list of characters, I misspoke again, we have a list of strings, Pythonic. Negative indexes occur from right to left instead of left to right, as positive ones do. So starting on the left with -1, and then we count down. I think I said that wrong. Starting on the right with -1, counting down, going to the left. So we have -1, -2, -3, blah, 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 so on and so forth. Negative indexing is really just another way to address the elements of a list. Positive indexes work as well as negative indexes. So what this brings rise to is the fact that each element of a list really has two indexes, a positive one and a negative one. Of course, positive indexes work the way they always have, but then negative indexes do as well. So let's look at the P, for instance. The P here, you see it has a -8 index. It also has a crossing myself up. It also has a 0 index, a positive 0 or a 0. And it has a Y as a 1, 2, and so on. So each element has a positive and negative index, and it's really a choice as to the one you want to use. Negative indexes have limited use, but they're helpful for flexibility. Negative indexing can help you access elements from the end of the list when the length of the list is not known. And an important use of it centers on the index of -1. You can always find the last element of a list using index -1, like you see here. Index -1 is the end of the list. And it's always going to be the end of a list because it's the rightmost index. So it'll always allow you to find the end, whatever's at the end of a list. If you look down here, we have 1, 2, 3, 4. Index -1 will be 4 because it's the end of the list. So that -1 is always going to be useful, but the other negative indexes come in handy in certain spots. It's just another thing, another rule in Python that allows for flexibility. Because it's good to have options when you're solving problems. It is very good to have options. I've been there, folks. Now let's look at negative indexing in code. And we'll just use the scale since it's already here. Do some negative indexing. Let's see, scale -1. We have T, of course, that's the end. And then, so once again, illustrating that -1 is the last element. How about we get rid of a couple of elements and we do -1 still. Now it's going to be the last element, which is now saw instead of whatever the last one was. I don't remember now. So how fried my brain is, folks. Okay, we bring it back, do index -1 again. Now we got T, because it's the last one. Let's do a different index. Say -5. -5 is me because it goes backwards like this. It's -1, -2, -3, 4. -5 is me. There we go. And I was saying the fact that each element has really 2 indexes, like 2 addresses. Look at it with me. Me is also, it's also a +2 index. So if I put a +2 index, it's still going to give me me. So you have both ways to address elements. Yep, still me. Always will be me. It gotta be me. Okay, folks, that demo is done and the video is done. And next we're gonna look at looping and functions with lists. Welcome back, and now we're going to look at looping with lists. L's are wild, right? Looping with lists. Much power is gained from traversing lists using loops. Using loops with lists allows for automated processing. I kind of made this point before where you can put things into a collection and then you can run them through an automation. Well, you're about to see how this works. You have already seen how the for each loop can access all the items in a list. When I introed the for each loop, I used a list because I had to, so you've already seen how this works. Here we have a list of beetles and human beetles, not actual beetles. And we have the fab4, or the names. And then we go for beetle in beetles, print beetle. It's going to go through the for each loop. It's going to go through one at a time, place each name in beetle, and then print it out, just one at a time. There's your basic list processing using the for each loop. But you've seen that already. Let's look at another example here. Or an example using for range. It's not really another example. It's a new concept, really. So I mislabeled that one. Anyway, a form of the for range loop can also be used to go through a list item by item. So this is new for you. You can use the for range loop to go through a list as well. And a lot of the times, this is going to be your preferred option to use the for range loop to go through a list. So far, you've only seen the for range loop used in accounting scenarios, sort of, and you've seen it used to go through strings, but you can gain a lot using for range to go through a list, and here's how you do it. We have our list here, and then we do for I in range, len beetles. You saw this with strings where we're using the length of the structure, here being a list, we're using the length of it to insert into range, and that is going to govern how many times it loops. When you want to process a list, item by item, it makes sense to loop as many times as there are things in the list. Like here, we got the fab4. There are 4 things in this list. And the length of beetles is 4. So you could almost cross this out and put a 4 because that's how many times it's going to loop. But it's going to be better practice to use len because the size of a list can change, the length of a list can change. So you want to use len instead of hard coding, as it is called, the length of a list. In the body here, of course, we indent. And what's happening here, you print, and then Beatles index I. This is going to give you the element of every index in the list, because because of how range is going, I is going to go from 0 to 3, and it's going to capture every element of the list. And as the text says, this instance of the for range loop will do the same thing as the previous for each loop, just using a different syntax. The for range loop utilizes len to obtain the number of items in the list, and it also uses variable indexing with I to access each index as it loops. So, good stuff there. So yeah, both of these do the same thing. The range loop, or well, they do them with the different syntax. Get tongue-tied again, folks. Again here, folks. I can't even explain my tongue-tiedness. All righty, let's move on. And let's check this out. The while looping works like this, where we have a list here, and then we do our I equals 0, because with while you have to set the value of I explicitly. Like it's not automatic like it is with the for. Well, it's not automatic with the for loop, but it looks like it's automatic. Anyway, set I to 0, and then we do while I is less than the length of Beatles. Remember, the len is going to give you the number of items. So in this case, it's like saying while I is less than 4, we're going to print the indexed version, or not the version. We're going to print indexing with I, and then we're going to increment by 1, because if I does not increment, it's never going to get to 4. So it's going to go 0, it's really going to go 0 to 4, but on 4 it's going to bail out and go down to the next code. But here's how you would traverse a list using a while loop. Almost said for. I am not on autopilot today, folks. I'm thinking here. Trust me. Let us now look at each of these with some code runs. So here I've got my list of Beatles, and you've seen the for each loop already. So this is it's kind of old hat. Now let's modify this for the for range. Let's just modify it in place. So this, it'll give us the same thing, but now it's using the for range loop. Oh, typo. There you go. And then let's modify this for the while loop. Do it again, folks. I guess this could be fairly instructive as well. Watch me work, folks. And there we go with that. And then we just need the I plus equals 1. And it'll give me the same output. There we go. Same output. And how about this? I like to do this sometimes. If I omit line 7, see what happens. George Harrison, the only Beatle. Very good, very good. And that's because it's an infinite loop, because I will not increment. Just wanted to show you that. I stays at 0, which means it's going to only catch index 0, and that's what it does. Okay. On to the next topic. Now we will look at list functions. So we talked about string functions before. Well, list functions are provided for similar purpose, where these allow you to do commonly needed things with lists, so you don't have to do the code yourself. These are just time savers. They're tools that allow you to better use lists easier. From the makers of Python. That's a generic term that I use there. Good stuff. Okay, append is the first one, a very useful function. It adds or appends a single item to the end of a list. Here we have a list of goats, and if you can't tell, these are sports ghosts, not ghosts. They're sports goats, greatest of all times in their sport. Debatable, but hey, it is what it is. Here's how you call the function: goats.append. See, when you have a function that is according to a data type, it's always variable name dot function. That's the format that I shared with you in the strings lesson. And then you put what you're appending. It's going to add hawk to the goats list, so that once I do this, and if I print out goats again, it's going to have hawk in it, in addition to what's here. And I'm going to do the dual screen on this one so I can demo it. And get my list of goats together. I don't think it's going to copy over well, so I'll just do it. Jordan. Okay, then if I do goats.append hawk, then we print hawk. No, print goats. Gotas. Is that the Spanish pronunciation? Gotas. And notice in the end now hawk is there. So append is going to add to the end. Yes, yes. All right, the next ones, index and count. These share functionality with the same functions from strings. String has index, string has count. Same thing here. Index is going to give you, it's going to give you the integer index of the value that you supply to it. Now let's do that real quick here. Let's do index Brady, and I'll have to print it out. If I want to see the index. One. So that means Brady is at index 1, of course. And there's an example in the text. And count is going to give you the number of occurrences of something in a list. Here, every name only occurs once, so it's going to give you a 1. So that's that. Here are some cool functions. Sort. Sort is going to sort a list in ascending, meaning least to greatest order. And you have a list of integers here. You call sort, and then it's going to print it in ascending order, like least to greatest. I think this is one of the coolest functions that you're going to see in basic Python. It's like it's a cool automation where you can take a list that it has a hodgepodge of numbers in it, you hit sort, and it will sort that list. Hell of a time saver, right? Because I'm assuming most of you don't know how to write sorting algorithms on your own, so it's like, bam, pop it in there, and it's going to sort it. See that? 1, 2, 3, 4, 5. That is cool, man. All right, reverse. Reverse is going to reverse the order of a list. Reverse is not sorting, it's going to reverse the order. So you start with this, you hit reverse, and then it just flips it. So over in PyCharm, let's change sort to reverse so you can see what it does. And as the text says, it's going to reverse it. And cool how that works. I'm just seeing how much I got left here. Okay. Okay, the next two functions are removal functions, where I said this before, that lists, you can add stuff and you can remove stuff from lists. Well, these next two allow for removal. They just remove in two different ways. So the first one, pop, is element removal, and it's really element removal by index number. But it has two forms of it. The first form of pop is where you can use empty parentheses. And if you use empty parentheses with pop, it's going to remove only the last item in the list. Well, yeah, it'll remove the last item in the list if you do empty parentheses. So it's like an unappend. It's like the opposite of append in this case. So it'll just pop off the last item, whatever that item is. If you use it with a number inside the parentheses, it's going to remove the item at that index. So if I put a 1 in there, it's going to remove the item at index 1. So like, you look at this list, you hit a pop 1, Brady is going to be gone, and it's going to print Jordan Gretzky Bonds. Let's look at both of these forms here. If I can get the goats list back. There's the goats list. Let's see, goats. If I can spell it. Let's do a different one. Let's do pop 2. Then print the goats. For some reason, I don't like to do the same example that's in here all the time. Seems kind of boring to me. I don't know. What's the best way to do it? Anyway, 2, I'll remove Gretzky this time. And so you see Jordan Brady Bonds, no Gretzky. So that's one form. That's the, the second form that I talk about, where you put something in there. If you put nothing in the parentheses, it's only going to remove the last item. I don't know why I keep saying only, but because these only remove one at a time anyway. So I hit pop here. So from this one, it removes bonds, because that's the one at the end. So pop with nothing in the parentheses is going to remove the last item. It is like an unappend. And that is pop, folks. It goes back to the idea of the stack data structure, if you know what those are. All right, let's look at remove. Remove is another removal function, and it's going to remove based on value rather than index. So the reason you have two removal functions is that one removes based on index, and the other removes based on value, and that's remove. Remove will remove based on value. And for values with multiple occurrences, it removes the first occurrence only. So if you have a few occurrences of something in there, you do remove on the value, it only removes the first one. So if you want to remove several, you might need to loop to do it. I will not be showing you that here. But I will be showing you the example of, we have a list of fruits. And then we do this list dot remove, removing banana. What that's going to do is remove the first occurrence of banana only. And so it prints apple, cherry, banana, kiwi, removing the first occurrence of banana that is in between apple and cherry. Let's look at that one, shall we? And let's do a removal. Variable name dot function. B-A-N-A-N-N-A. Actually, I don't recall how to spell banana. I don't even know if that's right. And it's not goats, it's going to be this list. Caps. No caps. And you see it removes the first one. If I call it again, let's take a look here. I do it, and then I do it again. It'll remove the next occurrence. So every call will remove like the next one. So if I do it again, you see, banana's all gone. How about if I do it again when there's no bananas left? You actually get an error. So if what you're trying to remove is not there, you're going to get an error. There you go, folks. A little bit extra info, giving you value up in here. That's what I do. All right, let's look at the last function here, insert. Insert is another addition function. Like you can use this to add stuff to your list. Like append, you can add stuff. But insert, it's not just going to insert it at the end. You can choose where to insert it. No jokes here, guys. I know guys would have a joke for that. But insert is going to insert the given value into the list. I'm cracking up on that one myself. I couldn't stop. Well, whatever. Okay. Composure. It's going to insert the value in the list at the specified index. When inserting, it's going to shift the remaining items to the right by one index. So insert, it allows you to put something into a list at a certain spot. You remember, append just puts it at the end. Well, insert is going to allow you to surgically go in and put it at a certain index, and it's going to shift everything that was there to the right. Like it's going to put something at a certain index, and the thing that was at that index is going to go to the right, and then everything else is going to go to the right as well. So interesting process. We can look at it here, where you have this list, and then you have apple, blah, 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 blah. Then you do this list dot insert, and here's how you use insert. It is the index, comma, the value that you're inserting. So we're going to insert chicken at index 2. Let's go index 0, 1, 2. So the process here is that it is going to get rid of cherry. It's going to put chicken there, and it's going to shift everything over to the right. So it results in this, where it is apple, banana, chicken, cherry is still there, banana, kiwi. Good stuff. And of course, we are gonna run this one. What would this be without a PyCharm run? You're gonna get tired of me saying PyCharm. This list dot insert, and we're gonna insert 2, and I'll do the same example that's here. And then what you're gonna do is print what I'm gonna do. Is print the name of the list, or print the list afterwards. And you see it gives you a little hint: index, object being the value or the thing that you're going to insert. No jokes, guys? All right, so we see apple, banana, chicken, cherry, banana, kiwi. So you see chicken is inserted at index 2. All righty, that is a big check mark, folks. Done with the concept of lists, and then we move on. So that is the end of this module. You will hear me in the next one doing more Python teaching. Until then, I'm out. Hello and welcome back. This time we are looking at the data type of dictionaries, a new data structure for you. And yeah, dictionaries are a data structure like a list is a data structure, a collection of individual entities. But the dictionary is definitely a step up from a list and adds an extra layer of organization to the data structure. And so let's dive in here. Dictionaries are data structures where the elements are stored in key value. Actually, they are data structures where the elements are stored in pairs rather than individually. And if you remember with lists, the elements are stored one thing at a time, or it's just like integer, comma, integer, comma, integer, comma, one thing at a time. Dictionaries are different in that the elements, the individual units, are really stored in pairs. It is pairs of things together that comprise the base elements of a dictionary. The pairs in dictionaries, they consist of 2 related items, and they are called the key and the value. So in dictionaries, each element is composed of a key and a value, basically fused together. That's the idea behind the dictionary. And they're going to be related items. Like think about if you had a database of names and social security numbers, or names and salaries, or something like that, where the 2 pieces of data were related and they're kind of fused together. I like that word, fused, in this case. The first item in each pair is going to be called a key, and the second item in each pair is called a value. So a dictionary is a collection of key and value pairs. In dictionaries, the keys are going to be used to locate the values. And dictionaries are set up such that the items in the pairs are going to have a logical association to each other. Yes, they're going to be related, they're going to be associated. And that's really kind of brings up the power of dictionaries, where the power is that you have association between the 2 items. And so it brings a greater sense of organization to the data. Yes. and the keys are used to look up the values. Dictionary keys are somewhat like indexes, like, you talk about indexes in with lists. Like a list, you look at use index 3 to find the fourth element in a list. In dictionary, the keys are kind of like those indexes because they're going to be used to look up the value. Like going back to the example of the name and the social security number association. To look up a social security number, you would use a name. Like if I want to find Dean's social security number, I would look up Dean in the dictionary, and then the social would be next to it, because these key value pairs are fused together. Dictionaries cannot be addressed by numeric order like lists, because dictionaries are unordered. That's just not how they work. Numeric indexing by order does not work with dictionaries. See, really with dictionaries, the indexing happens with the key to look up the value rather than an integer that indicates order, like 0, 1, 2, 3, whatever. It just doesn't. They don't work that way. The keys in dictionaries have to be unique. They must be unique because the keys are lookup mechanisms. Having duplicate keys would damage the ability to locate values based on keys. Because keys are the way that you find data in a dictionary. So if they're not unique, then your data organization is messed up. So, like if you're going back to the names and social security numbers, if you're looking up the social security number for Dean and there's 3 Deans in the dictionary, that's going to be a mess, because like which Dean is the right one? So they must be unique. Now let's take a look at how dictionaries actually look syntactically down here. Some basic examples of dictionaries. So here we create a variable called ages. Make it equal to, and then this right here, this is a dictionary where the dictionary definition begins with curly braces to open, curly braces to close. And you remember with lists, where lists use square brackets to open and square brackets to close, dictionary uses the curly brace, so kind of a differentiation there between data structures. And then inside the dictionary, you have key value pairs separated by commas. You see comma, 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 and each key value pair consists of one piece of data, a colon, then another piece of data. The data before the colon is the key. The data after the colon is the value. That's how it works. So it's key, value, and then separated by a colon. And that's how the dictionary goes. It's key value, comma, key value, comma, for however many key value pairs you have. And you can use a variety of data types for the key and for the value. Here's another example of a key value pairs. We have a dictionary with the variable name Instagram. And what these are string names and then a string Instagram handle. So like if you want to find the Instagram handle of an individual, you use the name to look it up. Like Dean's handle would be that, Wes would be this one, and then David's would be this one. So you see the association idea there. So it's kind of like it's a more intelligent data structure than a list. Not that lists are bad. Lists are good for their purpose. I am not hating on lists. Let's look at the creation of dictionaries a little bit more. Like lists, dictionaries can be created with or without items in them. Items in a dictionary have to be created in pairs, separated by colons like you just saw. Each key value pair in a dictionary is separated by a comma. The entire dictionary is closed in curly braces. Here in blue, we have two examples of the creation of dictionaries. We have this first example, books, where the dictionary is empty. And just like lists, this is kind of a placeholder to say, later on I'm going to add stuff to the dictionary. But right now, it's empty. It's kind of like reserve this for later use as a dictionary. And then the next example, we have fruits, where we actually have data, where it is string key, and then the values are integers. The values are integers. And you could liken these to, like, maybe it's like an inventory, where you have a fruit stand and you have 15 apples, 12 oranges, 30 pears, and so on. So I think you're getting the idea of dictionaries right now. The brain is busting right now, busting at the seams. Let's look at some usage principles on dictionaries. In dictionaries, values are retrieved by specifying a key. So yeah, you get the value by looking up with the key, kind of like a book dictionary. To find the definition of a word in a book dictionary, you look up the word, and right there next to it is its definition. The same idea with dictionaries, and probably that's why they're called dictionaries in Python. So looking up using a key is called key indexing. Kind of like numeric indexing with lists, where you look up using a number because of the order. With key indexing, you place the key inside square brackets, similar to how you would place an integer inside square brackets to index a list. The result is the retrieval of the value. So we have a little thing here, a little snippet, where I've created a dictionary where it is name for the key, and then the value is a phone number. And the values are, these are both strings, denoted by the quotes. I think that's blah, 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 blah. Stop talking. We'll talk about something else. Name, or a string, colon, string. The phone numbers are strings as well. So this is kind of a lookup where you can look up the phone number by using the name. Yes. And we do this on the next line. This is what I refer to as key indexing. You have the name of the dictionary, square brackets, and then the name of a key, or a key inside the brackets. So this is going to get to Joshua's phone number, which is going to be this, thus this. There we go. And that is how you can look up using a dictionary. This is an important enough concept that I am going to pop it into PyCharm. And over here I have a dictionary. That's from a previous run there. Actually, I have two dictionaries. And I'm going to show you key indexing here. And now we'll do it inside of a print statement. I'll do the phone numbers dictionary. And we'll look up Marguerite. Yeah, this indexing is reminiscent of how you would index using a list. Or it's reminiscent of how indexing works with lists, but instead of a number, you have the string key. And yeah, cool how that works. You get the number or the value by looking up with the key. Let's do it with this fruits. One dictionary. Let's look up oranges. I get 12, and that's 12. This is how key indexing works, folks. Okay, back in to the work. Next point is that values in dictionaries can be overwritten by indexing using a key and making it equal to the new value. So you can change the values in a dictionary by indexing using the key. So here we index using the Jackie key, and we create a new number. And there we go. So then we print out the dictionary again, and Jackie will have a new number. Somewhat reminiscent of how you can change values in a list, but in this case it is you index using the key and the value will change. The key, of course, is going to stay the same. The value that it points to is going to be different now. And here would be your output, where the output of printing phone numbers, where Jackie in red now has this number instead of the one that it had before. So this is how you can change, overwrite the value for a given key. Like my slow delivery there, yes. Another point, to create a new key value pair in an existing dictionary, you're going to index into the dictionary using the new key and set it to the desired value. So this is a situation where, let's say you've created the dictionary already, it already has data in it, but you want to add a new key value pair. This is how you can add a new key value pair. You'll index into the dictionary like the key is already there, but this is a new key, and then you make it equal to whatever value you want to make it equal to. What this is going to do is add a key value pair with the name Dean to the dictionary. So adding a new one, a new key value pair, is index with it as if it was there, and then make it equal to a new value, and then it'll have your new entry, your new element in the dictionary. And a final point on usage is to remove key value pairs. So we talked about adding, now we're going to talk about removing. To remove key value pairs, you can use the del statement. And it's just interesting syntactically, this one, as opposed to some other things. But you'll type del, and then you will index into the dictionary using the key that you want to delete the key value pair for, and it will delete that key value pair. It'll delete both pieces of it. And yes, this will delete the key value pair with the key Jackie from the dictionary. So deletion is del space and then index into the dictionary using that key. Now, I went over a lot of stuff here, so I'm going to demo these last few points here. First thing I'm going to look at is changing the value associated with the key, like we did with Jackie here. What? Dictionaries. And I will comment to make it easier for y'all to get these points. So looking at the phone numbers dictionary, let's just change Jackie like it is here. So let's make this a new number, and then we'll just do the 555s like it is in there. So yeah, it is index in and set it equal to a new value. You see the value, the existing value up here, I'm making it a new one. And let's just follow the same format. There we go. Now when I print, you see Jackie has changed. Of course, the others are unchanged. That's changing. And now let's take a look at adding a key value pair. To add a key value pair, you're going to index into the dictionary like it's already there. And notice you look up at line 4. Look at there. There's no Dean in here. I'm going to add it like this. And then I am going to print it out. Now looking down below at the bottom, you see Dean is now here. So that is the addition, adding a key value pair to the dictionary. And finally, I'm going to delete. I'm going to show the deletion of a key value pair. It looks like this. You use the del keyword and then you do indexing. We'll delete Joshua this time. Delete Joshua and then print the dictionary. And you see only Jackie and Marguerite. I got rid of the addition of Dean because that code is no longer here. So Jackie, Marguerite, no Joshua. Joshua's gone. And let me add this here just to show you a little bit more here. Delete Jackie as well. I delete both of these. There's only going to be one left. Yep. Only Marguerite is left. All a very small phone book there. All right, let's get into this next topic of looping dictionaries. So as you might guess, dictionaries can be processed in loops. The for each loop is the only kind of loop that can be used effectively with dictionaries. You can try to use the other kinds of loops, but it's more of a, it's more difficult. The for each loop is kind of more made for dictionaries. And so that's what we're going to look at. When looping through a dictionary, the variable after for is going to be used for the key in the for each loop. So for dictionaries, use the for each loop, and the variable in a for each loop is going to hold the key as you loop. Let's take a look here with this example code. We first have the creation of the dictionary. Then we have the loop. And for this loop, it's our fruits dictionary. For F in fruits. This is the variable I'm referring to. This variable, F, is going to hold the key. That's very profound, isn't it? Holding the key. But yeah, it's going to hold the key each time as you loop. So it's going to get to all the keys. And the keys in this dictionary are apples, oranges, pears, mangoes. It's going to loop and get apples, oranges, pears, mangoes. And you see down here, it's going to print all of those. So that's basic looping using a dictionary. You're going to traverse through and get all of the keys. Those are going to be stored in the variable. So thinking about the keys, of course, I said before that you can use keys to look up the values. So as you're looping through a dictionary and you get every key, you can then use the keys to look up the value if you want to. So you can have keys and values be accessible as you loop, because all you need is the key. Once you have the key, you can look up the value, and you can do print the keys and values together, or do whatever you need to do with the keys or the values, because you have the key. You hold the key, my friend. And as you saw earlier, the key can be used to retrieve the value using key indexing. So here is a modification of the previous loop, this right here. Modification of the previous for each loop, where you still go for f in fruits, and then in your print statement, instead of just printing f, you print the index, the indexing of f in the brackets. See, f is the key. When you index with the key, I think that's a k. When you index with the key, you get the values. See down there? So those are all the values. So in contrast to the last one where we're printing f, we do indexing with this one, so we get all of the values. And we can combine. They can be both printed together. In this last loop here, we go for f in fruits, and then we use f string situation to, we print the key, and then we get the value by indexing. So then it results in this kind of printout where we have the value, is the key and the value on the same lines. That is cool. I'll demonstrate these for you after a long period of silence, right? Was that awkward for y'all? Wasn't for me. The wheels was turning. Okay, this is your basic for each loop with a dictionary. Just going to give me, those are all of my keys, as you see, key, 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 and so on. And the modification here is I can use f to look up values. So if I do this modification, now I get all of the values. You see down here? Those are all of my values in the pair. And I can then go a step further and print my key value pairs together using the f string. I change my print statement there. I get a nicely printed situation where I've got the key, the value, same line, nice little printout there. But yeah, from here you can go a lot of places, but this is just showing you really the basic traversal of a dictionary using a loop. And the for each loop is going to be the one to use with dictionaries. That is it for the Dictionaries module, and you'll have some exercises to do on Dictionaries. But until then, until you check that out, this is me saying goodbye. Hello, we're back, and now looking at the topic of tuples and sets. Tuples and sets, these are two kinds of data structures in Python, and they are quite different. They are used less than your dictionaries and lists, and I'll be covering them in really less detail because of that, but they are nonetheless important data structures contributing to the whole of Python. So tuples. Tuples are data structures. They are very similar to lists, but they cannot be modified once created. So really, they are like fixed lists, where you create a tuple, you put things in it, and then you can't change it. They are locked in, fixed. They are constant data structures. The common term used is immutable, meaning cannot be changed. Mutable, like mutate, means able to be changed. Immutable means not able to be changed. They can be indexed and sliced like lists. Their set of available functions is similar to lists with the omission of functions that would modify them. So I don't list the functions here in this module that are available with tuples, but really, they are the functions that the same functions you would use for lists, other than the ones that would modify because a tuple can't be modified. An example would be a thing like sort, a function like sort. It modifies the list. It sorts them in ascending order. You can't use sort on a tuple because once you put the information, once you put the data into it, those locations are fixed and they cannot be moved around and sorted. So things other than sort would be available. Let's look at initialization of the tuple. Tuples are initialized using surrounding parentheses with data items inside separated by columns. To initialize a single element tuple, a comma is required after that single element. If the comma is not included, it's going to be interpreted as a single value inside of parentheses. And you'll see what I mean after this first example. This first example, a tuple is created with parentheses around, and then you have the data items separated by commas just like you would with a list. So really the distinguishing characteristic of the look of the tuple is the parentheses. And in Python, the data structures are really differentiated by the enclosing symbols. A list has the brackets enclosing. A tuple has the parentheses enclosing. The dictionary has the curly braces enclosing. So you see here, the pattern is that the enclosing symbol kind of tells you what kind of data, or what kind of data structure, data type the stuff is. Let's look at this next example. In this next example, this is what I mean with the, if you're going to initialize a tuple that has only one element, you must put a comma after that one element, or else it's going to be interpreted as a single value inside parentheses. So it's going to be interpreted not as part of a tuple, it'll be interpreted as a single value. So the comma afterwards is important. Next thing, usage. Scroll up, scroll up. This really is how you use tuples. So a tuple can be indexed and sliced. We've seen indexing in other modules where you, just like a list, this is going to get indexed to the third element of the tuple. And then this next one, this is a slice going from 1 to 3. And it says print elements from index 1 to 2. That's because the upper limit is not inclusive, where it's going to go index 1 and 2, and it's not going to do 3 because the range of a slice is not inclusive. But the slicing works just the same way it does with a list or a string. Tuples can also be concatenated like strings can, where you take a tuple 1 and tuple 2, here shown as T and U. If you do a plus symbol on them, what it's going to do is combine them into one tuple, and the new tuple is V. It does not modify the two tuples because tuples are not able to be modified. It's going to create a new tuple, and that tuple's name will be V. So tuples can be concatenated. And here's a little tip. Lists can also be concatenated, although I didn't cover that. So take that little nugget and run with it. So here, this is about functions. List functions that do not modify the data will work. So really, look at all the list functions that do not modify data, and you can use them with tuples pretty much. And here I'm going to look at the count, and the index functions, where I've got a tuple here, and you get remember, count is going to give you the number of occurrences of a value. So if I get the count of 12, it's going to give me a 3 because there's 3 12s in here. Looking at index is going to give me, index of 7 is going to give me the numeric index of 7, which is going to be 5 because you start 0 here and 5 here. 1, 2, 3, 4. It is the 5th index. So list functions can work on tuples as well. Here is another point about tuples. This is really about use cases of tuples. Tuples are going to be used for data that does not change. And there are some important use cases of that. It can be used for fixed data like coordinates, RGB data, which is red, green, blue color data, or storage of a reference chart like an alphabet, things that do not change. And here's some examples. Tuple T has coordinates in it, like a latitude, longitude type of thing. Of course, the location of a city is not going to change, at least not anytime soon, right? So the latitude, longitude of the city Miami in Florida, it's going to be fixed. It's not going to change. So you could throw that into a tuple if it needs to be part of a data set that you're using in Python. So that's a good example. Another example is the alphabet. Alphabet doesn't change. So you could throw it into a tuple, and you could have the letters at fixed locations because A is always going to be the first letter in the alphabet. So if you need to use that in your code, you can go ahead and do that. And these last two examples are really this is color data like RGB, where you have separate numbers for the amounts of red, green, and blue, and these amounts will not change for a certain color. So red's going to be these 3 color combinations. Yellow is going to be those 3 color combinations. So there is the talk about tuples, folks. Now we're going to look at the data structure of sets. All right, looking at sets. What is a set? A set or sets, they are unordered, mutable, meaning changeable like we covered in the last piece. Tuples are immutable, sets are mutable. Sets are unordered, mutable data structures containing only unique elements. Only unique elements, that is important. Sets are unordered and cannot be indexed. That's another important point. If something is unordered, it cannot be indexed because indexing refers to order. Think about indexing a list where you have index 0, 1, 2, 3, whatever. this is the ordering, the location of the data. Sets are unordered, thus they have no locations. And the order that a set is in right now could change the next time you retrieve the set. So you can't rely on the order of a set. They are unordered. They are just, think of them as, well, unordered. I can think of an analogy quick enough. It doesn't matter. Okay, let's talk about creating sets and a little bit of usage. Sets are created by enclosing comma-separated data inside of curly braces. An empty set is created using the set function. Now, I talked about the thing in Python that separate data structures are really, they are almost identified by the enclosing symbols that they use. Like lists have the square brackets, tuples have the parentheses, dictionaries have the curly braces, and also, guess what? Sets have the curly braces as well. So sets and dictionaries, they share the curly braces as you see here. And there's a way to differentiate between them, of course, because the way to differentiate is that dictionaries have key value pairs separated by a colon. Sets are single values separated by commas. So the Python interpreter can tell what kind of data it is, set or dictionary, by the nature of the element. If the element is a pair separated by a colon, it's going to recognize it as a dictionary. If they are single values, it is going to recognize them, or it, as a set. So let's look at set creation, folks. Set creation. In the beginning, there was sets. So here you have 3 strings in a set. Next line, you have an empty set. In the third line, you have an incorrect initialization of a set. See, the curly braces, the empty curly braces are, that syntax is reserved for dictionaries. So this is kind of what you run into when you have data structures sharing enclosing symbols. You have rules like this where the empty curly braces means dictionary, so a set can't use that. Instead, sets have to use the set function to create an empty set. So that is the rule with that. Let's move on to an important characteristic of sets. Because sets do not allow for duplication, they can be used to remove duplication from other data types or data structure types like lists. You can use a set to remove duplication from data. A list containing duplicates can be converted to a set, and then the duplicate values will be removed in the process. So take a look at here, where we have a list that contains duplicated data. Notice that there's duplicated 1s and there's duplicated 3s. What if I want to get rid of the duplication without doing some complicated, convoluted process? Sets are going to come to the rescue. Look at the next line. I convert my list to a set using the set function, and then I put it into this variable s, and look at what s is going to contain. S is going to contain a set consisting of all the unique values from the original list. So what I could do from here is convert it back into a list, and then I have an unduplicated list. And I will demonstrate this one. This is important enough. This is a very prominent use of sets, where you use them to deduplicate lists. get rid of that for now, or actually forever. Okay, so we have the list with duplication, and then we've turned it into a set. Let me go ahead and print what's here. You see that? So the data is deduplicated, but notice it is a set right now, shown by the enclosing symbols. It's a set. I want to turn it back into a list. So there's another function appropriately called list that I can use to convert it back to a list. I'll use my same variable name, and I'll convert S to a list. And now duplist will contain the deduplication, but now as a list. So here it is, folks. You start with duplication, you convert to a set, then you convert back to a list, and then the duplication is removed, and we have our deduplicated list. That's what I wanted to impress upon you. Hopefully you are impressed upon. And just to wrap it, I'll get the type of the data. Of course, it is a list because it's enclosed in square brackets, but it is a list. So I've taken a list that contains duplication, converted it to a set, and then back to a list. Magic. Voila. However you say it. The duplication is gone. Gone, folks. I don't say it to impress you, I say it to impress upon you that it is gone. Wanted to use that line. Okay. Set functions. So here's a couple of functions that you can use with sets. Important ones called add and remove. These two functions will add or remove from an existing set based on value. Sets are unordered, so the addition or removal cannot be based on an index, because there's no indexes in sets, folks. So what we got here, we got a set of strings. You add a string, you remove a string, and you see the result. I'm going to pop this in just for the, well, just for the heck of it. I'll keep it clean for now. So looking at this, you have a set, you add a D, and then you remove a B. See what we get afterwards. Just printing S. A, D, C, because D was added, so it's there. B was removed, so it ain't there. Magic. All right, here's an important section. They're all important, right? That's why I'm going over them, but this is something that makes sets pretty useful. The set data type contains a set of functions that utilize mathematical set operations useful for combining and filtering data. If you have any familiarity with basic algebra, there are operations called union, intersection, difference, and symmetric difference that you can do on numbers, on sets of numbers. Well, in Python, you can do these operations on sets of data, and it's a pretty valuable data organization tool, these are, to do operations on different kinds of data. And perhaps you'll see the value as I get into these functions. Those set operations that can be done are the union, the intersection, the difference, and the symmetric difference. And I'll cover each, of course, one by one. Looking at union. These aren't the good guys in the Civil War. The union, it's a union of two or more sets. That's what it is. So I want to frame it before we begin. These operations are done on two or more sets where they are kind of like combining and filtering operations. It's a way they kind of generally say it, but it's kind of doesn't get to the heart of what's going on. Getting into the heart of what's going on is about to happen now. With union, the union of two sets is the set of every element in both sets. And if this was more than two sets, it would be every element in all of the sets. I want to let you know that I'm doing examples on two sets at a time, but any of these operations can be done on multiple sets, like across more than two sets. Two sets will be the examples, though. So the union is is every element in both sets, and it can be done with the union function or the vertical line operator. Another thing about these set operations is that they can be done with, each of them can be done with a function or an operator. It's a very flexible kind of thing. Kind of cool. Always more than one way to do things in programming. All right, so we have two sets here. And then here we get the union set A, union set B. As the definition states, it gets everything in both sets, and that's what you get here, everything in both sets. See how it's happening? If you're saying so, I can't hear you, but hopefully you get it. If you don't get it, stare at it, watch it again. Okay. Next one is intersection. Intersection, these are the elements that are common to both sets, performed with the intersection function or the ampersand operator. I believe that's how you say it, ampersand. Correct me if I'm wrong, but I, of course, can't hear you. Here we have two sets, set A and set B. And here we get the intersection of set A and set B, where the elements common to both. So let's eyeball it and look at the elements common to both. Let's see, we have A's, we have C, and that's it. So the set would be A and C. So you see how this is working? This is like kind of a regrouping of data or filtering or whatever word you want to put in there that makes sense. It is, right? But pretty cool stuff. A way to reorganize data according to according to the criteria that you want. Yeah. Difference. Difference is the set of all elements in the first set that are not present in the second set. To perform it, you use the difference function or you use the minus operator. Emphasis on this, minus operator. Difference is minus, just like in mathematics. Subtraction, I know you were told that subtraction is the difference between quantities. Well, you use the minus to do the set operation as well. Okay, two sets. And then we do A minus B. It's the elements in the first set that are not present in the second set. So it's like it's a one-way deal where it is things present in A that are not present in B. So you have A, B, C, C, D, A. What's present in A that is not in B? It happens to be B. So there's your outcome there. And for these next two, I'm going to run them in our buddy Python. Charming, charming, charming. Okay. But the outcome is going to be what you would expect, so got that. See, the things that are in set A that are not in set B, and that would be the B. Looking at the next one, it's a different kind of difference, which is an interesting way to say it. We have the symmetric difference. The symmetric difference, it's the set of elements that are unique in either set, performed with the symmetric difference function or the caret operator. Interesting one. It may be on the number 6, depending on the keyboard you got. Symmetric difference, it's a different kind of difference where these are the elements that are unique in any of the sets. So comparing these two again, we know that B is unique from A to B, but in this other set, D is not in A, so it's really a difference that goes both ways. The regular difference is a one-way. It's things that are in set A that are not in set B. Symmetric difference says these are the things in set A that are not in set B, and the things that are in set B that are not in set A. So it's a difference that goes both ways, symmetric. It's symmetric. Boogie, wiggy, wiggy. Please don't close the video because I did that. But anyway. Well, the video is about to be over anyway, so you'll be able to close it soon, or I'll close it myself. This is the last piece. So looking at symmetric, no, this is not symmetric. Oh, wait a minute. This is a typo, folks. I'll correct that right now, because this is an editable copy. Using the wrong symbol. So the caret right here. All right, so what we have here is symmetric difference in PyCharm. Check it out. And we have down here D and B, because B is unique from A, and then D is unique from B. There it is, folks, symmetric difference. And yeah, you can do some really basic data science stuff with these set functions. Cool stuff. Okay, folks, now you can stop the video because I'm out of material. This was Tuples and Sets, and I'll see you, and you'll see and hear me in the next module. See ya. Okay, welcome back, folks, and now we're going to look at the topic of functions. This is the module right now, and I'm going back to slides, switching it up a little bit, give you a little slideshow. We're going to go back to a document once the slides are done and look at some code examples, but this part will be in slide form. So without anything else, we're looking at functions. Defining functions. So what is a function? Functions are reusable tasks created in separated sections of code in Python. Think of a function like a math formula, where you have, like a simple geometry thing where it's area equals length times width, the area of a rectangle. Like the length times width would be a function where you would plug in a value, or actually no, you would supply values for the length and the width. You do the multiplication, and your output would be the area. See, that output would be the output of a function. So very simply, functions they're kind of like tools in code where you can package up a little set of code like a formula, and then you can plug data into it. It'll do its processing, and then it'll output something to you, kind of like a formula. And you've been using a few functions already, like the print and the input function that do certain things. So you have some familiarity there, even though maybe you don't know it. Now you do. A function, they accomplish a specific task or a specific set of tasks. So sometimes functions will do just one thing, or they'll do a few related things. And a lot of times you input data into a function, it does something, and then it outputs the modified data. That is a very common basic use of a function. Functions improve code readability by replacing repeated sections of code with a single function call. You may find as you code, you may end up doing a certain routine over and over again, and especially if you're like you're processing data, you may be doing the same operation over and over again. Well, a function allows you to, instead of writing several lines of code over and over again to accomplish a certain thing, you write the code once and you section it off, and every time you need those few lines of code, you just point to them, and those few lines of code will run. That's the essence of a function. You create the few lines of code that you need to do to accomplish the task. You section it off, and then instead of writing that code every single time you need the code, you're going to just point to it, or as they say, the term is call. You're going to call it, and the function's going to run, and then it's going to output what you need. So it is like definitely great for code efficiency. You have already been using functions without knowing it, and you've heard me use the term function, and maybe you didn't really know what it meant when I said function, but here's an example of a few functions that are defined in Python that you've already been using. First and foremost, print. Print, it is a function that's going to display text on the screen, display output. And see, really functions are they're utilities created by individuals so that you're going to create a routine consisting of commonly used tasks where you write it once and then you don't need to write it over and over again. So somebody wrote print, and now you never have to write the code to do print again. You just call the print function and it's going to do what it does. So it's like you don't have to reinvent the wheel. Somebody they invented the wheel, and you just keep using it. That's the idea of functions. So print will display text on the screen. You have type. I don't think I've covered this. I'm not sure if I've covered this in this course yet, but I cover it in a lot of my courses, kind of on the fly. But type is a function that you can use to determine the data type of data. You put a variable inside the parentheses, and it'll tell you what kind of data it is, like string, integer, whatever, float. I know we've used the input function, creating a prompt, a text prompt, and then you input text into it, and then it goes dynamically into your code. So that's a function as well. And we've used the int function to convert data to integer form. Yeah, you've already been using functions. So, see, a part of this module is I'm going to empower you with the knowledge to create your own functions. So you'll see how that goes very soon. These functions, they're called built-in functions because they are built in to Python already. They come with the language. You have the ability to write your own functions, and when you create your own functions, they are called user-defined functions. Yes, user-defined, you being the user. Even though you're a programmer, you're a user also of the language. Now we're going to take a look at creating your own functions, and right away here is what creating your own function looks like syntactically. And what this is a function definition. This defines a function. It does not actually run a function. See, when you create a function, you set it up in code, and you say what the function is going to do, but simply typing out the code for the function does not make it run when you run your code. To be able to run a function, you have to do an operation called calling the function. The function has to be called. The definition alone will not run the function. It will only define it. So this is a function definition. We'll get into how to call a function later on, but this is only defines it. So think of a function definition as like a plan or a blueprint where you lay out what the function is going to do, but there's going to be other code that you're going to use to actually execute or run the function. And we'll get into that a few slides later. But yeah, looking at this one, this is a function that is going to take two numbers as input, add them together, and produce the result of that sum of numbers. And I'm going to go over the sections of a function definition right here. The first part, function definitions always start with a keyword called def. And this is not about Def Jam or rap music. This is def stands for define function. And all function definitions begin with this. Next, you have the name of the function. The name of the function will be a descriptive name that you're going to use to identify the function. You need to use a descriptive name because it increases code readability, and also you're going to use the function name when you execute the function. So the function name here is addNum. When I'm ready to actually use the addNum function, I will call it by name in my code. I'll say like, well, I won't give you the exact syntax, but the gist of it will be like use addNum, and then addNum will spring into action and it'll work. So that's the function name. Next here is we have the parameters, and this is actually a typo right here. These are not arguments. These are parameters. So inside the parentheses, what you got is you have two variables separated by a comma, and what the parameters represent is they represent the data that you will input into the function so that it can do its thing. And the number of parameters is optional. You will define however many parameters you need for your function to do what it does. I define 2 parameters here because I'm going to take in 2 numbers to be added together. That's why I do that. But you don't even have to have parameters at all. There are some functions that don't take in any parameters, and they just do what they do. They don't need parameters. The number of parameters is up to the programmer, and they will appear in parentheses. They will be the data that the function takes in to do what it needs to do. And as far as the naming, I name them op1 and op2. These are, you can liken them to variable names, and really they are variable names. These names will be used in the body of my function to refer to the data that's being taken in. So when data is passed into the function, it's going to go into op1 and op2, basically these 2 variables, and then those 2 variables will be manipulated later on. And I want to highlight the fact that this line here, this whole line here, this first line is called a header of the function. kind of like you have headers for the if, elif, and else. Well, actually, there's no really header for the else, but sort of. You have headers for those. You have headers for the loops. This is a function header, and at the end of the function header, you have a set of you have a colon, not a set of colons. What the hell am I talking about? You have a colon, and the colon serves the same function as it does in the if, the for loop, the while loop. It kind of says the body is about to begin. So you see some commonality between this header and some of your other structures like the loops and the conditional statements. So this is a kind of like a Python feature that all headers will have. And the header consists of the def keyword, the function name, and the parameters. That's the header of the function. I wanted to clarify that because that's not in the slide. Next part is the function body. And as you know from other kind of control blocks like the loops and the conditional statements, the body is indented below the header. The body is indented. And what's in the function body is these are the tasks that the function is going to perform. And what happens here is that create a variable value and it equals op1 plus op2. So these two are being added together, these two pieces of data that are being taken in. And then I have what's called a return statement. And what return does is that it is going to take your result and give it back to the portion of code that executes the function. So it's like the output of a function. A return is like saying output. This is going to output this value. Like the function takes in two values and outputs one, which will be the sum. So return is like saying we're going to output this from this little formula. That's what it is. And we have the return statement, like I just said. It's the thing that specifies the output. The return statement is it's optional because not all functions will return something. Not all functions output something when they are done. Sometimes a function will just change a piece of data, but it won't need to be output because the data will be available throughout your program. So it's optional, but here we are using it because we're getting a sum and then we are outputting the sum. And there's a basic function definition. Some things to note. There's always something else, folks. This stuff is multifaceted and super deep. What you just saw was a function definition. Functions don't run until they are called. I specified this earlier. So what you saw was a plan, like this is what the function is going to do. But if I put that into a code file and ran it, it wouldn't do anything. Functions do not run until they are called. Calling a function means running it. A function is called by typing its name, the function name, next to a set of parentheses. Sometimes you put data in the parentheses, sometimes you do not. This depends on how you define the function. If your function has parameters, you will put something in the parentheses. If your function has no parameters, you will not. So let's going back here, looking at the parameters. See, the parameters define if you're going to put something in the parentheses when you call it. If there is something like there is here, you're going to supply the appropriate amount of data, meaning the number of parameters will be supplied. If there's nothing, you put nothing. But I'm a little kind of jumping ahead because you need to see what a function call looks like. And you'll do that right now. These two are examples of using your function, meaning calling it. For now, I'm going to use the term call, not jump around. You use the name of the function, parentheses, and then data inside the parentheses to specify specify the data that you're passing to the function. Here I'm passing 3 and 7, which really means the 3 and the 7 are going to get added together, because as you saw in that function, that's what it does. You can also supply variables that will contain the appropriate data. So you can supply exact data, like literal data, or you can supply variables that will contain the data. See here, x and y likely will contain numbers that can be added together. There's your function name. These are the arguments. So when you pass data in the parentheses, these are called arguments. And they can be either values or variables, like I said. And that is using your function, using your noodle, yes. And now we're going to take a look at how this function actually works in real code in PyCharm. Let me move some things around here. Now actually, I'm going to grab this one, put it into PyCharm. There is our function. And notice I'm going to just run this code as is. You see nothing happens, because if you run a function definition, it doesn't do anything. It must be called. And so here, I'm going to call my function. I'm going to call it inside of a print statement because it's going to produce a number, and I want to print that number. So I'm going to call it inside of a print statement. I'm going to supply it with just arbitrary numbers. And you see num1 and num2 here. This is PyCharm providing hints as to what I'm supposed to put here. And the hints come from the function definition. So PyCharm reads the definition and tells me as the programmer, it's like, you need to put num1 here and num2 here. So these two are not part of the code. These are hints supplied by PyCharm. The code that I've supplied is simply 4, 6. So I wanted you to understand that. And let's run it and see what we get. Aha, we get a 10. And here I want to show you kind of the reusability of the code, where I can call the function several times using different inputs, and I'm just going to get my answer. So like, given several inputs, I just wrote the code once, but now here I'm running it 4 different times. This is the power of functions, where you write it once and then you can run it as many times as you need to with a variety of inputs. See, I'm inputting all different numbers here, getting all different additions. You see that? Therein lies the power of functions, where I can now, even though the function is only a couple of lines, you can kind of envision that you can create a function to do a lot of stuff, and then you can kind of sit back and call it and use your code resting on your laurels, over and over again with different inputs. So cool stuff. And down here, these are all the sums of all the numbers that I input. So yeah, take this one for a spin and try it yourself with some different numbers. You will be inspired and enthused, I'm sure of it. We're going to now look at a few examples of user-defined functions that I've defined to use as examples of how functions look and work. And first we have here a function to get the square of a number, where you will input one number and then it's going to return that number times itself. So let's take this one and throw it into PyCharm. See how this one runs. And we'll just run all of these. So I'm going to put this up there. I think the indent is a little too big. Yeah. Okay. Now, I think with all these I'm going to do print, because return is going to give me output. I want to print that output, so I'm going to put the function call inside of a print statement. Now I'll get the square of, let's say 50. Yeah, 2500. Good stuff. And let's get the square of 5. Cool. And that's how square works. Now let's look at this next one. It's a function called isEven. isEven. You clean up this. Yeah, what this function is going to do is the input is going to be a single integer, and it's going to return true if the integer is even. Otherwise, it's going to return false. So this is a cool thing for you to see. Here is how you can determine if a number is even or not, where you say if n being the variable that we're testing, if n modulo 2 equals 0, return true. So the test is if n modulo 2 equals 0. Remember, modulo is getting the remainder of a division. So if some number divided by 2 produces a 0 remainder, it is even. So all even numbers, when divided by 2, produce no remainder because they divide by 2 evenly. So when you divide by 2 evenly, it's an even number, thus we will return true. Otherwise, you return false. If they do not divide evenly, they are not an even number, so you return false. So I'll change this to be to use isEven, and I'll just use the number 5 once again. And 5, of course, is not even, so you get a false. Let's look at like 22. It is even. So there you go with that one. Determine if my number is even. Here's another one for y'all. Here you got a function called addAll. So what this function is going to do is it's going to take in a list, and it is going to add all of the elements of a list together. Like this. Let's say you have a list here. We'll just make it simple and make it a list of sequential numbers. How this one works, this may be a difficult concept at this stage for y'all, but how this one works is that some list is going to be a list. I'm going to create a total equaling 0. This is going to hold my sum of the numbers. And then for I in range, the length of some list, this is going to loop as long as some list is. So if some list is, let's say it's 8 numbers, this would loop 8 times. That's what that means, getting the length of some list. Talked about length in an earlier module. Then this is the key line right here, where you have total plus equals some list I. What this is going to do is, this is going to add Pretty painstaking, ain't it? Yeah. This is going to add each element of the list to total. And it's going to do it in a cumulative way where it's going to loop, and I is going to be the value of each index, and it's going to go to each number. So like on the first turn, it's going to be 1, so it'll be total plus 1, and then store it. And then on the next turn, you're going to get a 2, then it'll be the previous total plus 2, so it'll be 1 plus 2, and it'll be 3. And then we get 3 on the next turn, then it'll be 3 that's already in total plus 3 more, so it'll be 6. And then you loop around again, you have 4, and then it'll be 6 plus 4. It'll accumulate and add each element. It's going to add each element together as it loops. And so it'll produce a sum of everything in the list. Let's try it out. And how this works is that I need to create a list, and then I need to call my function, which is named addAll. I need to supply the list in the parentheses, because the list is going to be the data that I'm going to give it. You see, what happens is that a list that's defined here, a list is going to turn into some list, and then inside here, some list is going to get its pieces added together. There's like a transformation that happens where when you supply data as an input, it's gonna go into the placeholder or the variable that's here, and then it's gonna be manipulated, and then the total is gonna be output. So yeah, interesting how that works. But let's just see how it runs here. It's an indentation issue. I figure that might be the case there. When I bring stuff over from a document, it doesn't always format right. All right, let's run it. All right, so all these numbers added together equals 36. Okay, folks, we went over functions, and I'm sure you'll be doing exercises on functions soon. So that is the function module. You will hear me and see my code in the next module. Until then, I am out. Hello, and now we're going to look at built-in functions. These are tools provided within Python to help you along your coding journey, basically. They're just ready-made tools that you don't have to create yourself. Python offers several built-in functions to facilitate and enhance the efficiency of common tasks. In this section, we're going to go over several prominent ones and see their usage. So these are going to be the most useful built-in functions for you. Looking at the first one, len. You've probably seen this one before. Len is short for length. It's going to return the number of items in a collection or sequence. Or you can really just think of it as it's going to return the number of items in a data structure, like a list or a string. A string isn't really a data structure, but it'll still do it. And you see it here actually with this first one. Name equals Bart Simpson. This is a string, of course, given by the quotes. If I get the len of that string, and the form of len is you place the variable or the data inside the parentheses, and len is on the outside, of course. If you get the length of name, it's going to print 12 because there are 12 characters. Because the length of a string is going to be the number of characters, and the space counts as a character. Look into the next one. You have a list here of numbers, and you get the length of that list. It's going to be 5 because there's 5 elements in the list. Straightforward, right? Yeah, len is going to be used pretty heavily. Used a lot with loops. Here is another one used heavily with loops called range. And you've seen range and used in the for loop, but range can be used outside of the for loop. It is a built-in function that can exist outside of the for loop context. Range is going to return a range object, which consists of a sequence of numbers, and it has 3 different forms. And I'm going to go over the forms pretty soon, but range, essentially, it produces a sequence of numbers. That's what it does, and it produces a sequence of numbers according to the options that you specify. So you as a programmer can tweak, or you can decide what kind of sequence it is going to generate. It'll generate that sequence, and there you go. So there's 3 different ways to generate your sequence. Number 1 is that you specify the upper limit only of the sequence, called the stop, and the sequence will end at 1 less than the specified stop. And here is that format right here. Range, and then you have a number inside the parentheses. This number will be the upper limit of the sequence, but it really is going to end at 1 less than the specified ending, because in a range the sequence or the ending is not inclusive. So it's not inclusive of the end, so it's actually going to end at 1 less. In this case, it's going to end at 9. And when you specify the upper limit only, the sequence will always start at 0. And also in this single number argument function, it's going to start at 0, and it's going to just be consecutive numbers from 0 ending at 9, because it is 1 less than 10. So this is really going to go 1 through 9. That's the sequence that it's going to generate, and it's going to generate each and every number in that sequence. This is an important enough concept, and it's confusing enough that I am going to demonstrate with a split screen here. Firing up PyCharm here. So range produces a range object, and I'm just going to show you what happens if you print the outcome of range. Let's do range 10, and this is going to produce a sequence from 0 to 9. Let's see what happens when I try to print it. You don't actually get the sequence, you get kind of like a description of it, the 0 to 10. That's not that useful. You actually want the set of numbers. To really turn range into a sequence, a set of numbers that you can use, you will do a conversion to a list, and that's going to give you an actual sequence and a structure that you can use. If I convert it to a list using the list function, and you'll learn about the list function a little bit later, it's a conversion function. But you see this, it gives me an actual sequence from 0 to 9. And really, for the most part, when you use range outside of a for loop, you're going to be using list to convert it, because range isn't as useful as a range object. It is somewhat, but trust me, you'll be converting it more than not. But that's the first form of range. It goes 0 to 9 if you specify 10, and I'll illustrate further that the ending is not inclusive. If I put a 15 in here, it's going to go 0 to 14. You see it right there. And there you go. Let's check out this other form of range. The second one is you specify the beginning and end of a sequence called the start and the stop. If you just specify one, it's called the stop, like the ending. If you specify the beginning and end of the sequence, it's called a start and a stop. And these are kind of vocabulary words with range, because you'll see the options of range specified in these terms over and over again, start and stop. So get used to them. And in this form of range, the 5 would be the start, the 20 would be the stop. And to reiterate, the ending is not inclusive, so the stop is not inclusive. So this is really going to generate 5 to 19. And so given that, let's take a look over here and do it. Ain't nothing to it but to do it, my friends. 5 to 20. It's going to give you that 5 to 19 you see over there. Yeah. So that's the second format of range. The third format of range is where you can, whoops. I gotta say whoops a lot in these videos. I'm finding signatures within myself. You specify the start, stop, and step of a sequence. So with this, you specify 3 things. And what is the step? The step is the number of items to skip in the sequence. So far, these have all been sequential. With these first 2 options, it's all one after the other, like 1, 2, 3, 4, 5, every single number in the sequence, skipping nothing. The step allows you to skip. And you can think of step as a skip. And so step is going to be a number, and it's going to be the number of numbers to skip in the sequence. In reality, it's the number of numbers to skip minus 1. There's a lack of the exclusivity coming in again, where here's the format. It's start, stop, and step, 5 being the step, but it really means that this 5 step really means to skip 4, because how it's going to work is you're going to start at 5, stop at 50, and skip 4 in between. So the result is going to be like for the first couple of terms, or the first 2 terms, it's 5 skipping 6, 7, 8, 9, and then 10 would be the next one. Notice we skip 4, and then 11, 12, 13, 14, skip all those, then you go to 15. These would be the numbers in the sequence, 5, 10, 15. Specifying a step of 5 means that you're skipping 4. And there's other ways to look at this and verbalize it, but this is the way that I kind of internalize it. When you have a number in your step, you're really skipping 1 less, as you see here. And I'm going to put these numbers in so you can see the actual sequence generated. 5 to 50, and then skipping the step of 5. Start, stop, and step. And there we go, folks. You see 5, 10, 15, 20. So it's just that it's going by 5s, skipping 4 in between each number. That is your third and final option for the range. And now there is more to the range. You knew there was more. You see, range, as you've already seen, range is typically used in a for loop. The options that I just went over can be used to add more capabilities to a for loop. And if you look here, the options of range are on display, where I create a string of the alphabets, where it's just sequential alphabet all the way across. I think all the letters are in there, hopefully. And then I loop for I in range, and you see range here, and you see a format of range that you haven't seen yet, where I'm using the third format of range, which is start, stop, and step. And because they all end or begin with S's, I can't just put 3 S's here to kind of tell you what they are, but the 0 is the start, the length of S is the stop, and the 2 is the step. Start, stop, and step. And so what the start is the beginning. The stop, of course, is the end, but really the end minus 1, or 1 will be minused from it in actuality. And then the step is the number to skip, minus 1, sort of. So looking at the step, I'm going to be skipping 1 because there's a 2 specified there. 0 is the start, which means I'm starting at 0. What I'm really doing here is I'm going through the string, but I'm looping using a skip or a step, where what's really going to happen is I'm going to loop through, and I'm only going to access every other or every second letter. So the effect would be going like A to C to E to G to I, and so on. And that's what this start, stop, and step is going to do. I start at the beginning of the string. I go for the entire length of the string. That's what the end, the stop. And then I skip 1 in between. And this, going back to the string, I'm skipping B, I'm skipping D, I'm skipping F. See, that's how it's going. And I is going to be holding each number in the sequence, and then I'm going to use that number to index into X. And this is something I didn't specify much earlier on, that range, when range generates the sequence, as it loops, it's going to feed numbers into I. So as it loops, like for each number it generates, one number goes into I, you have an iteration. Then the next number goes into I, you have an iteration. Next number goes into I, have an iteration. So how this works is going to be, when you begin, 0 is going to go into I. Then you're going to skip, and then you're going to skip 1, and then 2 is going to go into I. Then you're going to skip 3, and then 4 is going to go into I. So that's going to be the effect on I as we loop. And we can kind of illustrate this as I demonstrate. Illustrate as I demonstrate, right? But I said a mouthful, so if you don't, something you didn't get, you can replay here. But I'm going to move forward with this as not to take too much time with the video. Even though it doesn't really matter. I mean, we need to explain as long as it takes for y'all to get it. But let's go ahead and run this one. And you see what it does. I get every one skipping 1. So A skipping B, C skipping D, E skipping F, G skipping H. So all the way down. And as I was saying, I is going to be getting each number in the sequence as it goes. And we can illustrate that here, I believe. See the values of I there? I'm using amazing printing formatting to do that. The value of I, you see the skipping. It's not sequential, it is like every other. And that is that's the power of the start, stop, and step of range, my friends. All right, moving forward. Let's look at the next built-in here. We have round. Round is going to do as it says. It's going to round a float, a decimal number, to the desired precision. Precision being the number of numbers after the decimal point. So you look at this one, 3.14159. This is pi, of course. And so the format of range is you put the number that you want to round first, a comma, and then the precision or the number of places to round it to. This is going to be the pi rounded to really one number after the decimal point. So when you print it, it's going to print 3.1 because using 4 to round the 1, it's going to stay at 1 because 4 is less than 5. And we know those classic rules of rounding. Yeah, that's what rounding is, or that's what the round function is. You know what rounding is. Don't be silly. Yes, yes, yes. Okay, next is type. With type, you've probably seen this one before. Type is going to give you the data type of the item specified in the parentheses. And here's how you use it. Type, parentheses, and then you put a data item inside the parentheses, and either a data item or variable. And in this case, it's going to print a class list. It gives you whatever the data type is. And it always prints class in front of it because everything in Python is based on a class. So that is why. And if you want to know what classes are, that'll be in another course that I have not created yet. There's an object-oriented concept, or object-orientated, as it were, if you want to have a certain vernacular. Too many blank lines. I'll just show you this real quick with type. Say you put in, whatever data. If you just put in a raw data item, you see it gives me int for that. Do this one, float. So there you go. Of course, this will give you a list, but that's all to say about that. Sum, as the name suggests, it is going to return the sum of a number collection. What's a collection? Like a list. So here we have a list, and then we call sum, put the list inside of it, and then the sum is going to go into this variable called total. And total is going to print 21 because 21 is the sum of 1 through 6. Try that one out on your own, folks. Next we have pow. This is kind of a classic function where this is exponentiation. It is going to raise a number to a given exponent. So the format here is it's 2 arguments. It's the first one is the base, because you call lowercase b. Second one is the exponent, be. So it's like 2 to the 4th. And you probably know 2 to the 4th equals 16. There we go. So it's base, comma, exponent with power, or POW. POW. Sorted. This is an interesting one. Sorted returns a sorted list. It can sort multiple data types. And so, yeah, sorted does sorting. And you already have seen a sorting function with lists. There is the list sort function. What's the difference between the list sort and sorted? Because first of all, sorted can sort other data types other than lists, and sort only sorts lists. That is one difference. The second difference is that sorted will return a list. Sort returns nothing. So those are your two important distinctions. And so you can use sorted in a case where you need to produce a list from the sorting, and maybe you don't want to modify your original list, which sort does. Sorted produces a different list, and it's a sorted list, and it produces a list. Sort doesn't produce anything. So let's look at this one. In its most simplest sense, you have here a list, and then you have sorted, and we print the list. And you see, of course, the list is sorted in ascending order. Very good, very good. Let's do the same thing with sort to kind of demonstrate the difference here. So, like, you have a list, and let's just call sorted on this list. Or sorry, sort on this list. Remember the list sort? This is going to show you the difference. Notice I get none for the return because sort doesn't return anything, but sorted will actually give you, it'll produce a list. A very important difference there. So if you're going to print out the output of sort, you would have to sort on a separate line and then print the list afterwards. So sorted, to sort of recap, sorted will produce a list, it'll return a list, and you can sort different data types with sorted. The sort function is only for lists, and it will not return anything. Those are the differences. I don't have fancy graphics for that, but you can listen and take notes, right? That's what you're supposed to do in class. ABS returns the absolute value of a number. This is pretty pedestrian, where you supply a number, positive or negative, and it gives you the absolute positive value. Next, moving on, is instance. This is a data type determining type of thing. Determines if data is of a specified data type, and it returns true or false. So really, this one could be used in an if or elif type of scenario, because anything that returns true or false is somewhat ideal for a decision statement. So we have type that I covered earlier that's going to give you the data type. It tells you what it is. Is instance is a little bit different. It's kind of in the same category of data type determination, but it kind of answers a different question. You see, type just gives you what type of data it is. Is instance, you ask, is it this kind of data type? Like, is it an integer? Is it a float? So it's approaching it from a different angle, and sometimes you need to solve a problem where approaching it like this makes more sense than just getting the data type. Like, is it this? Instead of what is it? So that's kind of the difference. Type says, what is it? Is instance answers, it answers, is it this? Yeah, I almost lost it for a second. And it returns true or false. All right, so we have a number here, x, and then here's how you call it. It is, you specify the value first, and then a comma, and then the data type that you're asking, is it this? So is x an instance of integer? And you can do this for pretty much any data type. And you just have to know the abbreviations, because some of them are abbreviated, some of them aren't. And I'll leave that as an exercise for you to figure out what they are. But int is abbreviated, float is not, list is not. So it depends on the length of the word, basically. Like dictionary is abbreviated, I don't remember if tuple is abbreviated because I don't really check for tuples. Anyway, you can look that up on your own. So let's check this one out. Let us check it out. Missing a parentheses. So you have this 3.15 blah blah blah, and this is asking, is it an integer? It is not an integer because it's a float. Okay, so there we go with that. False. So yeah, this would be ideal for if or an elif, like checking the data type. Really for like input validation. If you have like a form or something and you want input of a certain type, like you grab the input, say, is this a string? Is this an integer? If not, you kick it back, blah, blah, blah. There we go. Hopefully I'm not explaining that too quickly, given your, I don't know what your experience level is, but there is a use case. It's going to be in your conditional statements a lot of times. It'll be an if in front of it. Anyway, let's go on to the last official function. We're going to cover some type conversion functions, but this is the last of the kind of non-conversion built-in functions that we are going to look at. It is called zip. It's a very interesting one. What zip is going to do is it's going to combine multiple iterables into a tuple and process the elements concurrently. This is kind of a code condensing operation where you can take multiple iterables. Think of iterables as something like a list or a string, like a data structure that is an ordered collection. You're going to take that and you're going to take multiple ones and be able to process them together in one loop very easily. And it really increases the power where, like, if you need to take 3 or 4 lists and you want to group the corresponding elements together, like if you want to loop through these lists and each element 0 you want to take and do something, each element 1 across all the lists you want to take them and do something, this is ideal for that, where it's going to allow you to process the corresponding elements, meaning like the same elements across the lists or the data structures. Like, look at names and ages. Let's say there's a relationship between these two lists where you have a person's name and then you have their age in corresponding indexes. Like Mike's age is 23, Spike's age is 37, Jeff's age is 55, Jordan's is 32. So the indexes correspond. And in this kind of scenario, you can use zip to process them together. Like if I want to do something where I want to group Mike in 23 and Spike in 37 and Jeff in 55, I can do that. And this is actually what I'm going to do here, because I'm going to use the power of zip to create a dictionary from 2 lists. So this is kind of cool. So I'm just going to grab this and throw it into PyCharm. So be it. Perhaps easier to explain, because I'm going to explain it, then I'm going to run it, blah, 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 blah. So we got our 2 lists, okay. And we create an empty dictionary. You remember how to do that? Create an empty dictionary, because I'm going to be putting the stuff into the dictionary in the loop. Line 8 is how you use zip. So we have for NA in zip. So this is a different kind of for loop that you haven't seen. And there's some other ones you haven't seen that will be revealed to you later on, but this is another kind of for loop. Here's the zip function, and the arguments to the zip function are going to be the data structures that you're going to process together. Here we're going to process names and ages together, of course. And so what are N and A? N and A think back to the concept of the for each loop, where you have that for item in list. Item would be the variable. N and A are variables, temporary variables, set up to, what they're going to be is they're going to hold the current element of each list here. N will hold an element of names. A will hold an element of ages. And each N and A will hold one element for each turn of the loop. For instance, on the first turn of the loop, N is going to hold Mike. And on the first turn of the loop, A is going to hold 23. It's going to allow those two to be processed together on that first iteration, the first turn. And then on the next turn, what's going to happen is that N is going to hold Spike, and then A is going to hold 37. And it's going to allow those two to be processed together, like one by one by one. And let me illustrate that one real quick here. This is a good concept to show y'all. So I'll just do N comma A. And you'll see that for each turn, you get the corresponding elements, right? Mike 23, Spike 37, Spike 37. So there you go. So I'm going to use this functionality to create key value pairs. So I'm going to go back to the way the code was before, and see line 9 is I am creating new dictionary entries. How it works is you have the name of the dictionary, you index in using the new key. The name is going to be the key. Name is the key, the age in A is going to be the value. That's how it's going to work. So then, let us run. Not quite yet because I'm going to print. Not quite yet. All right, there we go, buddies. And we see a dictionary that is populated thusly, if that's a word. Mike 23, Spike 37. There is the power of zip. Way more you can do with this, but that just scratches the surface. So moving into the last bit here, what we got is a conversion function, type conversion functions. So very simply, what these are going to do is convert the item inside the parentheses to the data type, which is the name of the function. So what that means is that you're going to put, so like whatever you put in here, it's going to be converted to the data type, which is the name. So if you put X in there, it's going to be converted to an integer. And all of these and so on. So yeah, you can do conversions, but they have to make sense. Like, yeah, you can convert the string 32, you can convert that to an integer, absolutely. But some conversions don't make sense. So that'll work. The overall thing is that as long as the conversions make sense and they're legal, they'll work. And if they don't work, it'll give you an error and show you that it doesn't, or they don't work. So I'll show you one of these. And you've already seen int being used before when we use the input function. Absolutely. Let's create an integer and simply convert it to a float. And yeah, you can reuse the variable, of course. And when you convert it to a float, you see 333 has got a that at the end. And if I get the type of it, it is going to be float. And yeah, these all work as long as the conversion makes sense. Like if it's impractical, you're going to get an error message, and you can be on your merry way and fix your error message. That is the end of this module, and that's all I got to say for you. You'll hear from me again at some point, but that is it. Welcome back, folks, and now let us discuss the topic of algorithms. A word that you hear, non-programmers hear this word nowadays all the time, talking about social media and stuff like that. The term algorithm is kind of like a buzzword these days, but I want to nail down here the real definition of an algorithm and how they apply in coding, because this is kind of the realm that algorithms came from. Really, algorithms came from mathematics, and computer science is really the science of algorithms, but don't need to get too deep into that because I simply don't know a hell of a lot in that arena, even though I am somewhat of a computer science. Anyway, before we go down a ridiculous rambling rabbit hole, what are algorithms? An algorithm is a systematic, step-by-step solution to a problem that can be repeated. Yeah, and it's that's what it is. Computer science heavily involves the study and development of algorithms. That's a major part of what computer science is. Algorithms don't necessarily involve program code. Real-life situations can be broken down into algorithms, like tying a necktie or following a food recipe. That is an important point. Algorithms are not necessarily a code thing, and really any repeatable step-by-step thing can be termed an algorithm. And it's really an algorithm is really a repeatable set of steps that you use to achieve an outcome. See, given this set of steps, the outcome is going to be achieved every time. And that's really the essence of what an algorithm is. And what we're going to do in this unit is do some common coding algorithms that have already been established, way back when, people have been using for a while. We're going to use these algorithms. First, we're going to examine those algorithms, and then we're going to use them to solve some coding problems. So like you see a problem-solving process, and then you solve a problem using that problem-solving process. And I don't know if I said the sentence yet, so I'll say it if I said it again. I kind of lost myself there. The goal of this unit is to introduce you to a few common beginner algorithms and use these algorithms to solve some small problems. Really just detailing what I just said. Let's look at some common beginner algorithms. In this unit, we're going to examine several introductory algorithms and algorithms that are used to solve classic computing problems. We're going to examine and break down the code and then look at an example of the algorithm being used to solve the problem. So we're doing direct applicability here. We're going to look at the algorithm code and then break it down, and then we're going to actually use it to solve a specific problem in code. And these algorithms are going to be packaged in the form of functions. You learned about functions pretty recently. They're going to be functions where a function is a routine that takes in an input, does some processing, and produces an output. Well, these algorithms are really going to do just that. They're going to take some input, do a step-by-step process, and then they're going to produce some outcome, and we're going to use them to solve some problems. Let's look at linear sequential search. Here's a classic problem here. Searching It is a common task in computing. You could have large sets of data, and you want to find data with a particular thing, maybe a particular value or particular signature if you have more complex data. But whatever it is, searching is it's easier done with a computer than a human in a set of data. So we use computers for this. Specifically, we use code for this. The simplest method to do a search is to do a linear search. With a linear search, a value is given to search for in a list, and then the list is checked sequentially from the beginning until the end for that value. If the item is found, it is reported where the item is found, typically with the index. If the item is not found, then some indication is given via a numeric code or message. So a linear search is the simplest kind of search algorithm you could do. It starts at the beginning of a set of data and searches one by one looking for the value that you're looking for. I'll draw out an example here and just throw out some kind of random numbers. And not too good drawing with the mouse. That is a comma. Okay, we got a list of data here. Let's say this data exists in a variable and we don't know what the list contains, but we want to do a process to search the list for a certain value. Let's say we want to search, I'll abbreviate search here. Let's say we want to search this for the value of 7. Search this list for it. Of course, we can eyeball it and see that a 7 is in here, but let's say we couldn't see the data. Maybe it's thousands of values in here, and we can't even see them. We can develop a systematic routine to search for the data, and the one we're going to look at here is linear search. Linear search is very simple. It begins at the beginning and searches every single value until the desired value is found. So looking at this list, what it would do is it's going to go one by one, and you can envision that it's very inefficient, because if you have a large list, it's just going to go one by one sequentially, and if the item you're looking for happens to be near the end of the list, you just killed a lot of time going from the beginning to the end. So here it is. We're going to go one by one, and really we're going to compare what we see in the current element to what we are looking for. That's how you do the search. So we'll look at the first element, 5, and we're looking for a 7. Is it 7? No. Cross it out. Go to the next one, 11. Is it 7? No. Is this 7? No. Is this 7? No. Is this 7? Yes or no, it is 7. It matches. And what we would do at this point, when we find our match, we're going to report where it is found. It's found, and where it's found is a certain index. 0, 1, 2, 3, 4. It's found at index 4. So we would we would report the 4. We would return a 4. That's what we would do. And that's how it works. You search sequentially, and then once you find it, you report where you found it. And if you went all the way through the list and you did not find it, you would give some indication of that. Sometimes it's a print message saying item not found. Classically, a return of -1 is returned. Like if it's not found, return a -1. So it really is up to the programmer how to report not finding the value, but indication that it's not found would be returned instead of the index. That is how linear search works. And now we can look at the code on how it works. Because here we have a function that implements linear search on a list. The parameters of the function are a list and an item to search for. So you have our header, and the two parameters are, this is going to be a list, and this is going to be the item to search for. So in is going to be the item to search for. All right, let's loop through this list. That's what's happening. For I in range, the length of the list, and then this is kind of the key here. If the current element of the list equals the item that we're searching for, then we're going to return the index. Remember my drawing up there when we had the 7 and we found the index of the 7, we returned it? That's what's happening here. We're going to compare the current element to the element that we're searching for, and if they are the same, we're going to return the index, because we know I is going to be the index. And yeah, linear search one by one until it's found. And so this return is, if we go all the way through the loop, really through the list, and we don't find what we're looking for, we are going to return this string that says, it's an F string, it says value of what we're searching for not found. So we didn't find our 7, we didn't find our whatever. That, folks, is the linear search algorithm in a function. And now we can use linear search to solve a problem. So here's a problem that we can solve with this. Given these lists that are below, find the needle in the haystack and report where it is found. We have a list of strings here, haystack 1, and then you look at the elements of this. You have hay, a bunch of hays, then you have a needle, then you have a bunch of hays. This is a needle in a hay list or a haystack, right? We can use linear search to find where this needle is in the haystack. And this is the code that will do so, where we do a print function. And inside the print function, we call linear search. And we call it with the haystack and the search term, what we are looking for is needle, and it's going to give us a 4. This is a good time to drop this stuff into PyCharm and to get that rolling. So I'm going to do that right now. Get my screen set up here. Yiggity, yep, let's go. And here's our linear search function. Why did I react like that? That's weird. There's our linear search function. And let's drop in our other code here. Oh yeah, this is going to be double code. This is going to be a mess, my friends. Yeah. How about I just do this? This is going to work out better, I think. Will it? Let's see. You're seeing behind the scenes live, folks. Yeah, that's not going to work out. But guess another time I'll be more prepared, but yeah, you got to do what you got to do. Got to get these videos recorded, homie. Get them out the dough. All right. We have our haystack right there. And now we're going to call the function. Needle, of course, this should be 4. And we get a 4. And just more proof of concept, let's take the needle and put it in another spot here. I'm going to cut it. Let's throw it at the end. Now we got our needle at the end. And I don't know how many items are in this list, so let's run it. 7. So now we get a 7. 0, 1, 2, 3, 4, 5, 6, 7. There we go. Okay, folks, there's our needle in the haystack, using linear search to find it. Dope stuff. Let's, well, the rest of these two are just where your needle is in other places. In this next one, notice the needle is not even in the list. And I notice there's a typo right here. Why do I have to point out my mistakes? I don't know. But there's no needle in here, so it's going to print value needle not found, because it's going to search this whole thing and not find the needle. And looking at this next example, the needle is here, which will be index 8. So I'm not going to run these because I'll need to do modification, and you guys don't want to see me do that. So I'll move on to the next explanation. It's about progress, folks. Now let's look at this algorithm to count the occurrences of a given value. You guys like my deadpan delivery? It's dope, right? Okay, I'm feeling more deadpan today. Count occurrences of a given value. You, of course, have seen the count function for lists and strings, but it is good to see how the code for this function would look. And here it is. And so this is a function that actually does a manual counting. This kind of shows you how the counting function would look internally. The count function. You know the count function that you use for lists and strings? And no, I can't hear your reply, so don't say anything actually. But that function internally could look like this. And like what we do here is, in this code, we take in a list and a value to count in that list, and we go through the list and count every single one. We create a variable called total count. We loop through the list, and we say if the list or if the current element matches the one that we're looking to count, we increase the count by 1. Plus equals 1 with that combination operator. And then we return the count. So this is how count would well, this may be how the count function would look internally. But yeah, this produces a count of items in a list. And that is how that works. So now let's take a look at it used to solve a problem. Moving down without further ado. Here's our first problem. Determine if there are any duplicate values in a list. Report true or false if duplication is found. And let me format this a little bit. Yeah, this looks better down here because this is all together. What I've done here is I've created another function that utilizes the count to find duplication in a list. So it's kind of like a piggyback effect, where I've created this function, and then I'm creating another function that will utilize the previous function, and it's checking for duplications. Because see, a way to check for duplication is to count the number of items that have a certain value. Like, to know if 5s are duplicated in a list, I can count the number of 5s, and if there's more than one 5, it is duplicated. That's the simple idea behind this idea. Idea behind the idea, right? Okay. We have our header here. It takes in a list, and then we will loop through the list, and here I'm calling the previous function that I wrote. It's saying if if the count of the current item is greater than 1, now let's break this down though. Let's isolate this part. What I'm doing here is I'm calling manual count using the list and the current item from the list. What I'm essentially doing is getting the count of the current element in the list. And this whole thing here inside my orange brackets, it is going to return the count of that item in the list. And when I get the count of that item, I'm going to compare it to 1. If it's greater than 1, then I return true because there is duplication. What this is really saying is that if the count of any value in the list is greater than 1, duplication exists in the list, and I'll return true. And at the bottom here, if I get all the way through the list and there is no duplication, I return false. And yes, folks, we are going to try this one out. Really both of these together because they rely on each other. So I'm going to first copy in my manual account. Then I will copy in my dupe exist. And then we're going to create some code to test them. All right, so what you're going to have to do is create a list here that's you're going to feed into these functions so they can do what they do. So I'll create a list here called sample list. And let's just go, with this and some numbers, blah, blah, blah. And obviously that has duplication. And then let's do a list that has no duplication. That looks like duplication. Okay, no duplication on that list. And we're going to run both of these through. Of course, when I run the sample list through, it should be a true. When I run the other list through unduped, it should be a false. And when I say run through, I'm going to run these through the dupe exist function. And of course, the dupe exist is going to call manual count. And it's going to call manual count in the process. And so let's say I call dupe exist down here. The flow of things is that it's going to come up here, run this code. It's going to get to manual count, jump up here, and run through all this stuff, and then return back what the return value was, and then dupe exist will continue and then return back to down here. Hope you followed that. If you didn't, you can rewind. Press rewind if I haven't blown your mind. That's EPMD, I think. Or actually, I think it's Redman. Redman, yeah. Check out Redman's first album. I believe that quote is in there. Okay. Yep, I'm a fan of early 90s hip-hop. Really all 90s hip-hop. Well, not all of it, but the good 90s hip-hop. No Puff Daddy up in here in my playlist. Or Mace. Or Will Smith, for that matter. The shiny suit era. Okay. Enough of that. I'm going to call the dupe exist function. See what we got here? We can talk we can talk 90s hip hop, we can talk coding, Hit me up and text me who is your favorite 90s hip hop artist or group. I don't know if I have a favorite. Anyway, I'm going to supply a sample list to this one. And it's going to be a true, because there's duplication in this list. And if I supply unduped, it's gonna be a false, because there is no duplication. Alrighty, there we go. Now we move on to the next algorithm. Let us now dig into the algorithm for swapping variable values. This is a classic one right here. I guess these are all classics, which is why they're here in this text, prepared by yours truly. Slow jams, my friends. Okay. Swap variable values. Given two values A and B, you may have the need to swap or exchange values. Putting the contents of variable A into variable B, and then putting contents of variable B into variable A. A classic way to do this is to use a third variable to facilitate the swapping. So, let us look at this idea. Let's just think independent of the code right now. Let's say you got two variables A and B, and they've got values in them. You want to swap the values. Like, let's say A is 5, and we'll just use what's actually here, and B is 10. What if you want to put 10 into A and 5 into B? You want to swap the values. A natural thing would be to do something like this, like say, A equals B, but that doesn't work, because if you do this, A equals B, it's going to be A will be equal to 10 and B will be equal to 10. They will both have the same value, and then you will have lost the value of 5. So this ain't going to work. You can't just do a direct copy, because they're both going to have the same value, and you're going to lose one of your values. So you don't want to do that. What you actually have to do to be able to swap these two values is that you have to use a third value, or not a third value, a third container, a third variable, to hold one value off to the side while you proceed to do your copying. Here's how it works, folks. So, didn't mean to get rid of all of that. So I'm going to bring some of that back. Oh. Good stuff. Yeah, let's get rid of this. Here's how it works. We're going to create a temp variable. I'll just call it T here for abbreviation. And what we're going to do is we're going to make that temp variable, give it the value of A, because we're going to hold it off to the side. So temp equals A. So inside of temp, it's going to really be the value of 5 inside of temp, because 5 is inside A, and then that value is going to be transferred to T, to temp. So after the first step, temp is going to contain 5. And then what we can do, now that we have the first value saved away, we can now make A equal to B. And on this step, A is equal to B, so A becomes 10 and B is still 10. So at this point, we're going to have A equal to 10 and B equal to 10, because this assignment has made A and B both 10 because they're equal to each other. There's one last step. What I'm going to do now is I'm going to take B and make it equal to the previous value of A, which the previous value of A was 5. What I do here, it's not going to be B equals A because A is 10, so that's not going to work. What I'm going to do is make B equal to temp, because temp had that value, has the old value of A. So what happens here is that, and this is the end of the algorithm, what happens here once this is done is that temp, of course, is still going to be 5, but now A is 10 because of that middle step, and B is now 5 because it was copied from temp. So here is your ending values, and notice that A is now 10, B is 5, and that is a swap from the original. See? There you go, folks. A was 5, and now it's 10. B was 10, and now it is 5. There is how you do your swap. You need that third variable to be able to do it, and these are classic swapping algorithm. Okay. If you need to hear it again, rewind. Yeah, I don't know if you really call it rewinding in the case of digital, but whatever. There ain't no tape, no 2-inch tape right here. All right, let's look at this code. Rambled long enough. A equals 5, B equals 10, and if you print those two, you're going to have 5, 10. Here is the algorithm in code that I just went over graphically, very graphically, right? So I make temp equal to A, that saves the value of A. Then I make A equal to B. This is really making both of them the same value. And then I make B equal to temp, giving it the previous value of A. So it's kind of cool how this works. And then, you know, it'll print the swapped values now. Yeah. So I'm gonna just grab this and run it because I think it's cool for y'all to see the magic of swapping, the magic of algorithms. And yeah, going back to the definition of algorithms, it's a systematic, step-by-step routine that'll produce a certain result. Yeah, you plug any two variables into this algorithm, any two variable values, they're going to produce the result. They're going to get swapped, you know, no matter what the inputs are. All right, let's do this. So on the first, let's do a turn this into an F string. Let's do, because I want to do like before and after. So I'm gonna go away from the commas and use the F string style of presentation. I'll do the main accent after. So I'm up here in the frozen north. Although in the frozen north it's going to be 90 today. It'd be funny if you guys are watching this in winter time or something like that. We'd be talking about 90. Wishful thinking, right? Whatever. Okay. Before and after. Yep. So yeah, both of these we have A and B. You see afterwards the values are swapped. Magic of programming, folks. The dopeness. The dopeness. Okay. And let me just pull this up again just to, you guys can take a quick look. And I'll, go now into the problem portion. Alrighty, folks, so here's the problem that we're going to solve with this swapping thing. Given a list and two indexes, swap the values at those indexes. So here's a practical issue that we're going to be given using a swap, where we're going to take a list and we're going to swap two elements of that list using the swap algorithm, and the elements are going to be specified by the indexes of those elements. And what we do here is we create a function where you supply the indexes or the indices of the two things to swap, and you supply the list that they're coming from, and we're doing the swap algorithm on indices or indexes rather than on individual items like we did before. Notice that temp is going to be the element at A, and then the element at A will equal the element at B, and then the element at B, at index B, will equal temp. So then we do this down here. We have a list here. We call index swap with 1, index 1, and index 4. So it's going to swap the 2 and the 5. And then, as you see there, it's going to do that swapping. Let's get this one into PyCharm. Notice how PyCharm nicely puts the little hints there. I actually don't like them myself, but these are not part of the code. The code is really 1, 4, L. L being the list. So it is going to swap 2 and 5 from this list and give you that. Let's get it, let's go. So yeah, it goes from 1, 2, 3, 4, 5, 6 to this. And just for the heck of it, we are going to, I'm going to swap 2 other indices. Let's do, say, index 3 and index 6. Is there an index 6? 1, 2, yeah, of course there's a 0, 1, 2, 3, 4. No, there isn't. We'll do 3 and 5. It's amazing, yeah, zero-based indexing still trips me up at this advanced stage of my programming. 0, 1, 2, 3, 4, 5. So the 4 and the 6 will be swapped on this one. Yeah, see, 6 and 4 get swapped. There we are, folks. Swapping algorithm applied to another function where we're swapping items in a list. This is a pretty cool one. I think this is pretty damn cool. Hopefully you do too. All right, let's move on to the next one. I think this, no, it's not the last one. It's the next one. Remove all occurrences of a value from a list. The remove function in Python is going to remove only the first instance of a value from a list. So yeah, when you call the remove function, it only removes the first one. Here's a function that's going to remove all occurrences. So it's going to expand on that, just removing one. It's going to remove all via some code that I've created here to do really looping, and it's going to remove them all. So I have a function called remove all, and you supply a list and the value to remove, and we do a beautiful while loop. While value in list. So this is a key here. You see a while loop is while and then condition. The condition here says as long as the value I'm looking for is in the list. And I don't know if you've seen this one before. I don't know if I covered it. I don't think I did cover it at all yet. There is a keyword in that you can use in conditions where it's essentially a search in a structure. Like, let's say value is 5. I can search for the 5 in a certain list by using this Boolean expression. I could do if value in list, which means it's going to return a true or false. And if I do while value in list, it's going to do that Boolean expression every time it checks. And if that value is still in the list, it's going to return true. And we know through the usage of while is that it is going to loop while the condition is true. So while the value that I'm looking for is still in the list, I'm going to keep looping. And what I'm going to do in the loop is that I'm going to remove that value, the next occurrence of it, every single time. That's how it works here. So let's say a value is 5. While 5 is in the list, I'm going to remove 5, and then I'm going to loop back around again, and then I'm going to check and see if it's in the list. If 5 is still on the list, I'm going to remove the next one, then go back. And I'm going to remove the next one and go back. We're going to kill all the occurrences of that sucker while it is still in the list. I like this code as well. You can tell that I'm fired up here. My deadpan is kind of slowly leaving. So good stuff. All right, here's a problem, folks. Remove NA values from a data set of names. This is a very simplified look at a problem in data science, where you may have a set of values, many times a set of string values or numbers actually, where you've got if you've got bad values in the list, like NA values, you want to remove them. So this code, this function up here, is going to go through and kill all those NAs. That's what it's going to do. And let us do it. Get my function. Get yourself a gun. Oh my goodness. Yeah, I know there's a more efficient way to solve this, folks. But I'm not going to find out what it is live. It's live for me, it's not live for you, right? I'm doing this in real time while y'all sitting back. This is what you paid for, right? To watch me overwrite. And no, I'm not editing this stuff out. This is the process. Like, I wanted to have videos like this where I'm doing like one take and it's just free flowing and it's real. It's kind of like you're in a session with me, right? So there's a million of those polished videos where you do all the cuts and all the polished stuff. That ain't me. I want to be a little different. Got to bring uniqueness to the thing. All right. Enough about me. Let's run this code, homies. So, actually, yeah, I call remove all, but I need to print the list afterwards. And I'll do a before and after, I guess. Yeah. This would be after, though. I would print the data set because that's the list. And F got to go before. Incorrect English, yeah. And then I'll do a before right here. I almost did print F like I'm using C. It's a coding party here, folks. Before, after. Yeah, just give me before and after the changes. All right, let's check it out. Check it out, check it out. Got that. You see the NAs, now the NAs are gone. This thing is dope. It's gonna loop through, remove, while the value is still on the list. And see, we're using this on strings. This function could be used on numbers, strings, floats. So it is it's more I don't know what the word is, adaptable, I guess. Yeah. All right, let's keep this moving. See how many we got left here. All right, we got one set left. Next, we will look at the determination of maximum and minimum values in a list. Saving the best for last here, folks. Back to my deadpan. Okay, determining maximum and minimum values of a set of numbers is an often necessary operation. It is such a common need that functions already exist to do this in Python, but it's important to understand how those functions may be derived. And yeah, here's some code to find the maximum value in a list, but before we look at this code, I'm going to detail this idea for you because you need to kind of have the background before you look at the code. It's going to be way, way easier. So I'm going to create a set of numbers. All right. Of course, you gotta have the list notation. So let's say we got these numbers in a list. And how do we, with an algorithm, find the maximum value in this list? Well, it's really by doing a linear look at each value and comparing that value to what we've already determined to be the max. Now, when I say what we've already determined to be the max, how that works is that before we even look at the list, we create a variable called max, and of course you can call the variable whatever you want, but this variable is going to hold the max value. Let's create a variable max, and what you do here is you just make it equal to the first element of the list. And here the first element of the list is 1. And what we do is, from here, we go through the list one by one and compare every value to our max. And if that value is larger than what we've determined or what we've set the max to be, then max is going to assume that value. So the way it works is that it's going to continually assume the larger or the largest value, and by the time it gets to the end of the list, it's going to have the largest value. Here's how it works. So we take max and set it to whatever the value of the first element is. Here we set it to 1, and so we just compare it to every value. So let's compare max to 1. It is 1, so it's not 1 is not larger than it. So we move on. 3. Is 3 larger than 1? Yes, it is. So what happens here is that max, it becomes 3. Now max is 3. And we move on to the next one. Is 0 greater than max? No. Is 7 greater than max? It is. So then now max becomes 7. And then we move on to the next one. Is 9 greater than max? Max is 7, so it is. Now max is 9. See, we've gone from 1 to 3, 7 to 9. And now we move on. Is 6 greater than max? It's not. Is 8 greater than max? It's not. There is our maximum number. 9. And there we go. And so that's how you find the max in a linear fashion. Finding the minimum is exactly the same process-wise, but we can do a different comparison where we see if the element is less than our current. And if the element is less than our current, then we will assume that value with our variable. And this one would usually be called min if we're looking for the min. And it would be like, is 1 less than it? Is 3 less than it? Whatever numbers are less than it, it will assume that value. So that's how max and min work. Let's look at the code. Looking at the code we take in a list, and like I said, we make the first value of the list. Max is going to be that. It's just arbitrary. It's got to be, you make it equal to one of the values, and then it's just going to assume whichever values in the list are larger. It's just kind of arbitrary to do it this way. And then we loop, and if the current element is greater than max, then max is going to assume that. Like if 3 is greater than 1, then max is going to be 3. If 7 is greater than 3, then max is going to be 7. Then we just return max at the end, because it's going to have the largest value. There we go, folks. And here's the code to find the minimum, and there aren't many differences. The difference is that we use the name min, and then we use a different comparison operator. We see if the current element is less than min. Here we see if the current element is greater. So because we're looking for lower numbers down here, we see if the value is less than. And if the value is less than, then it's going to assume that. So these two algorithms are very similar. The difference really is the sign, the comparison operator. Yeah. Okay. I'm running up against an appointment. This is a long freaking video, but I'm glad you hung in here with me, folks. There's some good stuff in here, though. You've seen it. Y'all seen it? Okay. So here's the next problem. This is going to be a good one. Remove all occurrences of the maximum value from a data set. So this is actually going to be using the last two functions that we've created. We're going to use find max, and we're going to use remove all. So it's going to be cool. So we do this line to find the maximum of some list. The some list being right here. Then we remove all the occurrences of that value from the list. Then we print the list. See how that works? Find max is going to find the max, and then remove all that we went over a few minutes ago is going to remove all of the maxes. Remove all occurrences of the maximum value from a data set. And so looking at this data set, we got, what's the max value? It's probably 67. Yeah. So it's going to remove all the 67s from this list. Excited to get this one into code. Let's go. Into PyCharm. Probably when I say code, you're thinking of Visual Studio Code. I don't use that one much anymore. It's kind of weird, kind of clunky. I know that's hot these days, but it's a little clunky, homie. Anyway. All right. So I got find max and remove all because I'm using both. And then we have our list here. And let's do the before and after joint. Before, and I'll do a F string here. Always got to do that morning throat clearing. Blah. Yeah. So let's do it. All right. Here you see the output, or you see it down there. We got our 67s up here, and now they gone. He gone, like Ken Hawk Harrelson will say. Harrelson, yeah. Anybody watch White Sox baseball? He gone. All right. All right, that is that. And yeah, so I'm using 2 of these in tandem, so good stuff. I think you guys saw some cool stuff in this module, the longest module thus far. Maybe I'll break it up, maybe I won't, I'm not sure. But I was talking about he gone, now I'm gone. So I'll see y'all in the next module, and you'll see me. I am out. Out.